we are going to use Kali Linux operating system. Before we dive into the practicals, let me briefly explain what Kali Linux is. Kali Linux is an operating system that is specifically built for penetration testing and cybersecurity tasks. It is widely used for ethical hacking and cybersecurity tasks such as penetration testing, security research, computer forensic, and reverse engineering. It has more than 300 pre-installed hacking and forensic tools. Before we start using all the fancy tools, we need to learn the fundamentals of its command line. Now let's dive into the practicals. If you have not installed Kali Linux yet, I have covered the installation process in a separate video on my channel. Please watch that video first. Now, first thing that we need to do is open the terminal. There are multiple ways to open the terminal. The easiest among all is press Ctrl plus Alt plus T together and it should open up the terminal. This is the terminal, or you can click on the applications icon or menu and in the search box type terminal, click on terminal emulator. Or you can directly click on the terminals icon at the taskbar. Here it is, click on it and it will definitely open up the terminal. Now before executing any commands, I'm gonna change the font size. As you can see, the fonts are barely visible. So go to the file, click on preferences, click on appearance tab and click on the change button and click on up arrow to increase the font size. I'm gonna set it to 13. 13 works for me. Click on OK. Click on OK. As you can see now, we have a much more readable font size. When we open the terminal, we are presented with these two names separated by this symbol. Now this symbol can be anything. It is just a separator which separates these two names. Now name on your left side is the user name who is currently logged in. So type whoami command, press enter. Whoami command displays the currently logged in user. So the current logged in user is Demalu. It means Demalu is using the system. Name on your right side is the host name or your system name. Type host name command. It displays the host name. Press enter. Now type clear. Clear command, as the name suggests, it clears the terminal. Press enter. Now next command that I'm gonna type is date. Date prints the current date and time. Press enter. As you can see, this is the current date. I'm recording this video on this date. Now type pwd. Pwd stands for present working directory. It displays your present working directory where you are in your file system. Press enter. As you can see, my current working directory is Demalu. Demalu is the home directory for the user Demalu. And we also have this $ symbol, right? It also has a meaning. The $ essentially represents the regular or normal users. In Linux, there are two types of users, root user and regular users. The $ represents the regular users. For now, you don't have to worry about users. We will get back to users in a dedicated section. The currently logged in user, which is Demalu, is also a regular user. Now, before wrapping up this video, let me execute history command. The history command displays all the commands that you have executed previously. Press enter. As you can see, this is the list of commands that have been executed on this freshly installed Kali Linux machine. ls is an essential Linux command. ls stands for list or listing. As the name suggests, it is used to list or display files and directories. You can view or check the contents of a specific directory or multiple directories with ls command. Now let's dive into the practicals. So type ls, press enter. By default, the ls command displays all the files and directories in your current working directory. So these are the files and directories in my current working directory, which is home. And here we have two colors, right? The blue color and white color. The blue color represents directories and the white color represents files. The white color essentially represents all file types, whether it is .sh file or .txt file, mp4 files, pdf files. All file types are represented by the white color in Kali Linux. Now the default ls command does not display the hidden files and directories. So if you want to list hidden content, then type ls space -a. -a parameter allows us to display or list all the files and directories, including the hidden files and directories. Press enter. As you can see, guys, we have files and directories that have dot at the beginning. The files and directories that have dot at the beginning, they are the hidden ones. Now let me execute ls again. As you can see, the default ls command displays contents of current working directory. Now I only want to list contents of a specific directory. Let's say I only want to see what is inside the desktop directory. Then type ls. Now specify name of the directory whose content you want to check. Desktop. So this time I am telling ls command that only list contents of this specified directory. It will display what is inside this specified directory desktop. Press enter. As you can see, this time it is only listing contents of the desktop. Similarly, we can list contents of multiple directories as well. Just separate the directories with a space. Let's say etc. And this time ls command is going to list contents of desktop and the etc directory. Press enter. As you can see, this is the contents of desktop and this is the contents of etc directory. In this way you can basically list contents of as many directories as you like. Just separate those directories with a space like this. This time it is gonna list contents of these three specified directories. Press enter. As you can see, guys, now the default ls command, as you can see, only displays the file and directory names, right? However, sometimes we want more details such as file size, last modified date, etc. So type ls space -l. -l stands for long listing. It gives us a detailed information about the files and directories. Press enter. And first field from the right displays the directory or file name. Then we have this date and time, right? Now this date and time automatically get updated when you modify a file or directory. In the context of a file, when you modify or edit a file, then this date and time get updated automatically. And in the context of a directory, when you add a new directory or file to a directory, then this date and time get updated. Or if you modify a file within a directory, then the date and time of that particular directory also get updated. Now next field that we have is this. It displays the file size in bytes, which is not very readable to us. So if you want a more readable format for displaying file and directory size, then ls -l and -h. -h stands for human readable. Press enter. As you can see, now we have file size in kilobytes, megabytes and gigabytes. -H essentially displays file size in kilobytes, gigabytes and megabytes. And you don't have to, write the -H parameter separately. You can simply combine it with -L or other parameters. Press enter. As you can see, it is producing the same result. CD stands for change directory. It is a simple command. As the name tells you, CD allows us to navigate in our file system. So if you want to change directory or location, then we have to use the CD command. So open your terminal. Let me type ls and execute pwd as well. Now my current working directory is home. I'm in my home directory, right? Now let's say I want to switch or change my directory from current working directory to desktop. Then type cd space. Now specify the exact directory name where you want to switch desktop. Press enter. pwd. As you can see, guys, my current working directory has been changed to the desktop. Now if you want to go one directory back, then type cd space 2 dots. It takes us one directory back in our file system. Press enter. pwd. As you can see, similarly you can go multiple directories back with cd command. Type cd space 2 dots / 2 dots again. It will take us 2 directories back. Press enter. pwd. As you can see, and you can go as many directories back as you like with cd command. Just separate 2 dots with /, then it takes us that many directories back. Now what happens if you don't specify any directory name to the cd command, right? My current working directory is desktop. Now if I type only cd command and don't provide any directory name, then the cd command by default redirects us to the home directory. So press enter. pwd. As you can see, the current working directory has been changed from desktop to home. Sometimes we unintentionally or mistakenly execute the cd command, which eventually redirects us to the home directory. So if you want to go to your previous working directory, then type cd space and hyphen. It will take me to my previous working directory, which was desktop. So press enter. As you can see, guys, my directory has been changed to my previous working directory, which is desktop. In this video, we will learn how to create and modify text files using the Nano text editor. Nano is a terminal-based text editor that allows us to create, open and modify text files directly within the terminal. It is an easy to use and lightweight tool that offers features such as syntax highlighting, line numbering, search and replace, copy, cut and paste, among others. In this video, we will cover the fundamentals of Nano. Now, Nano is a tool that you will be using on a daily basis. Now, let's jump into the practicals. Type Nano and press enter. We are inside the Nano text editor. Now Nano is absolutely ready to take the inputs. So let me type a few random text lines. Let's say this is in line number 1. Now press enter for a new line. This is a new line. Press enter again. Third line. And at the bottom, these are the options that we can use with the Nano. First option that we have is Control G. Control plus G is for help. It displays the documentation for Nano in detail. So press Control plus G together, and here we have the detailed information about the Nano. Here we have the description for nano, what it is and what it does. Now press the down arrow key to scroll through the entire documentation. Here these are the options that we can use with nano. So guys, feel free to go through this lengthy documentation. Now to exit out of this documentation, press Q. Then we have Control O. Control O is for write out. Write out simply means saving the content to a file. I have not saved these lines into a file yet. So to save, press Ctrl plus O. Now here, as you can see, file name to write. Specify the file name where you want to save this content. Let me give, let's say, file name dummy.txt. Remember guys, by default the nano saves the file in your current working directory. My current working directory is desktop, so this dummy.txt file will be saved in my desktop. Now press enter. As you can see, wrote 4 lines at the top. Here we have the dummy.txt file where the content has been saved. Now to exit out of nano, press Ctrl plus X. Let me ls to check whether the file has been created or not. As you can see guys, dummy.txt file has been created. Now I want to edit or modify this dummy.txt file using nano. Type nano dummy.txt, provide the file name, press enter. Now we have opened the dummy.txt file successfully. Now we can, modify this file however we like. So guys, that's how you can create, save and modify contents of text files using nano text editor. Now before wrapping up this video, let me show you one trick that you can use for saving time. We can create the file at the beginning when we start nano. All you need to do is type nano and specify the file name, new file.txt. Remember, the way nano works, if the file name that you specify, if it already exists, then it will open the existing file, and if the file does not exist, then nano will create the file. Press enter. As you can see, new file.txt has been created. Now we can write content to it. Press enter for new line. Press Ctrl O for saving the contents to the file. Press Ctrl plus X to exit out of nano. ls. As you can see, new file .txt has been created. In this video, we will take a look at the cat command. I can assure you that you will be using it on a daily basis. It is among the core commands of Linux. So what does the cat command do? The cat command is a versatile multi-purpose command that can be used for a variety of tasks, such as creating text files, viewing the content of files, appending text to existing files, etc. The cat stands for concatenation. This is the first video on the cat command. In this video, we will learn how to view the contents of a file and print line numbers as well. Now let's jump into the practicals. Let me ls. I have these 2 files in my desktop and I want to view contents of let's say this dummy.txt file. So type cat and space. Now specify the file name whose content you want to view or print. I'm gonna go with dummy.txt. So I'm telling cat that display or print the contents of this specified file. Let me press enter. As you can see guys, this is the contents of this dummy.txt file. Now one thing that is missing is the line numbers. Cat command does allow us to print line numbers as well, which is a very convenient feature. So type cat, let's say dummy.txt and space -n. it prints the line numbers, as you can see guys. Now we have a very well formatted output. And we have 6 line numbers, right? This is because these two are the blank lines. Blank lines also get counted. The cat command also allows us to view contents of multiple files. All you have to do is tell the cat command those file names. Let's say cat space dummy.txt, now space d1.txt. So you have to separate the file names with a space. And this time cat command is gonna print contents of dummy.txt file and d1.txt file. Let me press enter. As you can see guys, this is the contents of first file, and this is the contents of d1.txt file. In this way you can view contents of as many files as you like. Just separate file names with a space, then it will print contents of all the specified files. Now I'm gonna print contents of a file which is located in another directory, right? The d1 and dummy.txt, these files are in my current working directory. I want to print contents of a file which is inside etc directory. The file name is passwd. Now the passwd file stores user account details. All the user accounts details are stored inside this passwd file. Press enter. As you can see guys, these are the user accounts in my Linux system. I will get back to this passwd file in a dedicated video. We will continue where we left off in the previous video. In this video, we will learn how to create files and append contents to existing files using the cat command. We will also learn how to concatenate multiple files into one. Now let's jump into the practicals. To create a file using cat, type cat. Now type the greater than symbol and specify the file name that you want to create. Let me create dummy.txt. Press enter. As you can notice, we have this cursor. It is essentially waiting for us to input something. Let me input a few random text line. This is a text line. Press enter for a new line. Line number 2. Now to exit out of the cat, press Ctrl plus C. Let me ls. As you can see, the file has been created. Let's check its contents, and these are the exact lines that we wrote inside the dummy.txt file. The cat command works pretty much like the output redirection operator. It overrides the contents of existing file. The way the cat command works, if the file doesn't exist, then it creates that file first and writes content to it. And if the file already exists, then it removes contents of that existing file and only keep or save the new content that you write to it. For example, I already have this file called dummy.txt. So if I write contents to this dummy.txt file, then cat will remove the contents of this existing file and only keep the new content that you write to it. So let me write, let's say this is a dummy file, press enter. Let me exit out of the cat, ls, and let's check its contents. As you can see, the existing content has been overwritten or removed. It only kept the new content. So if you want to keep the existing content and append new content at the end, then we have to use two greater than signs like this. Now specify the file name dummy.txt, press enter, line number 2, press enter, line 3. Now what the cat command will do is it will keep the existing content and the new content will be appended at the end of the file because we are using two greater than signs. Let me exit out of the cat ls cat dummy.txt. As you can see, the existing content is still there and new content has been appended at the end of the file. So guys, that's how you can avoid content overwriting. Now let's learn how to concatenate multiple files into one. Let me change my directory to desktop where I already have the multiple files. I have these two files. Let me first check their contents. This is the contents of d1.txt and this is the contents of dummy.txt. I want to merge contents of both of these files into one, which is very easy. Type cat and specify the file name. So let's say d1.txt. Now write the greater than sign, then specify the file name where you want to merge the contents. So what the cat command is gonna do, it will take the contents of the files that you specify before the greater than sign, then merge contents of these two files into this specified file merged.txt. Press enter. ls, the file merged.txt has been created. As you can see, let me get out its contents and this is the contents of merge.txt file. Remember, when you merge the contents with cat, it doesn't remove or alter the contents of the files. It only takes the contents of those files, then save that into the file where you merge it. In this video, we will learn how to create directories or folders in Linux. Basically, folders are called directories in Linux. Now let's jump into the practicals. Type make dir. Make dir is short for make directory. Now you have to specify the directory name that you want to create. Let me create, let's say, dummy. So I am basically telling the make directory command to create this dummy directory. That's as simple as that. Press enter. ls, as you can see, dummy directory has been created. Now let's create multiple directories with a single make dir command. Type make dir d1 space d2. This time make dir command will create these two directories. Just separate the directory names with a space. Let me press enter. ls, as you can see, d2 and d1 directories have been created. Now what I want is to create a directory within a directory. I want to create a tree of directories. For example, I want to create a directory called Sunny, and inside Sunny I want to create subdirectory called Dimalu. So type make dir sunny/dimalu, press enter, and we have an error, can't create directory, because if you want to create a directory within a directory, then we have to specify -p option. -p stands for parent. It creates a directory within a directory. So if I press enter this time ls, as you can see, the Sunny directory has been created. Let's check its contents. As you can see, inside the Sunny we have the Dimalu directory. So guys, that's it for this quick video. Thank you very much for watching. Welcome back everyone. This is the first practical video on the grep command. In this video, we will learn what grep is and the fundamentals of grep. Grep stands for Global Regular Expression Print. Now, what does the grep do? The grep command is heavily used for searching text or text patterns in files. Let's say you have a large text file and you want to know if a particular word exists within the file or how many times it is there in the file. Then the grep command solves this problem very efficiently and easily. It makes searching through files very easy. Use cases of grep command are vast. It can be used for formatting output, searching patterns, and analyzing logs efficiently. Now let's jump into the practicals. Let me switch my directory to the desktop. Now we are gonna need a file to work with where we can perform the grep searches. So what I'm gonna do is redirect the manual page of user add command to a file. This is the documentation for user add. I'm gonna redirect or save it into a file. Press Q to exit out of the documentation. Now type man user add, type output redirection operator, specify the file name where you want to save the manual page, out.txt. Press enter, ls. The file has been created. Let me quickly check its contents with -n option. Press enter. As you can see, in this file we have almost 500 lines. These are enough lines to demonstrate the grep command efficiently. Now back to the grep. So type grep. First thing that I'm gonna do is check the available options that we can use with grep. So help option is gonna display all the available options that can be used with grep. Press enter. So these are the options that we can use with the grep command. So feel free to go through all these options. Grep is actually a very advanced command. So type grep space. Now grep needs minimum 2 options. The search term, what you want to search for, and the file name where you want to search. So provide the search term or pattern. I'm going to search for the word user. Write the search term within quotes, space. Now specify the file name where you want to search, out.txt. So I am basically telling the grep command search for the word user in this specified file, out.txt. Press enter. As you can see guys, grep has printed all the lines that contain the searched term user, right? The searched term or match is being highlighted with the red color. So by default, it is gonna print all the lines that contain the searched term. Now, one thing which is missing here is the line numbers. I exactly don't know in which lines the grep has found the match. So to print the line numbers, we have to use -n option. So type grep -n, and search term is again gonna be user, file name out.txt. So this time grep is going to print the lines wherever it finds the word user. If I hit enter, as you can see on the left side, it is exactly telling us the line numbers wherever it found the match. Now the search that I conducted was in this file out.txt, which is in my current working directory. Now we can also search in a file which is located in another directory. I'm going to search for the word dimalu in the file which is located inside etc directory passwd. So what basically is going to happen this time, grep command is going to search for the word dimalu in this specified location. Location is etc directory. Inside etc directory we have a file called passwd. Now passwd file essentially stores information of all the user accounts on your system. So it will check whether the user account dimalu exists or not. I will get back to passwd file in a dedicated video. So press enter. As you can see, it did find the word dimalu or user account dimalu in this passwd file. It means the user account dimalu does exist. Now what happens if the grep does not find the match, or you provide a pattern that doesn't exist. In that case, Grep doesn't provide any output. So that's pretty much it for this video, guys. Thank you very much for watching. In this video, we will explore the WC command. It is a simple and useful tool. WC stands for word count. As the name suggests, WC counts the total number of words, lines, and characters in a given file. Now let's jump into the practicals. I have this file called out.txt. I want to count or check how many words, characters, and lines are in this particular file. So type WC space. Now specify the file name where you want to perform counting in. Out.txt. Now press enter. As you can see, we have some interesting details. First field from the right displays the file name. Then next field displays the total characters, and this field displays the total words, and first field from the left displays the total lines. Now I only want to print the total number of words. So type WC -w, and -w only prints the total words. As you can see, the total words in the file out.txt are 2008-31. Similarly, you can print only lines WCL, and if you want to print the total letters or characters, then specify -c. -c counts how many characters are in the specified file, as you can see. Now let me demonstrate the WC with a real world example. Let's say I want to check how many user accounts are on my system. Then WC -l etc passwd. Now it will count how many lines are in the passwd file. Press enter. As you can see, there are total 59 lines, which means there are total 59 user accounts in my system. So that's it for WC command, guys. Thank you very much for watching. In this video, we are gonna learn about output redirection. Output redirection is a fundamental concept in the Linux command line that allows us to control the output of a command or program. In simple terms, it means taking the output of a command and redirecting or saving it to a file. When you execute a command in the terminal, by default, the output of that command is typically displayed in the terminal. However, with output redirection, you can save the output to a file. There are many situations where you might need to save the output of a command to a file instead of displaying it in the terminal, such as analyzing the output later, filtering, or processing the output with other tools, etc. So let me practically demonstrate what I just explained. Let me execute the ls command. This is the output of ls command, right? Now, output redirection allows us to redirect or save output that a command produces to a file. This is exactly what I'm gonna do. I will take this output of ls command, then redirect or save it to a file. The syntax is very simple. Type the command whose output you want to redirect. I'm gonna go with the ls command. Now type the greater than sign. The greater than symbol is also known as the output redirection operator. Now specify the file name where you want to save the output. Out.txt. Now the way output redirection works, if the file name that you specify does not exist, then it will create the file first, then redirect output to it. And if the file already exists, then it will redirect or save the output to the existing file. Let me hit enter. and this time we did not get any output. This is because by default Linux sends output of a command to the terminal. However, this time we used the output redirection operator, so the output was sent to this out.txt file, not to the terminal. Now let me ls. As you can see, the out.txt file has been created. Now let's check its contents. Cat out.txt. As you can see guys, inside out.txt file we have this content. This is the output of this ls command. This is exactly what we redirected to this out.txt file. This is as simple as that. Now let's do a few more examples. Let me execute a date command. This is the output of date command. Now let's redirect the output of date command to a file. Type date output redirection operator date.txt. This time output redirection operator is gonna take output of date command, then redirect it to this date.txt file. Let me hit enter. ls. The date.txt file has been created. Let's get out its contents. As you can see guys, inside date.txt file we have the output of date command. So similarly you can redirect output of any command to a file using the output redirection operator. Now you have to be a bit careful when redirecting output of a command to a file, because the output redirection operator overrides or removes the contents of an existing file. For example, this date.txt file already has some content, right? Now if you redirect output of another command to this date.txt file, then it will remove or overwrite the existing content and only keep the new content. Let me actually show you what I mean. This time what I'm gonna do is redirect the output of ls command to the date.txt file. Now the date.txt file already exists, right? It has already some contents inside it. Now this time the output redirection operator is going to redirect the output of this ls command to the date.txt command and only keep the new content or output of this ls command. Let me press enter. Let's check the contents of date command. As you can see guys, the old or existing content has been removed. We only have the new content that we redirected it with the most recent command, which is ls. Now if you want to maintain or keep the existing content of a file, then we have to use the two output redirection operators. So let me redirect output of date command. This time use two output redirection operators like this, date.txt. Now when you use two output redirection operators, the output gets appended at the end of the file. So what it is gonna do, it will take the output of date command, then append or add it at the end of this specified file. Press enter. Let's get out contents of date.txt file. As you can see guys, this is the existing content. It is still there, it has not been overwritten, and the output of the previous command date has been appended at the end. That's how guys you can use the output redirection operator and avoid content overwriting. In this video we are gonna cover pipes, also known as piping. Piping is an essential part of the Linux command line. So what exactly is piping? In simpler terms, piping is the process of sending the output of one command to another. Piping combines two or more commands by sharing data between them. This is done using the pipe character between the two commands. Now why do we need to send output of one command to another or share data between them? Well, sometimes we have to use multiple commands or tools to complete complex tasks. So when you use different commands separately to get a single task done, it is a time-consuming process, right? So why not combine multiple commands together instead of executing them separately? This is exactly what piping solves. Piping allows us to combine or connect multiple commands by sharing data or output between them. So instead of using multiple commands separately, we can combine them using piping. When one command sends its output to another command, the receiving command processes that output as its input. This essentially means that the output of one command becomes the input for the next command or the receiving command. Now let's jump into the practicals. Here I have this out.txt file. Let me cat out its contents. This is the output of this cat command, right? Now piping allows us to pipe or send output of one command to another. This is exactly what I'm gonna do. I will send this output of cat command to the grep command. Grep command will further process this output. Let me type the complete command. So type cat out.txt. Now type the pipe character. This is the pipe character. This pipe character is typically above the enter key. Now let me type the grep command. I'm going to search for the word user and let me open another terminal. I'm going to need it for a smooth explanation. Now let me cat out the contents of out.txt file. Now let me break down this entire command. Now the way it is going to work, since we are using piping, the pipe character, the Linux is going to send the output of this cat command to the grep command. This is the output of cat command, right? Linux will send this output to the grep command. Now grep command will receive this output, then search for the word user in this output or in these text lines. If it finds the word user in any of these lines, then those lines will be printed or displayed. Now if you notice here, I have not specified any file name. The grep command needs minimum two options. The search term, what you want to search, I have specified the search term, but I have not specified the file name where I want to search for this specified word user. This is because the grep is going to search for this word in this output that it receives from this command through piping. Let me press enter. As you can see guys, it has printed all the lines that contain the searched term user. So that's how the piping works. So guys, the output of one command becomes input to another command or the command that is receiving it. Remember, most Linux commands are designed to receive the output through piping. So the output of cat command became input to the grep command, and grep command searched for the word user in the output that it received. This is as simple as that. Now let's do a few more examples. Let me change my directory to home. Let me execute ls command. Now I want to check whether the directory desktop exists or not. Obviously it does exist. We all can see it. It is right there. However, if there are, let's say, hundreds of files and directories, then it becomes a bit hard to locate a specific file or directory. But with piping, we can easily solve such problems. All we have to do is send this output of ls command to the grep command, then search for the whatever file or directory you want. So let me type ls space, type the pipe character. I'm gonna search, type grep. I'm gonna search for the word desktop. So what basically is going to happen? The Linux will send output of ls command. Let me close this terminal. This is not required. I'm gonna open a new terminal. Now what basically is going to happen? The Linux will send the output of this command, which is this, to grep command. Then grep command will search for the word desktop in this output, and if it finds a match, then it will list that line. Press enter. As you can see guys, it did find the word desktop, so the directory desktop does exist. So that's how guys the piping works. You can literally take output of any command, then pipe that to another command. Copying files is a common task that you have to perform on a regular basis, right? The command for copying files and directories is cp. cp stands for copy, and it can copy both files and directories. Now let's jump into the practicals. I'm gonna start with copying files, and later we will copy directories as well. Let me execute ls. I'm gonna use these files to demonstrate the cp command. So type cp. cp stands for copy. Now cp command needs minimum two options: the file name that you want to copy and the destination directory where you want to copy it. So I'm gonna start with copying this dummy.txt file. So specify the name of the file that you want to copy, dummy.txt space. Now specify the destination directory where you want to copy it. I'm gonna copy it in my current working directory, so specify a different name. Let's say dummy cp.txt. Now the copy command is going to take this dummy.txt file and create its copy under this new name dummy cp.txt. Let me press enter. ls. As you can see guys, we have successfully copied dummy.txt file. Here is the copy of dummy.txt file under this new name dummy cp.txt. Similarly, we can copy files to a specific location or different directory. What I'm gonna do is I will copy this dummy.txt file to the downloads. Let me open a new tab, change my directory to the downloads. ls. As you can see, the downloads directory is currently empty. So let's copy dummy.txt to the downloads. Type dummy.txt. Now provide the full path to downloads or wherever you want to copy it. Type home / username, which is Demalu for me, / downloads. Now this time the copy command will take the dummy.txt file and copy it to the specified location, which is downloads. Let me press enter. Now let me ls here. As you can see, the dummy.txt file has been copied to the downloads. So that's how guys you can copy files with cp command. We can also give a different name while copying. Type / let's say dummy cp.txt. This time the cp command is going to copy this file to the downloads directory under this new name dumcp.txt. Press enter. As you can see, we have the file dumcp.txt. Now let's copy directories. ls. I have this demo directory. I'm gonna create a copy of this demo directory. Type cp space demo. Now specify the name of the directory, demo12. So copy command is going to take this demo directory and create its copy under this new name dem12. Let me press enter. As you can see, we have an error, -r not specified. If you want to copy directories, we need to specify -r parameter. By default, copy command expects us to copy files. So if you want to copy directories, then we need to use the -r parameter. So type -r. This time the copy command is going to take this directory, then creates its copy under this new name dem12 in my current working directory. Let me hit enter. Ls, as you can see guys, we have successfully created copy of demo directory under this new name. Now let's copy demo directory to another directory. I'm gonna copy it to the downloads. cp-r demo. Now provide the path where you want to copy it. Home, type the username, downloads. This time copy command is going to take this demo directory and copy it to the specified destination, which is downloads. Let me hit enter. Let me ls here. As you can see guys, the demo directory has been created, right? Now let's copy multiple files or directories with a single cp command. What I'm gonna do is I will copy dem12 and app.c file to the downloads directory. So type cp ap.c space. Now provide name of the file or directory that you want to copy. Let's say dem12. Now provide the destination path home dimalu. Sorry. Now since we are copying a directory along with the file, we need to provide -r parameter. Now the way this command is gonna work, copy command will copy these two specified file and directory to the downloads directory. You can copy any number of files or directories, just separate them with a space like this. Now press enter. Let me go to the downloads ls. As you can see guys, here we have app.c file and dem12 directory. That's how you can copy multiple files and directories with cp command. Just separate the files with a space. In this video, we will learn how to delete files and directories using the rm command. The rm command is short for remove. It is used to delete or remove files and directories. It is a straightforward command with a simple syntax. Now let's jump into the practicals. I'm gonna demonstrate the rm command using these dummy files and directories. So type rm. Rm stands for remove space. Now we need to tell the rm command the file name that you want to remove. We are gonna start with removing files. Later we will remove directories as well. So rm space. Now specify the file name that you want to remove. I'm gonna remove this dummy.txt file which is in my current working directory. So type dummy.txt. So rm command is going to remove this specified file dummy.txt. Press enter. ls, as you can see guys, the file has been removed. Similarly, we can remove multiple files with a single rm command. Type rm space, specify the file names. Let's say app.c space. We need to separate files with a space. appcp.txt, and this time rm command is gonna remove these two specified files. Press enter. ls, as you can see guys, both the specified files have been removed, and this way you can remove as many files as you like. Just separate those files with a space. Now let's remove files that are stored in a different directory. I'm gonna remove files in my downloads directory. Let me change my directory to the downloads. Here I have all these dummy files. So let me go back to my current working directory, which is desktop. So type rm space Now we need to provide the full path to the file or directory that you want to remove. So home, type the username. Now downloads. Now inside downloads, I have this file called dummy.txt. So after the destination directory / then type the name of the file that you want to remove, dummy.txt. So rm command is going to remove this dummy.txt file which is stored in the downloads directory. Press enter. Let me go back to downloads. ls, as you can see guys, the file dummy.txt has been removed. Now let's remove directories. ls, I'm gonna start with removing demo directory. So rm demo, press enter. As you can see, it is a directory. Just like the cp command, we need to specify -r parameter when removing directories. So type rm-r, provide the name of the directory that you want to remove. Press enter. ls, as you can see guys, the directory demo has been removed. Similarly, we can remove directories that are stored in a different location or directory. The syntax is same. Type rm-r, provide the path to the directory that you want to remove. Downloads, in downloads I have directory called demo. So let me type the name of the directory. This time rm command is going to remove the demo directory which is inside the downloads directory. Hit enter. Let me ls, as you can see guys, the demo directory has been removed. Now let's discuss some of the options that can be used with the rm command. Now one of the most commonly used options with rm command is -f. -f stands for force. It basically forcefully removes the files and directories. Now what happens is that there are certain files that you can't remove with the simple rm command. We need to provide -f to remove specific files or directories. Now files that are write protected can't be removed with simple rm command. Now write protected files are those that can't be modified or edited. Let me create one such file. I'm gonna make this demo.txt file as write only. So type chmod. You don't have to worry about the chmod command. We will get back to it in a dedicated section. For now, I just want to create a write protected file just to demonstrate rm command. Chmod user, I'm gonna take away write permission on demo.txt file. Press enter. Now as you can see guys, in the desktop we have this lock sign. It means that this is a write protected file and it can't be modified or edited. Let me ls. Now let me try to remove it with default rm command demo.txt. Press enter. As you can see guys, we have this prompt: remove write protected regular empty file demo.txt. Now here we have to specify n for no. If you don't want to remove, then type n, and if you want to remove, then type yes, or y. Y stands for yes. Now I don't want to remove this demo.txt file yet, so I'm gonna specify n. Press enter. Now if you want to bypass this prompt, then we have to use -f parameter. So type rm-f, specify the file name, and press enter. As you can see guys, this time the rm command did not display this prompt: remove write protected regular file. It directly removed the file. So -f parameter essentially bypasses this prompt and forcefully removes the files or directories. And if you have, let's say, a write protected directory, then you have to specify -r parameter like this, -rf, then specify the write protected directory. Let's say we have a write protected directory demo, then this command is gonna remove this write protected directory and bypass the prompt that rm command typically displays when removing write protected files or directories. So that's it for rm command, guys. Thank you very much for watching. Welcome back, everyone. In this section we will discuss two important aspects of Linux: user management and performing administrative tasks. This is one of the most important sections in this course. Before we dive into root user, sudo command and other advanced topics in upcoming videos, it is essential to understand user types. Linux users have different levels of access and permissions based on their type. Therefore, understanding users and their types is important. In this video, we will explore the different types of users in Linux. So what is a computer user first? A computer user is essentially someone who interacts with a computer system and uses its resources to perform tasks. These tasks include accessing files, running programs, and utilizing all the other features the system offers. In short, anyone who uses a computer for various activities is considered a computer user. Now, Linux is a multi-user operating system. Now, what does multi-user mean? A multi-user operating system allows multiple users to access and use a system simultaneously. This means several user accounts can be logged in at the same time. In a multi-user environment, we can create separate or multiple user accounts. Each user has their own account with a unique username and password. This allows users to log in with their login credentials and access their own files and resources without interfering with each other. Remember, each user in a multi-user operating system has their own files. By default, one user can't access files of other users on the system. Linux automatically manages the resources and security of each user account. Linux, macOS and Windows are all multi-user operating systems. You can create multiple user accounts in each of these systems. In the upcoming videos, you will learn how to create and manage multiple user accounts on Linux practically. Now, there are three types of users in Linux, not only in Linux but in Windows as well. There are three main types of users: regular users, root user, and system users. Let's start with regular users. Regular users in Linux are also known as normal users, standard users, or non-admin users. Regular users have limited system access. They can perform basic standard tasks such as browsing the internet, storing and accessing their data, playing media, and creating files, etc. However, a regular user can't perform any administrative tasks such as installing, uninstalling applications, modifying system settings, accessing or deleting configuration files, and managing system directories and tools. In short, regular users don't have ability or permission to utilize and access files and tools that are specifically designed for performing administrative tasks. Now let's address the real question: why regular user accounts exist? What problems do they solve? As we discussed earlier, regular user accounts have limited privileges or access to a system. This allows users to utilize and access the system without being able to modify system files or other protected administrative files and tools. This limited access helps maintain system security. Organizations, schools, and universities commonly use regular user accounts for this very reason. Let's take an organization as an example. Organizations and corporations often have multiple employees who typically use the same computer system, right? To ensure security and privacy, each user is assigned a unique username and password. Users log in using their credentials. Each user's files are stored separately and one user can't access the files of another user without proper authorization. Regular user accounts, as we have discussed, have limited privileges. This means they can't damage or access system files, nor can they perform administrative tasks. By using regular user accounts, users can benefit from all the essential functionality the system offers without risking accidental or intentional harm to the system through administrative access. They can create their own files, perform office work, but can't access administrative tools. This restriction on accessing only their own files inherently makes regular user accounts more secure. Windows is also a multi-user operating system. You may be familiar with guest accounts. The guest account in Windows is also a regular user account with limited system access. The second type of user is the root user, also known as administrative user. Root will be covered in the next video because it deserves a dedicated video. Now let's discuss system users. System users in Linux as well as in Windows. A system user refers to a user account created for computer system or an application to execute specific tasks or functions. System users are created during the installation of operating system and applications. Some applications use a dedicated system user account to carry out their operations. System users typically run in the background. They are not directly relevant to your day-to-day tasks. We don't interact with them directly, but they are used by specific applications to carry out their operations in the background. These tasks include running daemons or services in the background. Specific applications such as antivirus software also use dedicated system account to scan the system. System users don't have a login shell, meaning they can't log into the system directly. In this video, we will learn about the root user. Root is the most important user on a Linux system. In the previous video, we discussed that regular users can't perform administrative tasks. However, someone eventually needs to perform administrative tasks, right? And that is where the root user comes in. The root is a special user account on Linux. It is essentially the admin or administrative user account on the Linux system. All administrative tasks are performed by the root user account. The root user is also known as the super user. The root user has complete control over the system. It can perform any operation on a system, such as installing or uninstalling applications, accessing, deleting, and modifying any system and configuration files. In short, the root user controls and accesses everything. The root user account is created automatically during the installation of Linux. Each Linux system has the root user by default. In the upcoming video, we will be putting theory into practice. Finally, we will put everything we have learned in the last two videos into practice. In this video, we will learn about the sudo command and how to use it to perform administrative tasks. We will also cover how sudo is related to the root user as well as who is allowed to use the sudo command. This video is going to be very important and probably one of the longest videos in the entire course. So make sure to watch the complete video and don't skip anything. Let's dive into the practicals. In the previous two videos, we learned that a regular user can't perform administrative tasks, right? Now let's actually verify if it is true or not. Now, how can you tell whether you are logged in as a regular user or the root user? Well, a regular user is denoted by the $sign. As you can see, it means that the currently logged in user Demalu is a regular user, and the root user is denoted or represented by the pound symbol. We will get back to it later. Now what I'm gonna do is I will try to install an application which is an administrative task. So type apt install vlc. Don't worry about the apt command, we will get back to it in a dedicated section. Apt is basically used for installing or uninstalling applications. Now let me press enter and see what happens. As you can see guys, we have two errors. The first error says permission denied. It means that the currently logged in user Demalu does not have permission to execute this command. And second error says that are you root? It means that you need to be the root user to execute this command. Only root user is allowed to execute this command. Now there are two primary ways to perform administrative tasks on a Linux system. Either you need to log in as the root user, or you can use the sudo command to perform administrative tasks. Now logging in as root user is not recommended, especially for beginners, because it can be very dangerous. The major problem with logging in as the root user is that the root user executes commands without alerting you or giving any warnings. No matter how dangerous the command is, you are not warned before making system changes or executing commands. This means that you will not have any opportunity to review the changes before they are implemented, which can lead to serious problems. For example, you could accidentally delete essential system files, rendering your system unusable or unstable. For these reasons, it is considered dangerous to log in as root or operate your system as root. Even experienced users avoid logging in as root unless it is absolutely necessary. So what is the safe way to perform administrative tasks? To safely perform administrative tasks, we can use the sudo command. Sudo command allows regular users to run commands with the same power or privileges as the root user. This means you don't need to log in as the root user to perform administrative tasks. You can simply use the sudo command. The term sudo stands for superuser do, where su stands for superuser and do stands for perform or execute. Remember, the root user is also known as the superuser. Now let's see how we can use the sudo command to perform administrative tasks. The syntax is simple. Just type the sudo command before the command that you want to execute. Now I'm gonna execute the same apt install vlc command. Apt install vlc, press enter, type your password, press enter. As you can see guys, now the command is working. Apt is asking me whether I want to continue the installation or not. Type Y. Y is for yes, N is for no. I'm gonna type Y to proceed with installation. Press enter. Now apt is going to download the required files for VLC, then install it automatically. The installation is complete. Now let me verify the installation. Type VLC, press enter. As you can see guys, VLC is up and running. So guys, that's how you can basically use the sudo command to perform administrative tasks. Just type the sudo command before the actual command that you want to execute. Now let me execute another command that needs sudo privileges. There is a command called fdisk which is used for managing partitions. press enter. As you can see, permission denied. Now I'm gonna type sudo then fdisk -l, press enter. As you can see guys, now the command has been executed successfully. So guys, if you encounter errors like this, permission denied, then just write the sudo command before the actual command, then the command will be executed. This is as easy as that. And there is another tool called Airmon ng. If I press enter, as you can see, run it as root. It means it also needs the sudo privileges. If I type sudo, press enter, now as you can see, this command has been executed successfully. So guys, whenever you want to perform administrative tasks or encounter errors like run it as root or permission denied, then just write the sudo command before the actual command, then everything will be fine. Now let's address a very important question: who can access or use the sudo command? Remember, not every regular user can use the sudo command. Only users who have been granted sudo privileges or permission to use the sudo command can use or access it. By default, only one regular user account has permission to use the sudo command. The user account that you create or set up during installation is allowed to use the sudo command. When you install Ubuntu, Kali Linux or any Linux based operating system, you have to set up a user account and password for that account during the installation, right? The user account that you set up during installation is automatically given permission to use the sudo command. Only that particular user can use the sudo command. Any user accounts that you create after the installation can't access the sudo command. They have limited access to the system and can't perform administrative tasks or use the sudo command. Now, how do you know whether a user account can access or have permission to use the sudo command? It is simple. We need to use the id command to verify that. Now type id space, now specify the username that you want to check sudo permissions for. I'm gonna check whether the Dimalu user has permission to use sudo or not. Type username, press enter. Here we have a lot of information. We will dissect this information in a dedicated section. For now, here you only need to see if the sudo is mentioned here or not. Here we have groups. So groups equal to, and here it is, sudo. As you can see guys, sudo is here. It means the user Dimalu is part of the sudo group. So the Dimalu user has permission to access the sudo command. Now I have another user account on my system, which is guest, and let me press enter to see if it has access to the sudo command or not. Press enter. As you can see guys, this is a regular user account that I created after installing the Kali Linux, and here we don't have sudo mentioned anywhere. It means that the guest user does not have access to the sudo. It can't use or access the sudo command. Again guys, I'm wrapping up this video with the note that only the user account that you create or set up during the installation has the access to the sudo command. User accounts that you add after installation don't have permission to use the sudo command. In this video, we are going to look at the IP-addr command. This is a very important command for administrators and you will be using it a lot. So what is it? The IP-addr command is used to display information about the network interfaces such as Ethernet or wireless network adapter on your computer. It provides network details like IP address assigned to each interface, network masks, MAC address and other network related details. By using this command, you can easily check and manage your network settings. Now let's jump into the practicals. Type IP space addr space show. Now the IP addr command with show parameter displays all the installed network interfaces on your system. So press enter. As you can see guys, these are the installed network interfaces along with their configurations. The first interface that we have is the LO. LO stands for loop back. It is up and running. The loop back is also known as the localhost. This is the address for the loop back. Now, loop back is not a physical network interface, right? It is a virtual interface. You can't use the loop back for connecting to a network. The loop back points to your own system. It can't communicate with external networks. The loop back is not that important for now. I will get back to loop back when we will set up the Apache web server. Now the most important part for us is this ETH0. The Ethernet network interface is represented by the ETH0 in Kali Linux. I'm connected to my network using Ethernet. So under the Ethernet, I have all the network configuration details. As you can see, this is the IPv4 address. INET essentially means IP address. BRT is short for broadcast address. This is the broadcast address. And here we have the MAC address. The MAC address is known by different names such as Ether, Link or hardware address. So this is the MAC address, and down here we have the IPv6 address as well. Now here we don't have the details for wireless card or wireless interface, right? This is because a virtual machine can't access the built-in wireless card because it is already being used by your main operating system or your host operating system. But if you connect an external wireless card, then that will be listed here. A wireless card is represented by WLAN 0. So if or when you connect an external card, then IPaddr command will display that card as well under the name WLAN 0. You will see something like WLAN 0 in this list of interfaces. Now, the show parameter is not mandatory if you only want to list the installed network interfaces. So just type IPaddr, IP space addr, then it will print all the network interfaces along with their configuration details. And instead of using addr, we can use its shorthand, which is A. So IP space A, press enter. As you can see, it is producing the same result as the last command, which was this. So IPA, A is the shorthand for addr. In this video, we will finally learn how to install packages or applications from the terminal. It is actually easy. Type sudo. Now, before actually installing a new application, we should always run the apt update command. It will update your local repositories, which will help the package manager to download the latest possible version of the application that you are downloading, as we discussed in the previous video. So let me quickly run the update command. So type apt update. It will update your local database. Press enter. Let the update command finish. Now the update command is complete. We are good to go. Now we can proceed with installation. So type sudo apt. The apt, as we discussed in the previous video, allows us to install, remove and update packages. So after apt, type install. Install parameter allows us to specify name of the package or application that you want to install. I'm gonna install, let's say, VLC. So type the name of the package that you want to install. So this command is going to install the specified package VLC. Remember guys, apt will only be able to install the specified package if it is available in the repositories. Now press enter, provide your password. Let me scroll up a little, and here these are the dependencies that apt is going to install, because VLC needs all these dependencies to function properly. Now scroll to the bottom. Here we have this prompt, continue. If you want to continue or proceed with installation, then we need to type Y is for yes, N is for no. I'm gonna proceed with installation, so type Y, press enter, and it will take a few seconds or probably a minute to complete the downloading and installation. Alright, the installation is complete. Now let's verify whether the VLC has been installed or not. Type VLC, press enter. As you can see guys, VLC is up and running, so installation was successful. Similarly, you can install any other package or application that you want. Let me install another application. Type sudo. The steps remain same. Type apt install. After install, specify name of the package that you want to install. I'm going to install htop. Htop is basically a system monitoring tool. Press enter, and the installation is almost complete. As you can see, installation is complete. Now type htop to verify its installation. Press enter. As you can see guys, this is the htop. We are inside htop, and at the bottom it is displaying all the running processes on my system, and in the top half it is displaying the system resources being consumed, like RAM, processor, etc. Now press Q to exit out of the htop. So guys, that's how you can basically install the applications. The syntax for installing every application is same. After install, parameter specify name of the package or application that you want to install, and if the specified package is available in the repositories, then the package will be installed. Thank you very much guys. In this video we are gonna learn how to remove or uninstall packages from terminal. So type sudo space. The tool for removing packages is apt, the same tool that we used for installing applications. After apt, type remove. Now specify a name of the package or application that you want to remove. I'm gonna remove VLC, so apt is going to remove the specified package VLC. Press enter, provide your password, and here as you can see, removing the package name VLC. Type N if you don't want to continue uninstallation, and if you want to proceed with uninstallation, type Y, press enter, and it will uninstall the package. As you can see, it has been uninstalled. Now guys, after executing the remove command, we need to execute the auto remove command. Let me type apt auto remove. Now what happens is that the remove command only removes the main executable file. It does not remove the dependencies that were installed with a package. It basically removes the dependencies that are no longer required. So press enter, and if I scroll up, as you can see guys, it is gonna remove all these dependencies that were installed with VLC. Now type Y to proceed with uninstallation. It will complete the uninstallation. Now as you can see, command has been executed successfully. Now let's verify whether VLC is still there or not. So type VLC. As you can see guys, VLC is no longer showing up. It has been removed successfully. Similarly, you can remove any application or installed package that you want. Just specify name of the installed package after the remove then it will remove that package. So thank you very much guys, that's it for this video. In the next few sections, we will focus on PowerShell. It is an extremely important tool for system administrators, cybersecurity analysts, and cloud engineers. It has become an essential part of the Windows ecosystem. So what exactly is PowerShell? PowerShell is a powerful command line shell used for task automation and configuration management. Now, what is a command line shell? A command line shell allows us to control and use a system through commands. This means that instead of using a mouse and icons, we can use commands to control and operate the system. A common example is the command prompt on Windows. We can give instructions to a Windows system through command prompt, such as copying files, initiating and terminating programs, changing settings, configurations, and managing all aspects of the system. Now, PowerShell is essentially an improved and advanced version of the command prompt. It was developed to eliminate the limitations of the command prompt and automate Windows tasks efficiently. The command prompt has limited features compared to PowerShell. While a command prompt can perform basic tasks, PowerShell surpasses it with a wider range of functionalities and executes them more efficiently. In PowerShell, you can do everything that command prompt does, and it also adds many new functionalities. One such feature is piping. In command prompt, there is no piping, which is essential for a command line shell, and PowerShell does support piping. It is object-oriented and has many more essential and advanced features. These days, PowerShell is a must-have skill for Windows administrators and cybersecurity professionals. It is absolutely essential, just like the Linux command line is for controlling Linux system through terminal. We need to learn PowerShell to manage and control the system through the PowerShell console or terminal. It has completely replaced Windows command prompt. The command prompt is now only present for legacy reasons. Since we are coming from Linux, transitioning to PowerShell should be easy. Let me tell you guys, PowerShell is more advanced than Linux command line or bash scripting in many ways. So learning it should be fun. Now, PowerShell is no longer limited to Windows. It is a cross-platform tool, meaning you can use it on Linux distributions like Kali Linux. In fact, it is already pre-installed on Kali Linux. Simply search for PowerShell in the application menu to find it there. There are currently two versions of PowerShell available, PowerShell 5.1 and PowerShell 7. PowerShell 5 is pre-installed on Windows 10 and 11. However, it is becoming obsolete. Microsoft no longer recommends using it, and Windows is gradually transitioning from PowerShell 5 to PowerShell 7. Therefore, we will use PowerShell 7 in this course. PowerShell 7 offers many more features and is faster than PowerShell 7. Now, PowerShell 7 is not completely different from PowerShell 5. It is pretty much the same. PowerShell 7 is essentially an extension of PowerShell 5. It has added more features and improvements on top of the PowerShell 5. PowerShell 5 is still the default on Windows 10 and 11 as of July 2024. I think in future updates, Microsoft will make PowerShell 7 the default, as it is already in the transitioning phase. Now let's dive into the practicals. The first thing that I'm gonna do is check whether PowerShell 7 is already installed or not. So press Windows key, type PowerShell like this. If PowerShell 7 is installed, then it will show up in this list. As you can see, it is not showing up, which means obviously it is not installed. So click on the Windows PowerShell. I want to check the current exact version of the PowerShell. So type get host command, get host it is, press enter, and here we have the version. The current version of the PowerShell is 5.1. Now that we know the exact PowerShell version, now let's update or install the latest version of PowerShell, which is PowerShell 7. So open any web browser and type PowerShell 7 download, and click on the link that says installing PowerShell on Windows, and click on installing the MSI package. And here we have two options for downloading PowerShell. We have PowerShell 86, which is a 32-bit file, and PowerShell x64. This is a 32-bit link or file. You need to download PowerShell according to your system's architecture. Since I have a 64-bit system, so I'm gonna click on this file, PowerShell 7.4 x64. Click on the appropriate link and your downloading will start right away. I have already downloaded the PowerShell, so I'm gonna cancel it. Now once the downloading is complete, go to the directory where you have downloaded the PowerShell. Double click on the file, click on next, click on next, leave everything to default, next, click on next. Now click on install, click on yes, and it is gonna take a few seconds to get the installation done. As you can see guys, the installation is complete. Now click on finish. Now let's verify whether it is installed or not. Press Windows key, type PowerShell, and here as you can see under apps we have PowerShell 7x64. Click on it, and this is the PowerShell 7, right? Let me execute get host command to check the exact version. As you can see, the current version of PowerShell is this. So guys, we have successfully installed the PowerShell 7. Now what I'm gonna do is pin the PowerShell in my taskbar so it is easier to access. So type PowerShell, right click on PowerShell 7, click on pin to taskbar, and here as you can see it has been pinned here. Now I can access it easily. Before we start exploring PowerShell commands, it is essential to understand their structure. This will make learning new commands much easier. PowerShell commands follow a consistent pattern and naming convention. All PowerShell commandlets follow the verb noun naming convention or structure. PowerShell commands are technically known as commandlets. However, commandlets and commands are used interchangeably. There is not much difference, so don't get confused here. Now let's dive into the practicals. Open your PowerShell console. I'm gonna execute let's say get command. Now get command commandlet displays all the commands that PowerShell supports. I'm gonna execute this command, then explain its structure. Press enter. As you can see guys, these are the commands or commandlets that you can use in PowerShell. PowerShell has hundreds of built-in commands, as you can see. Now type clear command to clear the terminal. Back to the main topic, which is structure of a PowerShell command. All the PowerShell commandlets follow this naming convention or structure: verb and noun. First part of a PowerShell command is always a verb and second part is always a noun. Now here we have the verb get. Get in PowerShell is used for displaying information. If you want to retrieve or display information, then we need to use the get, and what information you want to display, that is defined in the noun part. The noun part of a commandlet basically represents the target of the action that the commandlet performs. So if you put the noun and verb together, I am telling PowerShell that get or retrieve information about the commands that it supports. Press enter. As you can see, these are the commands. Now let's try a different command. This time I want to display all the running processes on my system. Now the verb or action remains the same, right? I want to display some information, so type get. Now noun changes to process. I want to display all the running processes. So I'm telling PowerShell that get or retrieve information about the running processes. As you can see, these are the running processes on my system. Similarly guys, based on the task or action that you want to perform, we can easily guess the commandlet name. For example, I want to start a new process. Then the action or verb is going to be start hyphen, and what I want to start is a process. Process means starting a program. Now space, let me type notepad. So this time the action is start. What I want to start is process, which is defined in the noun part. Then we need to specify the process name that you want to start. It will start the notepad. Press enter. As you can see, notepad is up and running. So guys, PowerShell has different verbs for different tasks or actions. For example, if you want to stop something, then we have stop verb. If you want to set or modify configurations, then we have set verb for that. And there are many more. You will get automatically comfortable with PowerShell commandlets as we progress in the course. So guys, that's the naming convention that PowerShell commands follow. It makes it easier to learn new commands. We just need to know what task or action we want to take, and based on that action, you can easily guess the commandlet name. Now PowerShell commandlets are case insensitive. Case insensitive means lowercase and uppercase letters are same to the PowerShell. It treats both equally, which means you can write your commandlets in both lowercase as well as uppercase letters. For example, let me write the get process command in uppercase letters. This is a valid PowerShell command because, like I said, PowerShell is case insensitive. It doesn't matter whether you write your commandlets in lowercase or uppercase letters. Press enter. As you can see, similarly you can write commandlets in lowercase letters or mix of both, like this. Press enter. As you can see, it is still a valid command, but the recommended method to write commandlets is this: capitalize the first letter of verb and noun. This way it looks clean and compact. We also have this hyphen or a dash, right? It is just a separator which separates verb and noun. Now that we have covered the absolute basics, it's time to dive into the interesting stuff. Now let's dive into the practicals. Open your PowerShell console. When you open the PowerShell console, we are presented with this path along with PS at the beginning. PS is short for PowerShell. It basically tells us that this is a PowerShell console where you can execute PowerShell commandlets, and this Sunny is my current working directory as well as home directory. So what I'm gonna do is execute get location command. It displays your current working directory where you are in your file system. Press enter. As you can see, this is my current working directory, and this is the full path to my current working directory. Let's talk a little about this complete path. it is starting with C. C is obviously the starting point where Windows operating system is installed. Inside C drive there is a directory called users. In users directory or folder, Windows stores the files for each user account on the system, and inside users directory there is this directory called Sunny, which is the home directory for the user account Sunny. Now if I type ls, as you can see, these are the files and directories in my home directory Sunny. Now type clear command. Clear command, as the name suggests, clears the terminal. Press enter, as you can see. Now before wrapping up this video, let me execute get history command. Sorry, get history. Now get history displays all the PowerShell commands that you have executed in the current session. Press enter, as you can see. And if you want to list a certain number of commands, then we need to provide count parameter to the history command, and now specify how many commands you want to display. Let's say 2. It will display the last 2 commands that you have executed. Press enter, as you can see. We have seen that PowerShell commandlets follow a specific verb noun syntax or naming convention. PowerShell provides aliases for many commandlets but not for all. So what is an alias? An alias in PowerShell is an alternative name or shortcut for a commandlet. It allows us to use a shorter and easier to remember name instead of the full commandlet name. Aliases are convenient shortcuts you can use in place of longer commandlet's name. This can make working with console more efficient. Now let's jump into the practicals. So type get -alias space. Now type definition space. The definition parameter allows us to specify name of the commandlet you want to check or find alias for. I'm gonna check the aliases for, let's say, get process. Now the get alias is gonna display the aliases that are available for the specified commandlet get process. Press enter. As you can see, guys, we have 2 aliases here. GPS is short for get process and PS is short for process. Now here, as you can see, PS is pointing to get process. It means that if you execute the PS in your terminal, then in the background PowerShell will execute the get process commandlet. It is basically pointing to the get process commandlet. Now PS or GPS, they are just for our convenience, right? So let me type the get process commandlet. Now get process commandlet displays all the running processes on a system. Let me press enter. As you can see, these are the running processes. Now if I type PS, it will produce the same result because PS is pointing to the get process. So if you execute the PS commandlet in the background, the PowerShell is going to execute the get process commandlet. If I press enter, as you can see, it has displayed all the running processes. Now if I type GPS, it will also print all the running processes because GPS is pointing to the get process. In the background, the PowerShell is gonna execute get process commandlet. Let me type GPS. As you can see, similarly you can find aliases for any PowerShell commandlet. Let me check alias for set location. Set location commandlet is used for switching between directories. Press enter. As you can see, these are the aliases available for set location. Now let me check the alias for get service. Press enter, and we have only one alias available for get service, GS v. Now instead of typing get service, we can directly type this alias gsv, then it will list the services. So guys, the syntax for checking aliases for every commandlet is the same. After definition, type the name of the commandlet you want to find alias for. In this video, we will learn how to list or display files and folders using the Get-ChildItem commandlet. Get-ChildItem is a versatile commandlet that allows us to efficiently list files and directories. It is very similar to the ls command in Linux, but Get-ChildItem is much more advanced than the ls command in Linux. Now let's jump into the practicals. So type get child item. By default, the get child item displays all the files and directories in your current working directory, just like the ls command in Linux. So press enter. Let me scroll to the top, and at the top, get child item displays the exact directory whose content it has listed. In my case, it is this Sunny directory. This is the home directory as well, and these are the files and directories in my current working directory, which is Sunny. Now listing files is one of the most frequent tasks that we have to do on a regular basis on both PowerShell and Linux, right? However, the Get-ChildItem command can be a bit lengthy. As you can see, it requires us to type a lot of characters just to list files. So what I'm gonna do is check the aliases for Get-ChildItem to find a more convenient option. So type get alias space, type definition, and provide the Get-ChildItem commandlet to definition. Press enter. Now we have three aliases that we can use for Get-ChildItem. dir stands for directory, gci is short for Get-ChildItem. Then we have ls. Most of us are already familiar with ls, right? Because on Linux we use ls command for listing files and directories. Now I'm gonna use this ls alias for listing files and directories. So type ls, press enter. As you can see, it has produced the same result as the Get-ChildItem. Now, as we discussed, by default, the ls command displays all the files and directories in your current working directory. Now, I only want to display contents of a specific directory. Here I have this directory called desktop, right? Now, I only want to list contents of this desktop directory. It is simple. Type ls space. Now you have to tell the ls command name of the directory whose content you want to list. For me, it is desktop. This time ls command is going to display contents of this specified directory. Press enter. As you can see, guys, this is the contents of this specified directory, desktop. Similarly, you can list contents of any directory or drive. Now what I'm going to do is list contents of a drive. So type ls space. Now specify the drive letter. I'm gonna list contents of C drive. So uppercase C : / press enter. As you can see, this is the contents of the C drive. Now let's explore some of the options that we can use with Get-ChildItem or ls. So type ls space, type hidden. Now hidden, DEN. Now the hidden parameter displays only the hidden files. Let me hit enter. As you can see, guys, it has listed all the hidden files, and on the left side we have HS means hidden system file, and if it is only H, then it means hidden. Now the default ls command displays both files and directories, right? Now I only want to display files. So type ls hyphen type file parameter, it will only display files. As you can see, I only have one file in my current working directory. And another option that we can use with the ls is name. Now before executing this ls with the name parameter, let me execute ls quickly. The default ls command displays all these fields like name, length, last write time, mode, etc. Right now I only want to print names. So type ls hyphen name, it will print only names. Press enter, as you can see guys. And we are gonna wrap up this video with the recursive option. So type ls hyphen type recurse. Now the recurse parameter lists contents of all directories and their subdirectories in the current working directory by default. What basically it means is, let me execute ls command. Now what basically it means, recurse option will list contents of each directory and their subdirectories in my current working directory. So type ls type recurse, press enter. As you can see guys, it is crawling every single file in the each subdirectory. As you can see, this is the final output. Now if you want to list content of a specific directory recursively, then type ls, specify the directory name, let's say desktop. Now provide the recurse option. This time I'm telling ls command that only list contents of desktop directory recursively. Press enter. Now as you can see, it has only printed the contents of the specified directory. So that's it for this video guys. In this video, we will cover how to navigate in your file system efficiently in PowerShell. In other words, we will learn how to change or switch from one directory to another. The commandlet for changing directories is the set location. Now let's jump into the practicals. First, I'm gonna check my current working directory. So type pwd, press enter. As you can see, my current working directory is Sunny, which is my home directory as well. Now I want to change my directory to something else. Let me execute ls. Let's say I want to change my directory to desktop. Then type set hyphen location space. Now specify a name of the directory where you want to change or switch. So type desktop. Make sure that the spelling is correct. So set location is gonna change my directory from current working directory to desktop. Press enter. Type pwd. As you can see guys, my directory has been changed to the desktop. Now it is my current working directory. Now just like listing files and directories, switching between directories is also one of the most common tasks that we have to do on a daily basis. However, set location commandlet, as you can see, can be a bit lengthy. It requires us to type a lot of characters just to change from one directory to another. So what I'm gonna do is check the aliases for set location to find a more convenient option. So let me quickly type get alias space definition set location, press enter, and these are the aliases available for set location commandlet. SL is short for set location, CHDIR is for change directory, and CD stands for change directory. Most of us are already familiar with CD because we have already used it on Linux for changing directories. Going forward, I'm gonna use the CD for changing directories. Let me type CD. Now I'm gonna change my directory to downloads with cd command. So type cd space specify name of the directory where you want to switch or change downloads. Press enter. pwd. As you can see guys, my current working directory has been changed from home to downloads. Now if you type only cd command and don't provide any directory name, then it will redirect us to the home directory. Press enter. pwd. As you can see guys, the directory has been changed from downloads to Sunny, which is my home directory. And sometimes we accidentally execute cd command, which takes us to the home directory. Now if you want to switch back to your previous working directory, then type cd space, now type hyphen. Hyphen takes us to the previous working directory. Previous working directory for me, it was downloads. So press enter. pwd. As you can see guys, my directory has been changed to the downloads. Now if you want to go one directory back in your file system, then type cd space, type 2 dots. It will take us one directory back. Press enter. pwd. As you can see. And if you want to go multiple directories back in your file system, then type cd 2 dots / 2 dots, and it will take us 2 directories back in your file system. Press enter. Now as you can see, my directory has been changed to C. In this way you can go back as many directories as you like in your file system. Just separate 2 dots with the /. That's it for this video guys. Thank you very much for watching. In this video we will learn how to access PowerShell commandlet documentation without going online. This means you can learn about any PowerShell commandlet directly within the terminal or console itself. PowerShell provides documentation for every commandlet directly within your console. The command to access this documentation is get-help. Get-help is a commandlet specifically designed to provide information about commandlets, such as what a commandlet does and how to use it. Now let's jump into the practicals. So type get-help space. Now specify name of the commandlet that you want to get help for or learn about. Let me type get process. Now the get process commandlet displays all the running processes on a system. Don't worry about get process. We will cover get process and many other commandlets in the upcoming sections. Now get help is gonna display documentation for this specified commandlet. Press enter. Let me scroll to the top. And at the top it displays name of the specified commandlet. Then this is the syntax. Now syntax means how to use a commandlet, the options that you can pass to a commandlet. Now obviously guys, this is not very helpful for you, right? As a beginner, this is not gonna make any sense to you, but it is certainly gonna help you once you get past the basics, right? After learning the fundamentals of PowerShell, then this documentation will start making sense. Okay, so it is important that you understand how to use the get help commandlet. If I scroll, here we have aliases. We will get back to aliases in the next video. Now the default get help displays the basic information about the specified commandlet. Now if you want some more details, then provide the detailed parameter. Detailed parameter is gonna display some additional details or more details about the commandlet. Press enter. As you can see guys, here we have some additional information about the get process command. Similarly, you can get help for any commandlet that you like. You just need to specify commandlet name after the get help command. So type set location, this time get help is gonna display detailed information about the specified commandlet set location. Set location is used for switching between directories. Press enter. Here we have the documentation for set location. So again guys, the syntax for every commandlet is same. After the get help, specify the name of the commandlet you want to check documentation for, and this time get help is gonna display the documentation for get service commandlet. Now before wrapping up this video, now let me show you another useful option or parameter that we can use with get help, which is online. Type online. Now the online option, as the name suggests, it automatically opens the official documentation web page in your default web browser. So if I press enter, the get help is going to open up the documentation for get service online. Press enter, and here is the official documentation page where you can learn about the get service. Now documentation is in detail. Here you will find every single option that you can use with the get service. Similarly, if you want to learn about let's say get process online, then type get process and online parameter, press enter. Now here is the documentation for the get process. Here you will learn how to use get process in detail. Everything is explained in detail. So guys, that's how you can basically use the get help commandlet. In this video we will learn how to create files and write content to existing files using the new item and add content commandlet respectively. The new item commandlet is used to create new items. It can create not only files but also directories or folders. And the add content commandlet, as the name suggests, allows us to write lines of text to the files. Let's jump into the practicals. Type new hyphen item space path. The path parameter allows us to specify the destination directory where you want to create the file. I'm gonna create in my current working directory, so type dot. Dot represents the current working directory in both Windows and Linux. So new item is going to create the file in my current working directory. Now type name space within quotes, type the file name that you want to create. Let me create dummy.txt and type item type space file. So item type is going to be file. I want to create a file. So new item command is going to create the file called dummy.txt in my current working directory. Press enter. As you can see guys, the file dummy.txt has been created. Remember, by default new item commandlet creates an empty file. Let me ls to verify. As you can see, the dummy.txt file is right there. Now the item type parameter is optional. If you don't specify the item type, the new item command by default creates a file. And path parameter is also optional. You don't need to explicitly specify the path parameter. By default, new item is gonna create file in your current working directory. Press enter. The file already exists. What I'm gonna do is create another file, dummy1.txt. As you can see, the dummy1.txt has been created. Here it is. Like I mentioned earlier, new item command creates an empty file. Now let's add some content to this empty dummy.txt file. Before we do that, let me show you how to create file at a specific directory. I want to create file in my desktop. So type new item space. Now specify the exact location where you want to create the file. I want to create in my desktop. So type the complete path. So uppercase C :/users/. Now type the name of the logged in user, which is Sunny for me. Now type desktop space name of the file. Let me create dummy.txt, and this time new item command is going to create dummy.txt file in the desktop directory or whatever path you specify. If I hit enter, as you can see, the direct file has been created. As you can see here in the desktop, the file dummy.txt is right there. Now let's move on to how to add content to a file. The dummy.txt file is currently empty. As you can see, its length is 0 byte. Let me check or verify it in Notepad. Dummy.txt. As you can see, guys, it is empty. Now to add content to a file, we have add content command letter. So type add content. Now write the file name where you want to add the content, dummy.txt space. Now write the value parameter. Value parameter allows us to write the actual content to a file. So within quotes, write the text that you want to write or append. Let's say a new line has been added. The way add content command works: if the file name that you specify doesn't exist, then it will create the file first, then add value or content to it. And if the file already exists, then it will append the content to the existing file. So this add content command is going to add this line of text to this specified dummy.txt file. Let me hit enter. As you can see, we did not get any error. Let me check the size of the file dummy.txt. As you can see, length is 27 bytes. Let's check its contents using Notepad. As you can see, guys, this is exactly what we added to this dummy.txt file. Now we can also add multiple lines with a single add content command. Just separate the lines with a comma like this. Line number 2, comma again, line number 3. This time add content command is going to add all these 3 lines to dummy.txt file. Make sure that the lines are separated with a comma. Press enter. Now let's check the contents of dummy.txt. As you can see, guys, this time it added these 3 lines. This line was already there, and the previous command added these 3 lines. So guys, that's how you can add content to a file. Thank you very much for watching. We will continue where we left off in the previous video. In this video, we will learn how to view or display the contents of a file in PowerShell. It is easy. The commandlet for viewing the contents is get-content. It is a versatile command that allows us to view the contents of a file or multiple files. So let's dive into the practical examples. Let me execute ls. Here I have a file called file.txt. Let me view its contents using Notepad. Notepad file.txt. Press enter. This is the contents of file.txt file. Now I want to view contents of this file in the terminal or within my PowerShell console. So type get content space. Now specify the file name whose content you want to display or view, file.txt. So the get content command is going to display contents of this specified file. Press enter. As you can see guys, this is the contents of this file.txt file. So the file name that you specify after the get content command, it will print contents of that specified file. Now I want to print only first 10 lines from this file. I don't want to print all the contents, just first 10 lines. We have to use total count parameter. Now total count allows us to specify how many lines you want to print from the beginning. Let's say 10, and this time a get content is going to print first 10 lines from this specified file. If I hit enter, as you can see, it has only printed first 10 lines. Remember, the blank lines also get counted. Now I want to view lines from bottom. Again guys, the number that you specify after the total count, it will print that many lines from the beginning like this. This time it is printing the 5 lines from the top. Now I'm gonna view contents from the bottom. So get content space, specify the file name. Now type the tail parameter. Tail allows us to view contents from the bottom. Let me specify, let's say 6, and get content is going to print 6 lines from the bottom. Press enter. As you can see, it has printed the 6 lines from the bottom. So number that you specify after the tail parameter, it will print that many lines from the bottom. This time it is going to print 16 lines from the bottom, as you can see. Now before I wrap up this video, let me show you the alias for a get content command. So type get alias space definition get content, press enter. Now these are the aliases for get content command. One of the aliases is cat. Now instead of using get content, you can simply use cat, right? In Linux we have cat command for viewing contents of a file, right? So type cat file.txt, press enter. As you can see, similarly you can use parameters such as tail with cat as well. So feel free to use cat or the original get content commandlet, whatever you feel comfortable in. Welcome back everyone. This is the first practical video on the select string commandlet. In this video, we will learn what select string is and its fundamentals. Select string is similar to the Linux command grep. Select string is a powerful tool for searching text or text patterns in files. Let's say you have a large text file and want to know if a specific word or pattern exists within it or how many times it appears. Select string solves this problem efficiently and easily. It makes searching through files very easy. The use cases for select string are vast. It is heavily used for formatting output, searching for patterns, and efficiently analyzing logs. Select string is particularly valuable when working with logs. In this particular video, we will cover the fundamentals of select string. So let's jump into the practicals. So type select -string space. Now you have to tell the select string command the file name where you want to search. So specify the file name demo.txt space. Now type the pattern parameter pattern parameter allows us to specify the search term or pattern what you want to search for. I'm going to search for the word user. So I am basically telling select string command that search for the word user in the specified file demo.txt. Press enter. As you can see guys, it has printed all the lines that contain the searched term user. The searched term is being highlighted with the background color gray, right? And on the left side it displays the file name where it found the match. It also displays the exact line number where it found the match. We have all these lines where the select string found the word user, which is our searched term. So guys, that's how you can use the select string. It is as easy as that. Now let's search in the multiple files. I'm gonna search for the same word user in multiple files. Now this particular command is going to search for the word user in this specified demo.txt file. Now if you want to search for the same word in multiple files, then separate the files with a comma like this. Now specify the another file name dummy.txt. This time select string is going to search for the word or pattern user in these two specified files. Let me hit enter, and as you can see guys, we have the output. Now to check in which file the select string has found the match, check out the file name on the left side. So here the word user is present in dummy.txt file, and here we have the match in demo.txt file. So on the left side you can easily find in which file it has found the match. So guys, that's how you can specify multiple files. Just separate the files with a comma, then it will search in the files that you specify here. So that's it for this video guys. The select string is a case insensitive command, which means it treats lowercase and uppercase letters the same. It does not differentiate between them by default. For example, if you search for the word user in lowercase, as you can see user is in lowercase, it also matches the word user in uppercase like this, user or user. It will match all three. Let me press enter to demonstrate what I mean. And if you analyze the result, as you can see, the line number 12 we have the word user in lowercase, and at line number 8 we have the word user in uppercase. So it matches both by default, lowercase and uppercase letters. So if you want to make your select string searches case sensitive, then type case sensitive parameter. Now case sensitive is going to make the searches case sensitive. This time select string is only going to match the word user if it is in lowercase. Press enter. It will not match uppercase letters. As you can see guys, it has matched the word user in lowercase only. It is not displaying the lines that contain the word user in uppercase. That's pretty much it for this video. In this video we will learn how to copy files and directories in PowerShell. The commandlet for copying files is copy-item. It is an easy to use commandlet that allows us to copy files and directories from one directory to another or within the same directory. Now let's jump into the practicals. We will start with copying files first, and later we will copy directories as well. Let me execute ls command. Here I have this dummy.txt file and I want to create a copy of this dummy.txt file. So type copy item. Now copy item needs minimum two options. The file name that you want to copy and the destination directory where you want to copy it. So specify the file name that you want to copy. For me it is dummy.txt, dummy.txt is in my current working directory. Now specify the destination directory where you want to copy it. I'm gonna copy it in my current working directory. So specify a different name, let's say dummy cp.txt, because we can't have two files with the same name inside a single directory. Now what copy item command is gonna do, it will take this dummy.txt file and create its copy under this new name dummy cp.txt. Let me hit enter. Let's ls. As you can see guys, we have successfully created copy of dummy.txt file under this new name. Now what I'm gonna do is I will copy this dummy.txt file to another directory. I want to copy it to, let's say, desktop. So type copy item space file name dummy.txt. Now specify the full path to your destination directory within quotes. Specify the path, uppercase C, backward slash. Now type users. Now specify the name of the logged in user. It is Sunny for me, backward slash desktop. Now this time copy item command is gonna take this file, then copy it to this specified directory, which is desktop. As you can see, this is the complete path. Let me hit enter. As you can see guys, in the desktop I have successfully copied this dummy.txt to the desktop. Let me ls. Here as you can see, I have the desktop directory. Now let me ls the contents of ls desktop. Press enter. Here as you can see, we have the dummy.txt file that I copied. Similarly, you can copy the files to any directory or drive. Let's say I want to copy this dummy.txt file to a drive. I have E drive in my system. So let me type copy item dummy.txt, and this time destination is going to be the E drive. So type E colon backward slash, and this time copy command is going to take this dummy.txt file and copy it to the specified drive, which is E. Make sure that the drive name is valid. Press enter. Now let me ls the contents of E drive. As you can see guys, here we have the dummy.txt file. Now let's move on to copying directories. Let me ls. Now here I have this directory called video. Let me ls its contents. Ls video. Okay, looks like the directory doesn't exist. Okay, videos it is, sorry. Ls videos. Press enter. Now as you can see, inside this videos directory I have some contents, right? So what I'm gonna do is I will take this videos directory and copy it to the desktop. Type copy item videos. Now I'm gonna copy it to desktop. Type uppercase C colon backward slash users, logged in username Sunny, desktop. Now this time what basically is gonna happen, the copy command will take this videos directory, then copy it to the specified destination, which is desktop. Let me hit enter. As you can see, the operation was successful. Now let me check the desktop. As you can see guys, the videos directory is in the desktop. Let's check its contents. Double click on it. As you can see guys, it's empty, right? Even though if I check the videos directory that we copied, it has contents in it, right? It has these two files and a captures directory. Now the way copy command works, when you copy a directory, it only copies the directory, not its contents. So if you want to copy not only the directory, also its contents, then we need to provide the recurse parameter. Now recurse parameter is going to copy not only the directory, also all its contents. Now press enter. Now as you can see, we have an error. The directory already exists. Let me remove the directory and copy it again. Press enter. Now let me check the contents of videos directory. As you can see guys, this time it has successfully copied not only directory, also its contents. Now we have another option that we can use with the copy, which is force. Force option basically overwrites the existing directory. Since this videos directory already exists in the desktop, it will overwrite the existing directory and copy the new directory to the desktop. What happens if I re-execute this command again to see what happens? As you can see, the directory already exists, right? So if you want to overwrite, then we can use the force option. Force option. Press enter. Now the existing directory has been overwritten. Now let's check the contents of desktop in terminal as well. So type ls desktop, press enter. Here as you can see in the desktop we have the videos directory. Let's check its contents. Videos. Now this is the contents of the videos directory. Similarly, we can copy directories to a drive as well. Type copy item, specify the name of the directory that you want to copy, then the drive letter, which is E. Press enter. Now the copy item has copied this videos directory to the specified drive E. So let me ls contents of E. As you can see, here we have the videos directory. Let's check its contents as well. Videos directory is empty. This is because I forgot to specify the recurse option. Press enter. The file already exists. Let's overwrite the existing file. Now let me check the contents of videos directory, which is inside E drive. Press enter. As you can see, now we have copied not only the videos directory, also its contents. In this video, we will learn how to delete or remove files and directories in PowerShell. The commandlet for removing items is remove item. Now let's jump into the practicals. I'm gonna start with removing files and later we will remove directories as well. So let me ls. Here I have this dummy cp.txt file. I'm gonna remove this file. So type remove item command space. Now remove item needs minimum one option. You have to tell remove item the file name that you want to remove. I'm gonna remove dummy cp.txt. So remove item will remove this specified file. Remember that this file is in my current working directory. Press enter. Let me ls. As you can see, the dummy cp has been removed. Similarly, we can remove files that are located or stored in another directory. For example, let me check contents of desktop. As you can see, the desktop has this dummy.txt file. I'm gonna remove this. So type remove item. Now specify the complete path to the file. The file is in my desktop, so type c /. I'm gonna provide the absolute path. Type users / again. Type the logged in username Sunny. Now type the desktop. Inside desktop I have dummy.txt file. So this time remove item is gonna remove dummy.txt file which is stored inside the desktop directory. Let me hit enter. Now let's check the contents of desktop again. Press enter. As you can see, the dummy.txt file has been removed. And if you want to remove a file in a drive, then the syntax remains same. I have a drive called E drive. Let's check its contents. Here I have this dummy.txt file. Let me remove this. So type remove item space, specify the drive letter. For me it is E /, and inside E I have this dummy.txt file. Remove item is gonna remove dummy.txt file in E drive. Press enter. Let's check its contents again. As you can see guys, the dummy.txt is no longer in the E drive. Now let's move on to how to remove directories. Let me ls. What I'm gonna do is create an empty directory. Type new item, name, demo, and item type is going to be directory, of course. Now the new item creates an empty directory, right? Let's check its contents. Demo. It is an empty directory. Let's remove this empty directory. Type remove item. Now specify the name of the directory. Press enter. ls. As you can see, the demo directory has been removed. Now I'm gonna remove a directory with contents. Here I have this video dummy directory. It already has some contents. Let's ls its contents, video dummy. As you can see, inside video dummy there is a directory called videos. So let me attempt to remove this video dummy directory. Type remove -item, and let me specify the name of the directory, video dummy. Press enter. As you can see guys, we have this prompt. The item video dummy has children. Children means it has contents in it, and if you continue, all children or items will be removed with the item. And here if you want to remove, then type y. Y is for yes and n is for no. I'm gonna go with n. So guys, if you want to bypass this prompt, then provide the force option. And another option that we need to pass is recurse. Now recurse option removes all the contents of a directory, and force option bypasses the prompt. Now this directory will be removed along with its contents without showing up this prompt. Let me press enter. ls. As you can see guys, video dummy directory has been removed. So guys, that's how you can remove directories. Now let's remove a directory which is stored in a different directory. Let me ls contents of desktop. As you can see, in the desktop I have this videos directory, and this video directory does have some content. So type remove item. Now specify the complete path. C users. Now specify the username, desktop, and inside desktop I have this video directory. And since the directory has contents, provide recurse and force option. Now press enter. Let me ls. As you can see guys, the directory videos has been removed. Now there is one option that we can use with the remove item command, which is confirm. The confirm option basically asks for your permission before removing a file. For example, I'm gonna remove this dummy.txt file and use the confirm option. Dummy.txt confirm. Now confirm option, like I said, it gives us a chance to review whether you want to remove the file or not. Press enter. As you can see, are you sure you want to perform this action? Type y. Y is for yes and n is for no. I'm gonna go with yes. Press enter. ls. As you can see, the dummy.txt has been removed. So guys, the confirm option can be used if you want to review the files that you want to remove before taking the action. So that's it for this video guys. Thank you very much for watching. In this video, we will learn how to rename and move files and folders. The commandlet for renaming is rename item and the commandlet for moving items is move item. Now let's jump into the practicals. I'm going to start with renaming files. Let me ls. Here I have this demo.txt file. I'm going to rename it to something else. Type the commandlet rename hyphen item. Now you need to provide rename item minimum two options: the file name that you want to rename and the file name that you want to rename it with. I'm gonna rename demo.txt space and I'm gonna rename it with, let's say, dummy.txt. So I am telling rename command that take this dummy.txt file which is in my current working directory and rename it to dummy.txt. Let me hit enter and see what happens. ls, as you can see guys, the file has been renamed to dummy.txt. Now I'm gonna rename a directory. I'm gonna rename this sunny directory, rename item, and specify the name of the directory sunny, and I'm gonna rename it to sunny 321. This time rename item is gonna take this specified directory sunny and rename it to sunny 321. Press enter. ls. As you can see guys, the directory has been renamed to sunny 321. Optionally we can use the new name parameter while renaming. Let me show you what I mean. Let me rename dummy.txt. now type new name. New name means the new name that you want to rename a file with. In this case, the rename item is going to rename this dummy.txt to demo.txt. so the new name parameter allows us to specify the new name that you want to rename with. It is optional, as we have seen. We can rename without it as well. Let me press enter. ls. As you can see, the file has been renamed to demo. Now let's move on to moving files from one directory to another. Now let's move on to moving items from one directory to another. Let me ls. Here I have this directory called dummy. I'm gonna move it from my current working directory, which is home, to desktop. So type move item space. Now specify the name of the directory or file that you want to move. Let's say dummy. Now specify the destination where you want to move it. I'm gonna move it to desktop, so C users desktop. Now the move item command is gonna take this directory, then move it to the specified location desktop. Let me hit enter and let me ls. As you can see guys, the dummy directory is no longer here. This is because it has been moved to the desktop. Now let me check the contents of desktop. As you can see, in the desktop we have dummy directory that we moved. Similarly, we can move files as well. This time I'm gonna move this demo.txt file to another directory. This time I'm gonna move to a drive, let's say E drive. Type move item. Let's move it to E drive. Of course, you need to specify the file name or directory name that you want to move. Okay, doesn't exist. I think it is demo.txt. Press enter. ls. As you can see, demo directory is no longer here. But if I check the contents of E drive, as you can see, demo has been moved to E. So guys, that's how you can move and rename items in PowerShell. Thank you very much for watching. In this video, we will talk about the get process commandlet. The get process commandlet is used for retrieving information about the processes running on a system. Processes refer to the applications that are currently running. It allows us to view details about running processes such as process name, process ID, CPU usage, RAM usage, and more. Get process commandlet is especially useful for system administration, troubleshooting, and system monitoring. Now let's jump into the practicals. Type get process, press enter. The get process command displays all the processes running on a system. So these are the processes running on my system, and we have all these properties or fields. I will walk you through some of the important fields. The first field from right is process name. It displays the name of each running process. Then we have ID. ID displays the unique ID assigned to each process. Windows automatically assigns a unique ID to each running process. These IDs help Windows to track and identify processes. An ID can be used to terminate processes as well. Then we have WS. WS stands for working set. WS essentially displays the RAM or physical memory usage. It displays the current RAM being used by each process. As you can see in the brackets, we have M. M stands for megabytes. So WS displays the current RAM being used by each process in megabytes. Then we have CPU. It displays the total amount of time a process has consumed or used since it started in seconds. The default get process command lists all the running processes. Now I want to check a specific process, whether it is running or not. So type get process space name. Now name parameter allows us to specify the name of the process that you want to check. So let me specify notepad. Now get process command is going to check whether the process called notepad is running or not. It will list the notepad if it is running. So if I hit enter, as you can see, can't find a process with name notepad. Now let's change notepad to Chrome. Press enter. As you can see, guys, we have all these Chrome processes running. Now I want to check processes that start with specific letters. For example, I want to check processes that has CON at the beginning. So type CON or any letters, then type asterisk. Asterisk is also called wildcard. It essentially means all. Wildcard selects everything. So in this context, it will list all the processes that has CON at the beginning or whatever letters you specify. Press enter. As you can see, guys, it has listed all the processes that start with CON. Similarly, if you want to list all the processes that end with specific letters, then put asterisk at the beginning, then type, let's say, TY. Press enter. As you can see, we have no such processes that has TY at the end. So let's go for SO. Now we do have one process that ends with SO. As you can see, it has SO at the end. This is exactly what we specified here. Now let's go with T. Now as you can see, it has listed all the processes that has T at the end. Now let's go with, let's say, host. Press enter. Now it has printed all the processes that end with host. If you put letters within wildcards like this time get process command is going to list all the processes that contain the specified word host. It doesn't matter whether host is at the beginning, end, or anywhere in the middle. It will simply list all the processes that has host in it. Press enter. As you can see guys, we have the host. Here we have host in the middle, as you can see host. We have host in the end as well. When you put anything between asterisks, then get process matches that word anywhere in the process, whether it is at the beginning, middle, or end. We will continue where we left off in the previous video. In this quick video, we will learn how to start a new process and how to stop a running process. A process refers to act of initiating an application. When you run an application, it becomes a process. A running application is called process. Let's start by looking at how to start a new process. The commandlet used for starting processes is start process. Now let's jump into the practicals. Type start hyphen process space. Now specify the name of the process that you want to start. Let me type notepad. Press enter. As you can see guys, notepad is up and running. Make sure that the process name that you specify is installed. Let me start another process. Start process space Firefox. I already have Firefox installed, so it should open up the Firefox. So press enter. As you can see guys, Firefox is also up and running. So guys, this is as easy as that. You can start processes by typing the process name after the start process command letter. Now what I'm gonna do is I will terminate the processes. Terminating processes is equally easy. First we need to get the process ID. I want to terminate, let's say, the notepad process. It is currently running. So type get process name notepad. We need the ID of the notepad process. Press enter. As you can see, the notepad process is currently running and its ID is this. So I'm gonna use this ID to terminate the notepad process. The commandlet for terminating process is stop process space. Now specify the name of the field or property. I'm going to use ID. So type the exact property name which is specified here. Now specify the ID. Let me type 14244. Press enter. As you can see guys, it has terminated the notepad process. Similarly, we can also terminate processes by their name. Let me open the Firefox. As you can see, Firefox is currently up and running. Now I'm gonna terminate process Firefox. First, of course, we have to get the ID or name of the processor. So Firefox. Now we have a plenty of processes with Firefox name. So type stop process. This time we are gonna use the process name property. So process name space within quotes type Firefox or the process name that you want to terminate. If I hit enter, as you can see guys, the process Firefox or all the processes with Firefox name have been terminated. So guys, that's how you can use the stop process command to terminate processes. In this video, we will discuss how to list and stop services using the get service and stop service commandlets. Get service is used to retrieve information about services running on a system, and the stop service commandlet is used for stopping or terminating services. We will learn both how to display and stop services. First, let's talk about what are the services. Services are essentially programs that run in the background on a computer. These programs are typically essential system functions that keep your operating system running smoothly. Many services are critical for system operation. Windows automatically starts those services when it boots, and they continue to run in the background, ensuring your system functions properly. Now let's dive into the practicals. Type get service, press enter. The get service displays all the services. As you can see, status column displays status of a service, whether it is stopped or currently running. Then we have name property. It displays the name of each service. Then we have display name. It is similar to the name column. The only difference is that display column displays the name of services in a bit more human readable format, as you can see. Now the get service is similar to the get process command. Let's say I want to check a specific service, whether it is running or not. So type get service space hyphen display name. Type display name. Now specify the specific service name that you want to check. Let's say Windows update. I want to check whether the service Windows update is running or not. Press enter. As you can see, the Windows service is indeed running, right? Now just like the get process command, we can use wildcard here as well. Let's say I want to list all the services that contain the word update. Now get service command is going to display all the services that contain the update. It doesn't matter whether update is at the beginning, end, or somewhere in the middle, because we are using two asterisks. Press enter. As you can see guys, now it has listed all the services that contain the word update. Now word update is at the end, and here we have update in the middle, as you can see. So these are the services that contain the word update. Now one service that I am specifically interested is Defender. I want to see if the Defender service is running or not, because it is important that Windows Defender is up and running. It is important for system security, so I have to make sure that it is up and running. Within quotes, type Defender. Okay, use wildcards. Within wildcards, type Defender, press enter. As you can see guys, we have all these services that contain the Defender. Bitdefender agent, it is running. Microsoft Defender antivirus network, it is also running. This is the most important component here. Microsoft Defender antivirus service, it is also up and running. So guys, that's how you can use the get service commandlet to list services. Now let's move on to how to terminate or stop services. To stop services, we have to open the PowerShell console as an administrator. So let me close my current terminal and right click on PowerShell console. Now click on run as administrator. Click on yes. Now the commandlet for terminating services is stop-service space, type display name. Before I execute this stop service, what I'm gonna do is check the status of Windows update service, whether it is running or stopped. So get service display name, display name within quotes. Let me type Windows update, press enter. As you can see, Windows update is currently running. I want to terminate or stop it. So type stop service space display name. Let me fix the spelling. Display name space, and within quotes write the service name that you want to stop. Now the stop service commandlet is used for terminating or stopping services. The display name parameter allows us to specify the exact service name that you want to terminate. In my case, stop service is gonna stop the service called Windows Update, which is currently running. As you can see its status column, press enter, and we have no error. It means the command was executed successfully. Let me check its status. As you can see guys, the status of Windows Update service is stopped. It has been stopped or terminated by this get service command. So that's how you can use stop service commandlet to terminate services. The syntax is same for all the services. After display parameter, type the exact service name that you want to terminate. So that's it for this video guys. Thank you very much for watching. In this video, we are gonna learn about output redirection. Output redirection is a fundamental concept in the command line that allows us to control the output of a command or program. In simple terms, it means taking the output of a command and redirecting or saving it to a file. When you execute a command in the terminal, by default, the output of that command is typically displayed in the terminal. However, with output redirection, you can save the output to a file. There are many situations where you might need to save the output of a command to a file instead of displaying it in the terminal, such as analyzing the output later, filtering or processing the output with other tools, etc. So let me practically demonstrate what I just explained. Let me execute ls command. This is the output of ls command, right? Now, output redirection allows us to save or redirect output of a command to a file. This is exactly what I'm gonna do. I will take this output of ls command, then save it to a file. It is actually pretty easy. Type ls space, now type the greater than sign. Greater than sign or symbol is also known as the output redirection operator in PowerShell. Now specify the file name where you want to save the output. So let's say op.txt. Now the way output redirection works, if the file that you specify here does not exist, then it will create the file first, then save or redirect the output to the file. And if the file already exists, then it will redirect the output to the existing file. Let me press enter. As you can see guys, we did not get any output. This is because by default PowerShell sends output to the PowerShell console. However, this time we used the output redirection operator. So output was sent to this file, not to the PowerShell console. Now let me check whether the file has been created or not. ls, as you can see guys at the bottom, the file op.txt has been created. Now let's check its contents. Get content op.txt, press enter, and as you can see guys, this is the contents of this op.txt file. This is the output of this ls command. We redirected this exact output to this op.txt file. So guys, that's how you can redirect the output of any command to a file. Now let me redirect output of get process command. This is the output of get process command. Now I want to save this information or output into a file. The syntax is same for all the commands. Get process greater than sign. Let's give it a different name. Let's say processes.txt. This time PowerShell is going to take output of get process command, then save that output to this specified file. Press enter. ls, as you can see, the file processes.txt has been created. Let's check its contents. Get content processes.txt, press enter. As you can see guys, this is the contents of the get process file. In this way you can redirect output of any command to a file. This is the second part of the output redirection. In this video we are gonna discuss the content overwriting, how it works. You have to be a bit careful when redirecting output of a command to a file, because the way output redirection operator works, if the file name that you specify after the output redirection operator already exists and has content in it, then it removes or overwrites the contents of the existing file and only keep or save the new content or output that you redirect to it. For example, I already have this op.txt file, right? It already has some content in it. Let me open a new PowerShell console and I'm gonna open the op.txt file in Notepad. As you can see guys, op.txt file already exists and it has some content in it. Now what happens if I redirect output of another command to this op.txt file? Let's see. This time I'm gonna redirect output of get process command to the op.txt file. Now what basically is going to happen, the output of get process command will be redirected to the op.txt file. This file already exists and it already has some content in it. Now the output redirection operator is going to delete or overwrite the existing content and only keep the output of this command get process. So let me press enter. The command was executed successfully. Let me close this file and reopen it in the Notepad. Now as you can see, the existing content has been removed. Now we only have the output of this get process command. Let me scroll down. As you can see, the previous content has been removed or overwritten. Now if you want to keep the existing content and append new content or output at the end, then we have to use two output redirection operators like this. This time let me redirect output of ls command to the same op.txt file. This time the PowerShell is going to keep the existing content of this file and append the new content at the end of the file, because we are using two output redirection operators. Let me press enter. Let me close the file and reopen it in the notepad. This is the existing content. If I scroll down, this is the content or output of the previous command, which is ls. So again, when you use two output redirection operators, the output is appended at the end of the file and existing content will not be removed or overwritten. That's it for this video, guys. Thank you very much for watching. In this video, we will cover pipes, also known as piping. Piping is an essential part of PowerShell and the Linux command line. By definition, it is the same concept that we learned in Linux. There is no difference at all. You can skip directly to the practical part of this video if you already know it, but it is recommended to watch the full video. So let's revisit piping in PowerShell as a refresher. So what exactly is piping? In simpler terms, piping is the process of sending the output of one command to another. Piping combines two or more commands or commandlets by sharing data between them. This is done using the pipe character between the two commands. Now, why do we need to send output of one command to another? Sometimes we have to use multiple commands or tools to complete complex tasks. So when you use different commands separately to get a single task done, it is a time-consuming process, right? So why not combine multiple commands together instead of executing them separately? This is what piping solves. Piping allows us to combine or connect multiple commands by sharing data or output between them. So instead of using multiple commands separately, we can combine them using piping. When one command sends its output to another command, the receiving command processes that output as its input. This essentially means the output of one command becomes the input for the next command or the receiving command. Now let's jump into the practicals. I'm gonna open two PowerShell consoles. It will make the explanation smooth. So let me execute get process command. This is the output of get process command, right? Now, piping allows us to send or pipe output of one command to another. This is exactly what I'm gonna do. I will send the output of get process command to another command. The problem that I am trying to solve is I want to sort processes by their RAM or CPU consumption. Unfortunately, the get process does not have this capability, so we have to use another command to sort processes. The commandlet for sorting processes or any given data is sort object. So we have to send these processes or output of get process command to the sort object commandlet. To send output of one command to another, we have to use piping. Piping allows us to connect two commands or share data between multiple commands. Now let me type the complete command, then I will break down everything. So type get process space, type the pipe character. This is the pipe character. It is typically above the enter key. It sends output of one command to another. Now type sort object property. Now the sort object allows us to sort processes. Not only processes, it can sort any given data based on the property that you specify to it. Now we have to specify the property. If I go back to the get process commands output, as you can see, we have all these properties or columns, right? We can sort processes based on any of these properties. One of the properties that get process has is WS or RAM. So I'm gonna specify the WS here. Make sure that the spelling is correct. So type the exact property as it is specified here. So type WS. Now the way it is gonna work, PowerShell is going to send output of get process command to the sort object because we are using piping. The sort object is going to receive the output, then check the property that I have specified here, and the property is correct because the get process does have WS property. Now based on this property, the sort object is going to sort the processes. Let me hit enter, then I will explain it further. Let me scroll to the top. As you can see guys, check out the WS field. The processes have been sorted, but by default the sort object sorts processes or data in ascending order, lowest to highest. As you can see, if you want to sort in descending order, then we need to pass descending parameter. Now descending parameter is going to sort processes in descending order, highest to lowest. Let me scroll up. As you can see, processes have been sorted in descending order, highest to lowest. The processes consuming the most RAM are being listed first. Now let me explain this entire command again, the way it worked. Since we are using piping, the output of get process was sent to the sort object, then sort object sorted the processes based on the RAM consumption. Remember, most PowerShell commandlets are designed to receive data through piping. So output of get process became input to the sort object commandlet. In piping, output of one command becomes input to another. Similarly, we can sort based on other criterias such as CPU. So after property, type CPU. The CPU property does exist. So type CPU, press enter, and let me scroll up. As you can see, the CPU column, the processes have been sorted by their CPU consumption. We can also sort by the process name property. Just replace CPU with process name, press enter. As you can see guys, now the processes are being sorted by their names. Now let's do a few more examples. Let me execute ls command. I want to sort the files according to their size. We have the length property here, so type ls. Let me pipe it to sort object, sort object property is length. Press enter. As you can see guys, the length column, the files have been sorted in ascending order, lowest to highest. Let's go with descending. Press enter. Now files are being sorted in descending order according to their size. So that's how guys you can use piping to send output of one command to another. In this video, we will look at the major object commandlet and how it can be used with piping. The major object commandlet is used in PowerShell to count the number of lines, words, and characters in the input you provide to it. It is typically used to perform counting in a file or the output you send to it through piping. It is similar to the ws command in Linux. Now let's dive into the practicals. Let me execute get process command. Now these are the running processes, right? And each line is a separate process. I essentially want to count how many processes are running on my system. So what we have to do is pipe the output of get process commandlet to measure object space. Now specify the line option. Line basically counts the total lines. If I press enter, as you can see, we have 177 lines. It means there are total 177 processes running on my system. Similarly, we can use other options like character and word. Character counts the total characters and word option counts the total words. If I press enter, as you can see guys, we have the output. There are total 177 lines, 356 words and 6000 plus characters. And now measure object is particularly useful when you want to count words, characters or lines in a file. For example, here I have this demo.txt file. I want to count how many lines and characters are in this file. The process is same. We have to send output of demo.txt to measure object. So type get content demo.txt, press enter. Demo.txt. This is the output of demo.txt, right? Now we have to send this output to the measure object commandlet. Type the get content, then file name, type pipe character, then measure object space line, press enter. As you can see, there are total 19 lines in this demo.txt file. Similarly, we can count characters as well. Type -c, press enter. -c is short for character. So instead of typing character, you can simply type C. Now it has printed the total characters present in this file. Similarly, we can pass the word or W parameter. It will count the total words. Press enter. As you can see guys, there are total 880 words in this file. Now let's count how many files and directories are in my current working directory. Let me execute ls. These are the files and directories, but I don't exactly know how many files and directories are there. So type ls pipe character, again measure object space line, press enter. Now the output is 17. It means there are total 17 files and directories in my current working directory. That's how guys you can use measure object and combine it with piping. We will continue where we left off in the previous video. In this video, we will combine piping with the output redirection operator. We will list the top 5 processes that are consuming the most RAM and then save that information to a file. So let's jump into the practicals. Type get a process. Now pipe it to sort object property space descending space. Now type the top parameter. Top parameter allows us to list a certain amount of data or processes. Let me provide let's say 5. Now it will display only the 5 processes that are consuming the most RAM because we are using the descending parameter. If I hit enter, it looks like we have an error, missing an argument for parameter property. I forgot to specify the property or the sorting criteria. type ws. Ws is essentially working set or RAM. Press enter. As you can see guys, it has listed exactly the 5 processes because we provided the value 5 to the top parameter. The processes are being sorted in the descending order or highest to lowest RAM consumption, right? Now this time I'm gonna list, let's say, top 10 processes that are consuming the most RAM. So provide the value 10 to top parameter. Now it has printed the top 10 processes that are consuming the most RAM. Similarly, we can use CPU property. It will list the top 10 processes that are consuming the most CPU. As you can see, the CPU column, it has listed processes consuming the most CPU. Now I want to redirect or save this information into a file. Now to save any information or output of a command to a file, we have to use the output redirection operator. So after top 10 space, now type the output redirection operator space. Now specify the file name where you want to save this information. So type top 10 cpu.txt, press enter and let me ls. As you can see guys, we have the file top 10 cpu.txt. Now let's check the contents of this file. Get content, type top 10 cpu.txt, press enter. As you can see guys, inside this file we have the information about the top 10 processes that are consuming the most CPU. So guys, that's how you can basically combine the piping with output redirection to filter and save the information. Thank you very much guys. In this section, we will learn about PowerShell objects in detail. Objects are the heart and soul of PowerShell. Understanding objects is essential for mastering PowerShell and automation. So make sure that you watch the complete video. This is extremely important. First, let's understand what an object is in general. This will lay the foundation for understanding objects in PowerShell. An object is essentially an entity which can be physical or simply an idea or concept. Examples of objects include books, chairs, computers, cars, and people. These are all objects. Now, each object has its own unique properties or qualities that describe it. Let's understand objects with a book object as an example. Each object has characteristics or properties that describe it. A book has properties like a title, a total number of pages, an author, and so on. These are called properties of an object or book object to be specific. Similarly, a person has properties such as eyes, legs, skin color, hands, and heights. So every object has properties or qualities that describe it. Objects can also perform certain actions. The action that an object performs is called a method. For example, a human being can walk, talk, build, and perform numerous other activities or actions. Now let's address the real question: how are objects related to PowerShell and why it uses objects? Well, PowerShell uses objects to represent and manage virtually everything it interacts with. In PowerShell, everything is an object. When you execute a command, you typically get text as output, right? For example, let's execute the ls command or Get-ChildItem. It returns all the files and directories as output, as we can see. However, these are not actually text. They are objects. The files and folders here are essentially textual representations of of objects. Each file and directory here is an individual object. Each row or line represents a separate object and each column is a property. Now let's discuss the actual question: why was PowerShell implemented with an object-oriented approach? PowerShell was designed with an object-oriented approach because it makes it easy to access and manipulate everything. In object-oriented design, we have an object and its properties, right? Now let's take a file as an example. Dummy.txt, this is a text file, right? As I mentioned earlier, everything is an object in PowerShell. So a file is also an object. And just like any object, a file object also has properties. A file has properties such as its name, size, creation date, extension, etc. Each of these properties describes a specific characteristic of the file object. Similarly, every file and directory here is an individual object with its own unique set of properties. Now, the biggest advantage of objects is that we can easily access and manipulate their properties. For example, let's say I want to access the size of a file. Then all I have to do is access the size property of the file object. I can access any property of the file such as its extension, creation date, name, and so on. By default, ls command displays only these 4 properties in its output. However, there are many more properties than these 4. In the next video, I will demonstrate in detail how you can view and access all the properties of an object. On the other hand, the Linux command line is not object-oriented, so accessing specific details such as file size or its creation date is not as straightforward as PowerShell makes it with its object-oriented design. PowerShell offers a more dynamic approach in this regard. You will explore in the upcoming videos and sections how convenient it is. Similarly, if you execute, let's say, the get process command, it returns a list of processes. However, each process is a separate object in PowerShell. So that's it for this video, guys. We will continue where we left off in the previous video. In this video, I will demonstrate objects practically. We will cover how to view and access properties of an object or the properties associated with an object. Now let's jump into the practicals. I'm gonna start with a very simple example. So let me execute ls command. As we discussed in the previous video, everything in PowerShell is an object, and here each directory and file is a separate object, and a file object has properties like mode, last write time, its length, name, etc. By default, the ls commandlet displays these 4 essential properties in its output. It considers these the most relevant to us. However, a file has many more properties than these 4, such as its creation date, last access time, and extension, etc. Now, if you want to view all the methods and properties of an object, then we need to use the get-member commandlet. The get-member commandlet allows us to view all the properties associated with an object. Now, the syntax for viewing the properties and methods of an object is simple. Type the commandlet name whose properties you want to view. I'm gonna view properties of ls commandlet or get child. Type ls. Now pipe its output to the get member commandlet. Now the get member commandlet is going to display all the properties associated with the ls commandlet. The ls commandlet lists files and directories, so it will display the properties associated with files and directories. Press enter. Let me scroll to the top a bit. And we have 3 columns here: name, member type, and definition. The name column displays the actual name of the property or method. The member type displays the type of member, whether it is a method or property. Then we have the definition column. It is not that important for us because the details displayed in the definition column are mostly used in programming and automation. Now in the member type column, as you can see, we have a bunch of methods, right? Now methods are essentially the actions that can be performed on objects. Methods are mostly used in automation and programming. Now we are specifically interested in the properties of the file object. So let me scroll down, and here these are the properties that are associated with a file object. We have properties like name, length, last write time, etc. By default, ls command displays these properties in its output, right? However, we also have properties like creation time, exists, extension. The creation time displays when a file was created. We can access and use all these properties very easily. Now there are 2 ways to access properties of an object. So let me demonstrate it practically. I'm gonna start with accessing the creation time. I am interested in seeing the creation time, when each file and directory was created. To access property of an object, within brackets write the name of the commandlet ls. Now type the dot. After the dot, you can write the name of the property that you want to access. Now ls commandlet has a property called name. Press enter. Now it has printed name of each object, right? Similarly, we can access any other property that you want. This time I'm gonna access creation time. Now creation time is gonna display the creation date and time of each file and directory. So press enter. As you can see, the creation time property displays the creation time of each file and directory when it was originally created. However, right now we can't exactly tell to which file the creation date and time belongs to, or to which file each creation date is associated with. Don't worry about it. It will be addressed in the next video, where we will learn how to customize and format the output. The focus for this video is to teach you how to access properties of an object. Now this commandlet by default displays the creation time of each file and directory in your current working directory. If you want to check the creation time of a specific directory or file, then we have to provide it the name of that particular file. For example, I have a file called dummy.c. I want to check when it was created. Now after ls space, specify the name of the file. Let's say dummy.txt. Press enter. Okay, it is not a valid file name. Okay, let me go for demo.txt. Demo.txt. Press enter. Now it is specifically telling us when this specified file was created. Similarly, guys, you can access any property that you want. Let me execute this get member commandlet, and here we have another property called exists. So let me show you how to use exists property. Now exists property displays whether a file exists or not. So it will specifically check whether this specified file demo.txt exists or not. Press enter. True means the file does exist, and let me provide an invalid file name. Now it is telling me can't find path because the file doesn't exist. That's how you can use any property that is associated with an object. Let's go for, let's say, base name. Now base name property displays the base name. Base name means the name without extension. If I press enter, now as you can see, it is only displaying the base name, not its extension. Now let's explore a few more commandlets. I'm going to check the properties associated with the get process commandlet. So type the name of the commandlet and pipe its output to the get member. Press enter. Here these are the properties associated with the get process commandlet. We have CPU, working set. Working set means RAM, and we have other important properties like start time. Start time property essentially displays when a process started. Then we have the path. Path property displays the path of process where it is installed. So let me use this start time property. Now the syntax is same. Within brackets type the name of the commandlet, dot, after dot write the name of the property that you want to access or use. Start time, press enter. Now it is displaying the time of each process when it started, right? And we can also check a specific process start time. By default, it is going to display the start time for each process, running process. Let me start, let's say, Notepad, and I'm going to check when the Notepad was started. So Notepad, press enter. As you can see, it is displaying the start time for the specified process Notepad. Similarly, we can access all other properties. One of the properties that I am interested in is path. I want to check where the Notepad is installed. Path. Now as you can see, it is exactly telling me the location where the Notepad is installed. And if you remove the Notepad, now it is going to display the path of each running process where they are installed. As you can see, we have the complete path. Okay, let me execute the get member commandlet again. Here we have the CPU property as well, right? CPU property displays the CPU consumption. So press enter. Now here, as you can see, and we have a property called WS working set. It displays the RAM consumption, how much RAM each running process is consuming. So guys, that's how you can view and use property of an object. Similarly, we can access and view properties of any commandlet. The syntax remains same. Type the name of the commandlet whose properties you want to view, then pipe that to the get member. This time get member is going to display properties and methods associated with the get service. As you can see, we are going to continue where we left off in the previous video. Now that we have the essential fundamentals cleared about objects, it's time to start learning the fun part. In this video, we will discuss the select object commandlet. The select object is used to select specific properties from objects. In simpler terms, it allows us to choose only the properties you are interested in, which can be very helpful for creating a more concise output. You can select which properties you want to display as output. Now let's jump into the practicals. I'm gonna start with a simple example. So let me execute ls command, press enter. Now by default, the ls command displays all these properties like mode, last write time, name and length. Now I want to format or customize my output. I only want to display these two properties, name and length. All other properties are not that relevant for now. So to display specific properties, we have to use the select object commandlet. The syntax is very simple. We need to pipe the output of ls or any commandlet whose properties you want to display. So let's start with ls. Type pipe character select object space. Now provide the property parameter. Now you have to specify the exact property names that you want to display. Let me open another PowerShell console for better clarity. Let's execute ls here. Now I want to display these two properties, name and length. So you have to write the exact property names. So type the name, and another property that I want to display is length. Type comma. You have to separate property names with a comma. Now length. This time the select object commandlet is going to display or print only these two specified properties. If I hit enter, as you can see guys, now it is only displaying these two properties, right? This is what I specified or provided to the property parameter. And if you remember, the ls commandlet or a file object has a property called creation time, which tells us when a file or directory was created. I think we discussed it in the previous video. So comma, type creation date. I think it is creation time. Yes. So type the creation time, press enter. Now it is exactly telling us the creation date and time of each file and directory in my current working directory. So guys, that's how you can use the select object to format the output. You can basically choose the properties that you want to display. Now let's do a few more examples. Now let me execute get process command and scroll to the top. Now the get process command by default displays all these properties, right? Process name, ID, CPU, RAM consumption, etc. I am only interested in displaying process names and the amount of RAM or CPU they are consuming. The syntax is same. Type the commandlet whose properties you want to select or whose output you want to format. Pipe character select object property. Now specify the properties that you want to display. I'm gonna display process name, so make sure that you write the exact property, which is process name, comma. I also want to display the CPU consumption. CPU, press enter. As you can see guys, this time this commandlet is only displaying these two specified properties, process name and CPU. And let's go for RAM as well. So type ws. Ws stands for working set. It is gonna display the current RAM being used by each running process in bytes, as you can see. So guys, that's how you can basically use the select object. Now we can also manipulate the way you want to display properties or in which order you want to display the properties. For example, I want to display the CPU consumption first. Then you need to specify the properties in the same order you want them to appear. So CPU, process name. This time select object is gonna display the CPU consumption first, then process name. Press enter, as you can see guys. So that's how you can basically manipulate and format your output according to your liking. Similarly, you can use select object with all other commandlets, right? You just need to provide the property names that are associated with the commandlet that you are redirecting to it. In this section, we will learn about WhereObject commandlet. It is one of the most important commandlets in PowerShell. WhereObject is used to filter data. You can filter anything based on objects properties with WhereObject. It is used to filter data based on conditions or criteria. If a certain condition is met, the matching result gets displayed. For example, if you only want to display processes that are consuming more than, let's say, 300 megabytes of RAM, or if you want to search for files based on their size, then you can use WhereObject to solve such problems easily and efficiently. Its use cases are vast, as you will discover in this section. This video is going to be a bit technical, so pay full attention. Now let's jump into the practicals. Let me execute get process command. Press enter. Get process command, as you can see, it displays all the running processes on a system. Now I only want to display the processes that are consuming more than let's say 200 megabytes of RAM. It is actually easy. Type get process. We need to pipe the output of get process to the WhereObject. So type WhereObject. Now we need to specify the filtering condition or criteria, how you want to filter processes. So type curly brackets. Remember, the filtering criteria or condition is always specified within the curly brackets. This is the syntax. Now first thing that we need to specify is the special variable. Type $sign and underscore. This is a special variable in PowerShell. It essentially holds the current object being processed in the pipeline. I will get back to it in a minute. After special variable, type dot. Dot allows us to access the property name that you want to use. So specify the property name that you want to use for filtering. I'm gonna filter processes based on the RAM consumption. So type ws. Get process has the property called ws, which represents RAM. After ws, type gt. gt stands for greater than space. Now type 200 MB or whatever number you like, but make sure that the MB is in uppercase. Now let's break down this entire command. Before we do that, I'm gonna open another PowerShell terminal, which is gonna make the explanation smoother. And here let me execute get process command, because we are piping the output of get process to the WhereObject. Let me scroll to the top. Now let me break down this entire command. Since we are using piping, the PowerShell is gonna send output of get process command, which is this, to the WhereObject, and WhereObject is going to filter processes based on their RAM consumption, right? Now the most important part here in this entire command is this condition, right? First thing that we need to understand is this special variable, what it does. Now this special variable $sign and underscore essentially stores the current object being processed in the pipeline. Let me explain what it means. WhereObject receives input through piping, right? Output of get process becomes input to the WhereObject. Now WhereObject processes one object at a time. Remember guys, every single process here is an individual object, and WhereObject processes one object at a time. It starts with the first object, which is this. So WhereObject takes this object, then stores it in this special variable where object needs the object or this data for processing. Then after storing the object or data in this special variable, then where object checks the property name that you have specified, which is WS or RAM. It takes the WS, which is this value of WS, which is 3.40, and then it checks whether it is greater than the specified value 200 MB or not. Condition is false because 3.43 is not greater than 200 MB. Now if the condition is false, then PowerShell is not going to display or list that process. It will only list those processes if the condition is true, and then it moves on to the next object. Here again we have RAM consumption 25 is not greater than 200 MB, so it will not list this process as well. And when it checks this particular process or object, as you can see, its RAM consumption value is 295. So 295 is greater than 200 MB, which is true. So if it evaluates this condition to true, then it lists or displays that process. Let me press enter. As you can see, guys, PowerShell has displayed only those processes whose RAM consumption is greater than this specified value 200 MB. As you can see, all the processes that are consuming more RAM than 200 MB are being listed or displayed. So guys, that's how this entire command works. Now just like -GT, which stands for greater than, we have other relational operators like LT stands for less than. Now I'm gonna list all the processes that are consuming less RAM than 2 MB. Press enter. As you can see, guys, check out the WS property. It is only listing processes that are consuming less RAM than specified value 2 MB. And we have other operators like less than equal to and greater than equal to as well. And another relational operator that you are frequently gonna use is EQ. EQ stands for equal to. I'm telling PowerShell or where object that display the processes that are consuming the exact RAM 2 MB, right? We have specified EQ. EQ means equal to. So where object is gonna check if the RAM value is equal to 2 MB or whatever number you specify. If I press enter, as you can see, it did not find any such processes. Now EQ is mostly used with the text or string. We will explore more about EQ in the next video. Similarly, we can filter processes based on other properties like let's say CPU and CPU greater than, let's say, 100. This time where object is gonna display all the processes that have used more CPU time than 100 seconds since they started. So press enter. Now check out the CPU column. As you can see, these are the processes that are consuming the most CPU, right? So guys, that's how you can basically use where object to filter processes. Now let me try the name property, and the name, let's say, equal to Chrome. This time where object is going to display if a process name is equal to the specified value Chrome. Make sure that the string or text is specified within quotes. Press enter. Looks like we have no such processes. You know what, let me start the Chrome browser, and now we should have some output. Let me re-execute the command. As you can see, guys, the get process has listed all the processes that meet this condition. The condition says that the name of a process must be equal to Chrome. Now check out the process name property. It has listed only processes with the name Chrome, Now see guys, process name and name properties are the same. The name is basically short for process name. So guys, that's it for this video. Thank you very much for watching. We are continuing where we left off in the previous video. In this video, we will explore where object further with more examples. We will learn how to filter services based on their status, such as running, stopped, and startup type. Let's say if you are only interested in seeing the services that are currently running or the services that start automatically at system boot, you can easily utilize where object to solve these problems. Now let's jump into the practicals. Let me execute the get service command. Press enter. By default, the get service displays all the services, including running services and stopped. Stopped means they are sitting idle, not consuming any system resources. Now, I only want to display the running services. To achieve this, we need to use the status property. As you can see, we have the status property. We need to filter services by their status. It is actually easy. Type get service, pipe it to the where object. Now type the curly brackets, type the special variable. Now type dot. After dot, specify the property name that you want to use for filtering. Let me type status. I want to filter services based on their status, whether they are running or stopped. Space. Now type equal to operator, space. Now within quotes, type running. Now let me break down this entire command. We are piping output of get service to the where object. Now where object will check status of each service. If status of a service is equal to running, then it will display that service, and if the status is not running, then it will not display those services. So press enter. Let me scroll up. As you can see guys, check out the status column. It is only displaying those services that are currently running, because this is what I told the where object. Take the services, then check the status of each service. If its status is equal to running, then list those services. This is as simple as that. Similarly, we can list the stopped services. Type stopped, press enter. Now check out the first column. Now it is only displaying the services that are stopped or sitting idle. Now let's do a few more examples. I want to display those services that start automatically when the system boots up. The get service has a property called startup type, which displays the services that start automatically. So let me pipe the output of get service to the get member to verify the property name. Press enter. Here, as you can see guys, we have a property called startup type. We need to utilize this property. So type get service, pipe it to the where object command. Let curly brackets, type name of the service, which is startup type. Startup type equal to automatic. Where object is gonna check the property that I have specified here, startup, then check if the startup type is equal to automatic. If the startup type is equal to automatic, then it will list all those services. Press enter. As you can see guys, PowerShell has listed all the processes that start automatically when the system boots up. However, we can't actually verify whether these services start automatically or not. To fix this, we need to display the startup type property in the output. We need to format our output using the select object commandlet. So pipe the where object's output to select object, type select object space, type the property name, display name, then I want to display the status as well. Now type the startup type property, press enter. I need to resize my PowerShell console to accommodate all the specified fields. Press enter. As you can see, guys, we have the startup type property in the output, and here we have the automatic value. Now this commandlet is displaying all the services that start automatically when the system boots up. So that's it for this video, guys. In this video, we will learn how to combine multiple filters or conditions to produce accurate results. Now let's jump into the practicals. Let me execute get process commandlet, press enter. By default, the get process displays all the running processes on a system. Now, I only want to display the processes that are consuming the RAM between, let's say, 200 and 400 megabytes. I only want to display those processes. Here we have two conditions. The first condition says that the RAM consumption must be greater than 200 MB, and the second condition is that the RAM consumption must be less than 400 megabytes. Now to achieve this, we need to specify two conditions. It is actually easy. Type get process and pipe it to the where object, curly brackets, type the special variable dot. Now write the name of the property that you want to use for filtering. I'm gonna filter based on the RAM consumption. So type ws space, type gt means greater than 200 MB or whatever value you want. This is the first condition. It says that the RAM consumption must be greater than 200 megabytes. Now we need to specify the second condition. Type AND operator, special variable again, dot ws space lt less than 400 MB. This is the second condition. It says that the RAM consumption must be less than 400 MB. Now here we have this AND operator. This is the most important component of this entire command. AND operator allows us to combine multiple conditions. Here we are combining two conditions. The first condition says that the RAM consumption must be greater than 200 megabytes, and second condition says that the RAM consumption must be less than 400 megabytes. Now the way it is gonna work, when where object receives processes from get process commandlet through piping, it checks each process. If a process meets both of these conditions, then it displays that process, right? If a process is consuming more RAM than 200 megabytes, and it also checks if the same process is consuming RAM less than 400 megabytes. If it meets both of these specified conditions, then it will display that process. Let me hit enter. As you can see, guys, check out the RAM property. Here it is displaying only those processes that are consuming the RAM between 200 and 400 megabytes, or in this specified range. So guys, that's how you can combine multiple conditions. It is as easy as that. You just need to separate your filters or conditions with the AND operator. In this way, you can combine as many conditions as you like. In this video, we will learn about the Get-NetIp configuration commandlet. It retrieves or displays network configuration details such as all installed network interfaces, IP address, default gateway, MAC address, along with all other network details. It is similar to the ipconfig command. Now let's jump into the practicals. So type Get-NetIp configuration. Make sure that the spelling is correct. Now press enter. Let me scroll to the top. The Get-NetIp configuration displays all the installed network interfaces on your system, including virtual and physical interfaces. As you can see, I have interfaces starting with V. V stands for virtual. These interfaces are created for my virtual machines that I have installed on my system. Now I am specifically interested in my network details such as my IP address, default gateway, or maybe MAC address. Now to check your network configuration details, you have to check your network interface that you are using to connect to your network. I'm connected to my network through Wi-Fi or wireless card, so I will have to check the Wi-Fi section. So let me scroll down. It should be somewhere here. Here it is. As you can see, Wi-Fi interface alias displays the name of the network interface. Wireless card is represented by Wi-Fi. Then we have interface index, which is 18. Each network interface has a unique number assigned to it. So for Wi-Fi it is 18. This interface index number is going to be different for everyone. Then we have interface description. It displays the details about the network interface, specific details including its model number, the bands it supports, etc. And this is the IPv6 address and this is the IPv4 address, and down here is the default gateway. And if you are connected to your network through Ethernet cable, then you need to check the Ethernet interface. There you will find your network configuration details. Now as you can tell guys, the default Get-NetIp configuration command displays all the installed network interfaces on your system, right? However, in most cases we are only interested in a specific network interface. For example, I'm connected to my network through Wi-Fi or wireless card, so I only want to see details for my Wi-Fi. All other interfaces are not relevant for me. So to print the details of a specific network interface only, you can use all these fields or properties. I'm gonna use the interface index property. Interface index for Wi-Fi is 18. So type Get-NetIp configuration command space, type the name of the field or property space 18. Now this particular command is going to print details for the interface with index number 18. Index number 18 is for Wi-Fi, so it will print the details for the Wi-Fi only. Let me hit enter. As you can see guys, now it is only displaying details for the interface index 18, which is assigned to Wi-Fi. Similarly, we can use other properties such as interface alias. So interface alias space interface alias or name is Wi-Fi. So type the exact interface name Y-Fi, press enter. As you can see, it is producing the same result. Now guys, one thing that you can notice is it is not displaying the MAC address. I also want to check MAC address for my Wi-Fi or wireless card. So if you want to print more details, then you have to pass the detailed parameter to Get-NetIP configuration command. So type hyphen detailed. This time Get-NetIP configuration commandlet will print detailed information for the interface with index number 18. Press enter. As you can see, guys, this time we have the detailed information for the Wi-Fi, and here is the MAC address, link layer address. This is the MAC address. So guys, that's how you can print detailed information for a particular network interface. Now if you want the detailed information for all the installed network interfaces, then remove the interface index or whatever property you are using. Just type get net configuration command with detailed parameter. Press enter. Now it is displaying detailed information for all the installed network interfaces. So that's it for this video, guys. Thank you very much for watching. In this video, we are gonna learn how to use Get-Netadaper commandlet. The Get-Netadaper command in PowerShell is used to retrieve information about all network adapters on your system, including both physical and virtual interfaces. Now, Get-Netadaper is different from the Get-NetIP configuration commandlet that we covered in the previous video. Get-NetIP configuration displays information about the network such as IP address, default gateway, IPv6 address, etc. Get-Netadaper, on the other hand, displays information specific to the network card such as MAC address and supported speed, etc. It is a flexible tool for managing adapter related settings. So let's dive into the practicals. Type Get-Netadaper and press enter. The default Get-Netadaper command displays all the installed network interfaces on your system, including the physical and virtual interfaces. We have all these fields or properties, right? So let me quickly walk you through what all these properties mean. So first is name. Name displays the name of each installed network interface. Then interface description displays details about the network interfaces, including specific details such as model number, the bands it supports, etc. Then IF index number displays the index number assigned to each network interface. As we discussed in the previous video, each network interface has a unique index or interface index number assigned to it. So it displays the unique number assigned to each interface. Then status column displays whether a network interface is up and running or disconnected. And the most important part is this MAC address. It displays the MAC address for each interface. For example, for my Wi-Fi interface, this is the MAC address for my Wi-Fi. And the last field is link speed. Let me expand my terminal so it can accommodate all the fields comfortably. Now let me re-execute the command. And now as you can see, we have a very neat and compact output. So link speed displays the maximum speed that a network interface supports. Now let's print only the physical interfaces. The default Get-Netadaper command prints all the interfaces, including virtual and physical interfaces. I only want to print actual physical interfaces or devices that are installed on my motherboard. So type Get-Netadaper space. Now specify the physical parameter, type physical. Physical parameter will print only the physical interfaces or the actual physical network interfaces installed on your system. As you can see, I have these two physical interfaces. Wi-Fi wireless card is represented by Wi-Fi and the Ethernet card, which is represented by Ethernet. Most modern computers have these two physical network interfaces. Now let's narrow down this output. I only want to print the details of a Wi-Fi interface. Just like the Get-NetIp configuration command, we can use any of these properties to print details of a specific interface. I'm gonna use the property IFIndex. IFIndex for Wi-Fi is 18. I want to print details for Wi-Fi interface. So type Get-Netadaper space if index which is 18 for Wi-Fi. Now it will only print the details for Wi-Fi. Press enter. Sorry guys, I forgot to put hyphen at the beginning of IFIndex. Press enter. Now as you can see, it is only displaying the details for the index number 18, which is assigned to Wi-Fi. Now let's narrow it down even further. This time I only want to print the MAC address. I don't want to print all other fields like name, interface, description, etc. Just the MAC address. Here we have to use the piping. So type pipe character, select object. Now specify the name of the field. I'm gonna type MAC address, MAC. Press enter. Now as you can see, it is only printing the selected field, which is MAC address. Now I also want the name of the interface. So type name. Now this time select object is going to print the name of the interface and MAC address assigned to it. Press enter, and as you can see, it has printed the name of the interface, which is Wi-Fi, and its assigned MAC address. So guys, that's how you can use the Get-Netadaper command. In this video, we will learn about the Test-NetConnection commandlet. It is a very important command. It is similar to the ping command but much more advanced. The Test-NetConnection is used to check the status of a network connection. It provides information about whether a connection can be established to a specific destination such as a server or website. This commandlet is commonly used to diagnose network related issues, including checking the internet connectivity problems and determining latency. Now, apart from network diagnostic issues, it can also scan ports to determine whether they are open or not. This is a very valuable feature. Now let's jump into the practicals. Type Test-NetConnection space. Now specify the host name that you want to test. You can specify either an IP address or a domain name. I'm going to specify the domain name Google. Now the way Test-NetConnection command works, in the background it sends the ICMP packets to the specified host, which is Google in my case, then waits for the host to respond. Press enter. As you can see, the scan is complete. The first field is computer name. It displays the host name that you pinged or connected to, which is Google in my case. Remote address displays the IP address of the host that you pinged to, which is this. And interface alias displays the interface name that you are using to connect to your network. Then source address displays the IP address of the sender or who initiated the connection. This is my own IP address because my computer initiated the connection by sending ICMP packets to the Google. Then we have ping succeeded, which is true. This is the most important component in this output. Ping succeeded true means the connection was successful. My computer successfully connected or communicated with the specified host Google. Now if ping succeeded is true, it proves two things. One, my internet connection is working, because to communicate with any host on the internet you need a working internet. It also proves that the host that you pinged to, which is Google, is also up and running because it responded to the ICMP packets that the Test-NetConnection command sent to it. The communication was successful. So my internet connection is working and Google is also up and running. Now if you want detailed information, then what we can do is pass the information level parameter, then specify the detailed value. This time Test-NetConnection commandlet is going to display detailed information about the connection. So press enter. Now we have pretty much the same result. The new information that we have is the name resolution results, right? It is displaying not only the IPv6 address of the host that we pinged to, also its IPv4 address. As you can see, this is the IPv4 address for the host google.com. Now let's dive into the port scanning. Test-NetConnection command also allows us to scan for ports. So type Test-NetConnection space, specify the host name that you want to scan, space. Now to scan port numbers, type P or port parameter. Now specify the port number that you want to scan, let's say 443. This time Test-NetConnection is going to check whether the specified port number 443 is open or not. So let me press enter. As you can see guys, the most important field for us is this: TCP test succeeded true. It means the port number 443 is open. The scan was successful. Now let's scan another port number, let's say 22. Press enter. I think port number 22 is probably closed or filtered. As you can see, we already have the result warning TCP connect to this host and port number failed. So the port number is either closed or probably filtered. Now it is scanning using the IPv4 address. The result will be pretty much the same. As you can see guys, we have the output here. TCP test succeeded false. It means the port 22 is closed or filtered. Only authorized devices can initiate connection to the port number 22. So guys, that's how you can use Test-NetConnection command to test your connection and scan port numbers. We will start by understanding the very basics: what a computer network is, why computer networks are needed, and what is resource sharing with real world examples. Don't worry about cables and devices used in creating a network. We will cover those details in upcoming sections. A computer network is essentially a group of interconnected computers or devices. When two or more devices connect to each other, they collectively form a computer network. The connection can be wired like this or wireless. Now, why do devices need to be interconnected? Because data can only be exchanged if devices are connected to each other. So when devices connect, they form a computer network. Once connected, they can start sending data to each other. That's why computer networks are required, because it enables devices to send data to each other. This is the simplest possible computer network. Later in the course, we will learn about more complex and sophisticated networks being used today. Computer networks were developed in the early 1960s, and back then only computers were part of a network. However, computing has evolved significantly. Today, a computer network is not limited to interconnected computers. Devices such as mobile phones, servers, tablets, switches, routers, printers, smartwatches, and other smart devices are all integral components of a computer network. Now let's address the real questions. Why are computer networks needed and what is resource sharing? As we have already discussed, devices can only exchange data when they are connected to each other. This forms a computer network enabling data communication. Apart from data communication, a computer network offers resource sharing, which is the most important feature or component of a computer network. Let's understand resource sharing with a few real-world examples. A network can be either wired or wireless. In a wireless network, devices connect to the network using Wi-Fi, right? When you connect to a Wi-Fi network, you and all other devices connected to that network can access the internet, right? This is an example of resource sharing, where multiple devices connected to the same Wi-Fi network share or utilize the internet connection provided by the Wi-Fi network. Similarly, a computer network allows us to share devices like printers, scanners, servers, file servers, etc. Printers are essential devices in most offices, right? Now, without a network, each person or device would need their own printer, or they would all have to connect directly to the same printer. This is inconvenient, costly, and inefficient, right? Now, a network solves this problem by allowing devices on the network to share the printer. All we have to do is connect the printer to the network. Once you connect a printer to the network, then all the devices connected to the network can share or use the printer. They don't have to directly connect to the printer. Each device can use the printer whenever they need it. This is called the resource sharing that a network provides. Here I am showing you the printer being connected to a switch using a wire or Ethernet cable. However, printers can also connect to a wireless network or router. Nowadays, printers have wireless capabilities as well. Data sharing or file sharing is another common activity in offices and even in home networks. We can set up a file server where files can be stored and connect it to the network. Then everyone connected to the network can access the files. Otherwise, files would have to be sent to everyone individually, which can be time consuming. So guys, to summarize, a computer network allows devices to communicate with each other and share resources with other devices on the network. This saves money and makes it easier for people to work together. You will gain clarity on networks in the upcoming videos and sections. Now let's discuss types of networks. Computer networks are divided into different types based on their size and the geographic area that they cover. Some of the most common types of computer networks include LAN, MAN, WAN, WLAN, and personal area networks. In computer networking, the term packet is used all the time when dealing with data. A packet is a small segment of a larger file. When two devices exchange data over a computer network such as the internet, the data or file is first divided into smaller pieces or segments called packets. The packets are then transmitted to the receiver. Let's understand packets with an example for better clarity. Let's say device A wants to send a file to another device B over the internet. Now, the file is not sent all at once. Before sending the file, it is divided into multiple smaller parts or segments, and these segments are technically called packets in computer networking. Then each packet is sent independently to its destination. At the destination, the packets are reassembled in the correct order to form the original file. So a packet is just a piece of a larger file, and data is sent in a series of packets. Every web page, email, image, video or audio file that you send or download is transmitted in a series of different packets. At the destination, the packets are reassembled to form the original file. Now, why are files sent in this manner rather than all at once? Breaking a file into smaller packets improves data reliability. Let's say that if a packet is lost or corrupted during transmission, then only that specific packet needs to be resent. On the other hand, if you send a complete file all at once and it gets corrupted or lost in transit, the sender will need to resend the entire file. This would result in the waste of your bandwidth and network resources. Packets also improve efficiency. Dividing files into smaller packets allows each packet to take a different route to reach the destination. The maximum amount of data that a packet can carry depends on various factors such as the network technology being used and the specific protocol in use. The standard is currently 1500 bytes. The maximum size of data that can be sent in a single packet is 1500 bytes. There is a newer technology called jumbo frames. A jumbo frame can carry a maximum of 9000 bytes. We will discuss this further in the OSI model section in detail. Thank you very much, guys. IP address stands for Internet Protocol, and it is a unique number assigned to every device connected to a network or the internet. When you connect to a Wi-Fi network or a wired Ethernet network, your device is automatically assigned an IP address. Now, why is an IP address needed? An IP address identifies each individual device on the internet. An IP address helps locate devices on the internet. IP addresses ensure that data reaches the correct destination. Just like individuals or businesses use a home or office address for sending and receiving mail, devices on the internet also needs a digital address for sending and receiving data. Let's say that you want to send an email or any type of data to someone in a different country or location. To deliver the data, the sender needs to know the location or address of the receiver. Then the sender will be able to deliver the data to that address or IP address. So this is what an IP address does. It essentially helps locate the device on the internet. Therefore, each device on the internet must have an IP address if it wants to access the internet or communicate with other devices on the internet. A device can send data to any other device anywhere in the world based on the IP address. Remember that computers communicate with each other using IP addresses on the internet. Without IP addresses, devices can't exchange data over the internet. Each packet contains two IP addresses: the IP address of the sender who is sending the packet and the IP address of the receiver where the packet will be delivered. There are two versions of IP addresses, IPv4 and IPv6. IPv4 is the most commonly used IP address. Now let me practically show you how to view your own IP address. Press Windows key, type CMD. Now click on command prompt and here type the command ipconfig/all. Press enter and under the wireless LAN adapter Wi-Fi, locate the field that says IPv4 address. Here it is. As you can see, this is my own IPv4 address and this is the IPv6 address. This is the IPv6 address, and if you are connected to your network using an Ethernet cable, then you will find all these network details under the Ethernet section. Let me scroll up. Here it is, Ethernet adapter, Ethernet. So if you are connected to your network using an Ethernet cable, then you will find the network details under this interface, Ethernet adapter. Host is one of the most commonly used terms in computer networking, so it is important to understand it at the beginning of the course. In networking, a host is any device that can communicate with other devices on a network. This means that any device that can send or receive data is called a host, such as computers, laptops, smartphones, tablets, servers, etc. Now we have new additions to hosts in modern days. These additions include smart devices such as smartwatches, smart refrigerators, gaming consoles, smart TVs, etc. These smart devices are capable of communicating or sending and receiving data. Each host or device capable of interacting with other devices has a unique IP address. This IP address enables seamless communication between devices on the internet. Whether you are a network administrator or have any role managing a network, dealing with servers will be a common task. So what exactly is a server? First of all, a server is also a computer. The name server might sound very intimidating, but it is essentially just another computer. So what makes a server different from a regular computer? The only difference between a regular computer and a server is that a server is configured to provide or serve specific services to users. The term server denotes a computer or program designed to serve or provide services to users or other computers. What a server serves depends on what you want it to serve. We have different types of servers. For example, a web server serves websites to users. In simple terms, a web server provides access to websites. When you type, let's say, cybersecurity on Google, it returns results related to your search query, right? Now, it is the web server that processes your request. Your search query is received by Google's web server, which then processes it and sends back search results to your web browser. As I mentioned earlier, a server is essentially just a computer. So how did Google turn a regular computer into a web server that answers your questions? To turn a regular computer into a web server, we need to install and configure certain things. First, we need to install software called a web server. There are two popular free web servers called Apache and Nginx, but Google uses its own server called Google Web Server, which processes your queries. Apart from installing a web server, we have to configure other aspects such as domain name, port forwarding, etc. to make a website accessible to everyone. By following these steps, you can effectively transform any regular system into a fully functional web server. There are many types of servers such as web servers, mail servers, file servers, database servers, DNS servers, etc. A web server delivers websites to users, a file server facilitates file sharing, and a mail server handles email communication. When you send or receive an email, it is the mail server that makes this process possible. Gmail is the most popular email service offered by Google, and it runs on its own dedicated mail servers. Typically, we use dedicated servers for each service. To summarize servers, whenever you install a service on a computer that serves multiple users, that computer becomes a server. Keep in mind that the servers need to be reliable, robust, and powerful because the server typically needs to be up and running 24/7. Let's say if Google's web server goes down, you will not be able to use Google. If Google's server goes offline even for a few minutes, it could cost them billions. Servers are usually accessible to many people and can be used for a variety of purposes. So let's start with the Ethernet cable. We can connect to a network in two ways, either through a wired connection or wirelessly, right? We connect to a wireless network using Wi-Fi to access the internet and other network resources. And if you want to connect to a wired network, you need a wire. Now, the wire or cable that makes this possible is called an Ethernet cable. An Ethernet cable connects computers to a wired network. Wired network is also known as an Ethernet network. The Ethernet cable is also known as the network cable. Here is what an Ethernet cable looks like. The Ethernet cable has a connector on each end. These are called RJ45 connectors. To connect a device to a wired network, we need to connect one end of the Ethernet cable to a computer and other end to a device such as a switch or router. Once connected, you will be successfully connected to the network and can access the internet or other network resources. Ethernet cables not only connects computers to a wired network, they can also be used to connect other devices like printers, servers, or any other device that supports it. This is just an overview of Ethernet cables. We'll get back to it in a dedicated section. Now let's move on to the LAN ports. Each system has one LAN port. This is what a LAN port looks like. To find the LAN port on your device, look for a small rectangular port that looks like this. Now, when you connect an Ethernet cable to a device, this is where the Ethernet cable gets plugged in. The RJ45 connector of the Ethernet cable gets plugged into the LAN port of a system. A LAN port is also known as the network port or Ethernet port. Routers, switches, computers, even printers have the LAN ports. You can also directly connect to computers using an Ethernet cable because it has connectors on both ends. Connect one end to one device and other end to the other device and you will be connected. Once connected, both devices can exchange data. So what is a MAC address? A MAC address is a 12-digit hexadecimal number. This is what a typical MAC address looks like. Later I will show you the actual MAC address practically. MAC stands for Media Access Control. It is also known as the physical address or hardware address. A MAC address is assigned to a network interface card. A MAC address uniquely identifies a computer. The MAC address is embedded or burned inside the network interface card. Each network interface card, whether wireless, wired, or external, has a unique MAC address embedded in it. A MAC address is permanent and can't be changed. MAC address is divided into two parts. The first 6 digits identify the manufacturer that developed the NIC, and the remaining 6 digits identify the device itself. Now, let's address the actual question. Why is a MAC address needed? The MAC address is essential for data communication. If one device wants to send data to another device, it needs the MAC address of the receiver. In order for devices to exchange data on the same network or across different networks, they need MAC addresses of each other to exchange data between them. Here we have an obvious question. We also have IP addresses, right? What is the role of an IP address then, since the MAC address sounds similar to an IP address? Well, both MAC address and IP address work together to deliver data to the destination device. Remember, an IP address is not permanent. It keeps changing. Your ISP typically assigns a new IP address to your network or mobile phone automatically after a certain period of time. When you move to a new location or country, the internet service provider of that area also assigns you a new IP address. Therefore, we require a system that can pinpoint a device's location, and this is accomplished by the IP address. The main purpose of an IP address is to locate your current location. On the other hand, a MAC address is permanent and can't be changed. Therefore, we need both to communicate with other devices. The IP address is used to locate the device's current location after locating the device. The MAC address or physical address is used to deliver data to the actual physical device. Let's say there were no IP addresses. In this case, other devices or networks would assume that you are in the same location or network, even if you change your location or network, because MAC addresses are fixed. Therefore, we need IP addresses to differentiate devices based on their location, and an IP address gets updated based on your location. When you move to a new location, the ISP or internet service provider of that area automatically assigns a new IP address to your device. IP addresses are essential for sending data to devices in different networks or locations. An IP address locates the device, and the MAC address is used to deliver data to the physical device. Devices on the same network can communicate directly using their MAC addresses. We don't need IP addresses to communicate in the same network. Now, let me practically demonstrate how to view your own MAC address. Press Windows key, type CMD, click on command prompt, and here type ipconfig /all, press enter, and under the wireless LAN adapter Wi-Fi, locate the field that says physical address. Here it is, physical address. This is how a MAC address looks like. This is my own MAC address for my wireless LAN adapter. As we have already discussed, the MAC address is also known as the physical address. Now, each network interface card has a unique MAC address. So this is the MAC address for my wireless LAN adapter, and let me find the MAC address for my Ethernet card. Let me scroll up. Here it is. As you can see, this is my wired Ethernet adapter, and this is the physical address or MAC address for my Ethernet adapter. To understand hubs, let's first discuss why hubs and similar devices are needed. This will provide the necessary context to understand hubs and switches. Suppose computer A wants to send data to B. To send data, first we need to connect these two computers directly with an Ethernet cable or by using a wireless connection. Once you connect them, it technically is a computer network. When two or more devices are connected to each other, it is called a computer network. Now, both connected devices can send data to each other. Obviously, it is the simplest possible network. This method of connecting devices directly to each other works well for two devices. However, if we add a third computer, we then need to connect it to both of the other computers for them to communicate with each other. If we continue adding more computers, we must connect each new computer to all of the existing computers. As the number of computers increases, connecting them all directly becomes increasingly difficult and inefficient. So wiring gets overwhelming. Now, hubs were developed to solve this exact problem. A hub was developed to simplify network connectivity. A hub simplifies how devices connect to each other and communicate efficiently with minimal wiring. A hub is a central multi-port device with multiple ports where various devices can connect. To connect a system to the hub, an Ethernet cable is required. An Ethernet cable has connectors at both ends called RJ45 connectors, right? To connect your computer or any device to a hub, connect one end of an Ethernet cable to the system and other end to the hub's LAN port. Similarly, other devices can connect to the hub using Ethernet cables. Once you connect your system to a hub, you can communicate with all the devices that are connected to the hub. Now, your computer is part of this LAN network. A LAN network can be created using a hub. When multiple devices connect to a hub, they collectively form a computer network. This is a LAN network. These connected devices can send data to each other through the hub. The hub manages communication between all the connected devices. Now let's understand how a hub facilitates communication between devices. The way a hub works is that when it receives a packet, it sends that packet to all the devices connected to it. Let's say that A wants to send data to C. The packet first goes to the hub and the hub broadcasts or sends the packet to all devices connected to it, including the destination device C. The hub basically copies the packet to all its ports. However, by default, all other devices reject or discard the packet except for the intended device C. Only the destination device C accepts the packet. Each packet contains the MAC addresses of the sender and receiver. When the packet arrives at device C, it checks the destination MAC address in the packet to see if it matches its own MAC address. If the MAC addresses match, then device C accepts the packet because it is intended for it. So that's how a hub works. Each packet that arrives at the hub is sent to all the connected devices. However, only the device for which the packet is intended accepts it, while others reject it. Similarly, all other devices connected to the hub can send data to any device that is connected to it. The communication flow remains the same. The packet that one system sends to a specific system connected to the hub is sent to all other devices connected to it. This is a drawback of a hub. We we will discuss it in the next video. So guys, that's how a hub simplifies connectivity. You only need an Ethernet cable to connect to the network or hub, and then you can communicate with all other devices connected to it without having to connect to them directly. A switch is essentially an improved version of a hub. It is an advanced networking device that addresses the limitations of hubs. It offers significant improvements in network performance, security, and efficiency. A hub has two major flaws. It lacks intelligence and is insecure. When a hub receives a packet, it forwards it to all connected devices, even if the packet is not intended for them, leading to unnecessary data exposure and potential security risks. This creates a security concern because by default, devices connected to a hub only accept or receive the packet that are sent to them. However, a computer or network card can be configured to accept packets that are not sent to it. Now, this modification makes the network less secure because devices can potentially receive and process data packets that are not sent to them, and they could potentially intercept and steal sensitive data being exchanged between other devices. Another drawback of a hub is that it generates unnecessary network traffic because instead of sending packets directly to the intended receiver, a hub sends all packets to all connected devices. This can lead to bandwidth congestion and slow down the network for all users. Now, the switch basically addresses these two problems or limitations of a hub. The switch is similar to a hub. This is how a switch looks like. A switch is also a multi-port central device with many LAN ports. The total number of ports in a switch depends on the size and type of switch. Most switches have a minimum of 5 LAN ports, and there are switches with 12, 24, and 48 ports as well. The switch allows computers or other devices to connect to a network through an Ethernet cable, so that they can communicate with each other and access the internet and network resources. The process of connecting a device to a switch is the same as we discussed in the previous video. We have to connect one end of the Ethernet cable to the computer and other end of the Ethernet cable to the switch. We can connect computers, servers, or printers to a switch using an Ethernet cable, which allows them to communicate with each other. Once you connect devices to a switch, it creates a LAN or local area network. A simple LAN can be created using a switch by connecting devices to it. Unlike a hub, a switch is a smart device. The way a switch works is that it stores the MAC address of each device connected to it. A switch basically learns which device is connected to which port by maintaining a MAC address table. The MAC address table stores the MAC address of each device connected to the switch and the port number on which the device is connected. For example, if device A connects to port 1 on the switch stores its MAC address in its MAC address table along with the port number to which it is connected. This is how the entry looks like in the table. This means that computer A is connected to port number 1. The switch does this for every device that connects to it. It stores the MAC address of each device and the port number to which they are connected. And how a switch exactly acquires the MAC addresses will be covered in a separate video. Now let's see how a switch works and forwards data. Let's say device A wants to send data to C. The packet first goes to the switch. every packet contains two MAC addresses, the MAC address of the sender and the MAC address of the receiver or destination where the packet needs to be delivered. Now the switch checks the destination MAC address in the packet and matches it against the addresses in the MAC address table. If the destination MAC address is found in the table, then the switch forwards the packet to the port number associated with that MAC address. In this case, the destination MAC address is at port number 3, so the switch forwards the packet to the device C. So unlike a hub, it sends packets only to the intended device. Similarly, if any device connected to the switch wants to communicate with another device, the same process is followed. The packet goes to the switch checks the MAC address table and forwards the packet to the destination. A switch is capable of reading MAC addresses, whereas the hub can't read MAC addresses. That's why it forwards packets to everyone. So guys, that's how a switch works. The data is delivered or forwarded only to the intended device, making it secure. A switch is among the most commonly used devices today. In wired network, a switch is always the preferred device. We are continuing where we left off in the previous video. In this video, we will discuss routers. Routers are extremely important. Now, to understand routers, let's first review the central devices we have already covered, such as hubs and switches. This will help us understand routers more clearly and provide the context for understanding routers and their requirements. A hub or switch allows devices to communicate with each other within the same network or local area network, right? The devices connected to a switch can communicate with each other easily. Now let's say that device A wants to access Google or the internet. However, Google server is not available within the network or LAN. It is located somewhere on the internet. Therefore, to access google.com or the internet, computer A and all other devices in the network must leave their own network to reach or access Google. A switch can't route or send data outside of the network. It is designed to facilitate communication only within the same network or LAN. So we need a device that can route or send data packets outside of the local area network. That device is a router. A router allows devices on LAN networks to communicate with external networks such as the internet. This is how a router looks like. So to access the internet, we must connect the switch to a router and the Ethernet cable is used for this connection. Just connect one end of the Ethernet cable to any LAN port of the switch and other end of the cable to the LAN port on the router. A router has at least one LAN port. Once the switch is connected to the router will connect your network to the internet. Now, devices connected to the switch or network can access the internet. Now, when any device on the LAN network needs to access anything on the internet, the switch forwards packets to the router and the router sends the packets to the destination. A switch understands MAC addresses, which means it forwards packets based on the destination MAC address. On the other hand, a router understands IP addresses. A router forwards packets based on the destination IP address in the packet. Now let's understand the complete communication flow with an example. Let's say device A wants to access Google. The packet first goes to the switch and then the switch forwards the packet to the router. As mentioned earlier, routers work with IP addresses. The router checks the destination IP address in the packet. In my case, the packet contains IP address of Google, and based on this destination IP address, the router forwards the packet to the Google, and the reply that Google sends back to device A will follow the reverse path like this. Packet arrives at the router, which forwards it to the switch, and the switch forwards it to the destination device A. Similarly, if any other device connected to the switch or wirelessly wants to access the internet, communication process remains the same. Remember that most routers also have a built-in switch. You can directly connect computers to a router using an Ethernet cable. However, a router typically doesn't have many LAN ports, so a dedicated switch is typically used for wired connectivity and provides connections to more devices. So if you are directly connecting to the router, it means the router has a built-in switch. Another very important function of a router is to select the path that packets need to take to reach their destination and then forward them. The internet is essentially a huge collection of interconnected networks or LAN networks. This means that different networks communicate with each other to forward data to the correct destination. The networks communicate with each other through routers. Routers connect the networks. Therefore, each network must have a router if it wants to access the internet. Since the internet is a web of interconnected routers, data must go through these routers to reach its destination. The job of a router is to select the best available path that packets need to go through to reach their destination. This is called routing. Routing is the process of selecting the path that data must go through to reach its destination. There are two main types of routers: wireless routers and wired routers. A wireless router allows devices to connect to a network wirelessly using Wi-Fi. A wireless router is used to create a WLAN, wireless local area network. On the other hand, a wired router allows devices to connect to the router using a wire or an Ethernet cable. These routers are mostly used in home networks and small offices. Keep in mind that a wireless router typically supports both wired and wireless connectivity. A wireless router may or may not have multiple LAN ports. However, each wireless router has at least one LAN port. So far, we have learned about fundamental network devices like switches, routers, and Ethernet cables. Now, the only missing mandatory component needed to create a functioning network is a modem. So in this video, we will learn what a modem is, how it works, and the difference between a modem and a router. So let's first understand what a modem is and why it is needed. The modem, in simplest terms, brings the internet to your home or office. It essentially connects your LAN network to the internet. Suppose you decide to set up a broadband internet connection at your home or office. In this case, you will first need to contact your local internet service provider and purchase a broadband connection from them. To provide internet access to your location, your ISP will use a cable or wire to connect your home to the ISP's network. To deliver the internet, a modem essentially maintains a dedicated physical connection from your home or office to your internet service provider. The cable provided by your ISP is plugged into the modem. Now, modem needs to be connected to the router. The cable used for connecting the modem to the router is an Ethernet cable. connect one end of the Ethernet cable to the LAN port on the modem and the other end to the WAN port on the router. I am repeating again, connect the other end of the Ethernet cable to the WAN port on the router. There are two types of ports on routers, LAN and WAN. The WAN port essentially connects your network to the internet. You might also see internet instead of WAN port. They are both the same thing. Once you connect your router to the modem using the WAN port, you will be able to access the internet. Most routers have several LAN ports, typically around 3. You can connect your computers to these ports and access the internet. If you need more Ethernet ports for wired devices, you can connect a switch to your router as we discussed in the previous video. Routers can be either wireless or wired. If your router is wireless, devices on your network can access the internet using Wi-Fi. Now you have a functioning network. Now let's discuss some of the technical details and main functions of a modem. A modem converts analog signals to digital signals and digital signals to analog signals. This conversion is absolutely necessary because the wires or physical cable infrastructure that brings the internet to homes and offices use analog signals. The data is transmitted in analog form through the wires. However, computers and other digital devices only understand binary language or digital signals, zeros and ones. So we need a device that can convert analog signals to digital signals and vice versa. The modem is that device. Modem stands for modulator demodulator. Modulation is the process of converting digital signals to analog signals, and demodulation is the process of converting analog signals back to digital signals. When the analog signals arrive at the modem, it converts them back to digital signals so that computers and other digital devices can understand or read them. The modem can be a dedicated device, but now they are often built into routers. These days, a router has a built-in modem. This means that you can have a router that also functions as a modem. However, there are still some cases where you might need a dedicated modem, such as if you have a very high-speed internet connection or a complex network setup. Now, the modem seems to be very similar to the router, right? However, there is a difference. A modem is a device that connects your home or office to your internet service provider through a physical connection or wire. It brings the internet physically to your place. On the other hand, a router allows devices connected to the network to access the internet, as we discussed in the previous video. Routers also decide the path that packets must pass through to reach the destination. We are going to wrap up this section with wireless access points. It is another important device used in computer networks. So in this video, we will learn about the wireless access point and the difference between a wireless access point and a router. Sometimes people mistake both devices for being the same. A wireless access point is also known as a wireless AP. This is what a wireless access point typically looks like. It typically has external antennas. However, some access points have built-in antennas as well. Now, before we discuss the wireless access point in detail, let's talk about routers briefly. Then we will be able to understand why wireless access point was developed. There are two types of routers, wireless routers and wired routers. A wireless router supports wireless connections, allowing different devices to connect to the network wirelessly using Wi-Fi. On the other hand, the wired router does not support wireless connectivity. You can't connect to a wired network or router using Wi-Fi. We have to use the Ethernet cable to connect to a wired router. Now let's say that you have a wired router that does not support wireless connectivity, and you want to enable wireless connectivity so that devices can connect to the network wirelessly using Wi-Fi. This is where the wireless access point comes in to solve the issue. A wireless access point is a network device that allows devices to connect to a network using Wi-Fi or wirelessly. Now, to enable wireless connectivity, we need an Ethernet cable. Simply connect one end of an Ethernet cable to the wireless access point and the other end to the wired router. The wireless access point can also be connected to a switch as well. Now it will start transmitting the radio waves. Now devices such as computers, mobile phones or tablets can connect to the network wirelessly using Wi-Fi. So an access point is a device that allows wireless devices to connect to a wired network. A wireless access point can also be used to extend the range of a wireless network. Wireless access points are frequently used in homes, businesses, and other public places to extend the reach of a Wi-Fi network and offer improved coverage. Let's say if you have a large office with multiple blocks and many people, a wireless router has limited range and it can't provide connectivity to everyone in the large block. This is where we can use the wireless access point. You can add one or more wireless access points to extend the Wi-Fi signal to all areas of your office or home. To do this, you simply need to connect the wireless access point to the main router using an Ethernet cable. Once the access point is connected to the main router, it will provide access to the wireless network. Now, devices from all corners can access the network using their Wi-Fi. All the devices are connected to a single network using different access points. This entire network is managed by the main router. If any device on the network wants to access the internet, the packets have to go through the main router. Everything is managed by a single router. Wireless access points are well suited for such setups or large offices because they are easy to manage. Alternatively, you can also use wireless routers instead of wireless access points to provide wireless connectivity to everyone by placing individual wireless routers instead of wireless access points. However, this can create manageability problems. For example, if you use wireless routers instead of wireless access points, you will need to configure each router individually if you want to make changes to the network. However, with wireless access points, you can manage the entire network using a single router. This is because wireless access points are typically connected to a central router, which allows you to configure all the APs from a single location or device. Now let's talk about difference between a wireless router and wireless access point. Wireless routers and wireless access points are two different devices with distinct capabilities. A wireless router can support both wired and wireless connections. Typically, a router has multiple features such as a built-in switch, firewall, DHCP server, etc. A router supports all these features. On the other hand, the sole purpose of a wireless access point is to provide wireless connectivity and extend the network coverage. It only transmits radio waves so that devices can connect to the network wirelessly. That's all you need to know about the wireless access point. The OSI model is one of the most important topics in computer networking. The OSI model is the foundation for understanding network architecture. Alright, so what is the OSI model? OSI stands for Open Systems Interconnection. In simple terms, if you want to understand how two devices sitting in different countries or on the same network are able to communicate and send data to each other, then the OSI model is your answer. The OSI model basically explains each component involved in sending and delivering data from one computer to another over the internet, such as how data is prepared before it leaves the sender's computer, how it travels through various paths or networks to reach the destination, and finally how data is processed and received by the destination device or receiver. Sending data from one device to another over the internet is a very complex process that involves many steps. Let's say you want to send a file to someone who is sitting in another country or network. Your system has to figure out where to exactly send the data, how to send it, and make sure that the data is delivered to the receiver without any errors, etc. So the OSI model helps us to understand all of these steps involved in the process of sending and receiving data over internet in detail. That's why OSI is essential in computer networking. As a network administrator or cybersecurity engineer, learning the data communication process is the most fundamental thing. The OSI model is a 7-layer model. Transmitting data over the internet is a complex task. To simplify this problem, OSI divided all the functions into 7 smaller parts. In technical terms, these parts are called layers, OSI layers. Each layer of the OSI model is assigned specific tasks or responsibilities. The reason for splitting the OSI model into 7 layers is simple. It makes it easier to detect and solve problems separately. This layered approach can easily tell us in which part the error or problem is. All 7 layers work together to transmit data from one device to another across the globe. The OSI model is very useful for troubleshooting network problems. Network engineers always use the OSI model to detect and troubleshoot network problems. Once you understand the function of each layer, it helps us pinpoint errors to specific layers. Using OSI, we can narrow down and isolate the errors or possible causes of the errors to a specific layer and resolve it more quickly and easily. The layered approach works best for troubleshooting. The first layer in the OSI stack is the application layer. The layers in OSI are numbered from bottom to up. The application layer is the 7th and the first layer from the top. Now the application layer is closest to us, the end users. Application layer allows us to access or use different network services such as sending emails, making video and audio calls, transferring files, browsing websites, etc. We access or use these network services using various network applications. Network applications are those that depend on the internet for communication, such as Zoom for video calls, web browsers like Chrome or Firefox for browsing websites, Outlook for emails, and FTP clients for file transfers, etc. All of these are network applications. Now, to be very clear, Network applications are not part of the application layer. They don't reside within the application layer. Network applications depend on the application layer to function properly. The job of the application layer is to provide the protocols that various network applications need to function correctly. The application layer communicates or interacts with network applications through its protocols. Each layer of the OSI model has its own set of protocols. The application layer has many protocols such as HTTP, HTTPS, Telnet, SIP, SSH, FTP, etc. Network applications depend on these protocols to function correctly. Let's understand this with a few examples. When you browse a website, it is the HTTP protocol that makes the web surfing possible, allowing you to view websites. At the beginning of each URL, you will see either HTTPS or HTTP, right? All web applications depend on the HTTP or HTTPS protocol to function properly. HTTPS is essentially the secure version of HTTP. That's why you see HTTPS at the beginning of most website URLs. Both protocols are part of the application layer. When you visit a website, your network application such as Firefox interacts with application layer using the HTTP protocol. If you send or receive an email, it is done using the SMTP protocol. SMTP protocol manages emails. File transfer is done through FTP protocol. Video calling applications like Zoom or Discord use the SIP protocol along with other protocols. SMTP, SIP, SSH and FTP, all these protocols are part of the application layer. Therefore, all network applications or services rely on application layer protocols to function correctly. So to summarize, the application layer provides the required interface and protocols for network applications to function. Each layer of the OSI model coordinates with specific devices. The OSI model is all about explaining data communication process, and in computer networking, it is the actual physical devices that make data communication possible, right? Therefore, each layer of the OSI model coordinates with specific devices. And the application layer devices are those that we use to access network applications or generate data, such as personal computers, mobile phones, laptops, tablets, etc. We run networking applications on these devices to access websites, make calls, and transfer files, etc. So these devices operate at the application layer. Servers are also application layer devices. The data or protocol data unit at the application layer is simply called data. We will learn more about it in later video. The presentation layer receives data from the application layer. The presentation layer performs 4 main tasks: translation, encryption, decryption, and compression. Let's discuss them one by one, starting with translation. The presentation layer receives data from the application layer in its raw form. It can be characters, numbers, images, or any other data generated by users through network applications. Therefore, it translates or converts the data into a format that a machine can understand, which is binary, ones and zeros. The raw data gets converted or translated into binary. Presentation layer is also responsible for translating data into a syntax or format that the application layer of the receiving device can understand. The two devices that are communicating might use different encoding methods. Encoding in computers is the process of converting data such as text, images, audio, or any digital data into a format that can be stored or transmitted electronically. For example, when you press, let's say, the key A on your keyboard, A is converted into a binary code using an encoding scheme like ASCII. The data can only be stored or transmitted after it is encoded. This binary code is then stored in the computer's memory or transmitted over a network. Similarly, all types of data such as audio, video, and images are converted into binary. Encoding is a separate topic that will be covered in a dedicated section. There are different encoding schemes such as ASCII and EBCDIC. Let's say the sender uses the ASCII scheme for encoding data and the receiver is using the EBCDIC method or scheme. Then the presentation layer converts ASCII to EBCDIC so that the receiving device can understand the data and display accurately. Without converting one format to another, data will not be displayed or represented accurately by the receiver. Encoding is a vast topic beyond the scope of this video or section. Just understand that if needed, the presentation layer can convert one encoding scheme to another. This is called translation in the presentation layer. Another important responsibility of the presentation layer is encryption and decryption. When two devices are communicating over an encrypted connection, the presentation layer handles encryption and decryption. Encryption is used to protect your data from cybercriminals. HTTPS websites are examples of encryption. When you visit an HTTPS website, your data is encrypted before it leaves your system. Encryption is simply the process of making data unreadable before sending it to the destination. Now, if a hacker or cybercriminal intercepts the data or your communication, they can't see what you are sending or receiving. They will only see the encrypted text. Only the receiver can see the original data because the data is decrypted back to its original form only at the receiver's device. Only the receiver can decrypt the data. All the big applications and websites use encryption to protect your data. Like I mentioned earlier, in the application layer, each layer has its own set of protocols that manage different things. In the presentation layer, we have the TLS protocol, which is responsible for encrypting and decrypting data. So encryption, decryption, and data security are handled by the presentation layer. The presentation layer is also responsible for data compression, which is a method used to reduce file size. It achieves this by reducing the number of bits that represent the original data. It uses compression algorithms or techniques to reduce the size of files so they can be transmitted more quickly. Compressing data does not impact the file itself. It merely reduces the file size and the receiver will receive the complete file. These are the protocols at the presentation layer. The session layer receives data from the presentation layer. It is responsible for managing sessions, authentication, authorization, and creating checkpoints. Let's first discuss the session management. The session layer controls the sessions between devices that are communicating or exchanging data. A session is essentially the period of time when two devices start their communication and when they stop communicating or end their communication. The session layer is responsible for creating, maintaining, and terminating sessions. It maintains session between communicating devices. Your computer can communicate with multiple websites or servers simultaneously, right? You might be logged in to Amazon at the same time. You can be browsing other websites such as YouTube, Wikipedia, etc. To manage this effectively, the session layer creates a unique session for each server or device that your device is communicating with. It assigns a unique ID to identify each session. It maintains separate sessions for each device and keeps track of which data belongs to which session or server. The session layer keeps the session open until both devices finish their data exchange. When you log out of website or exit the web browser, the session layer terminates the session. That's the session management. Now let's discuss authentication. Authentication is the process of verifying the identity of a user. It is typically performed by the server. Let's understand authentication with real-world examples. Suppose you want to log in to your Amazon account. Before logging in, you must verify your identity by providing your username and password, right? After submitting your login credentials, Amazon authenticates or verifies your credentials and allows you to log in if they are correct. This is an example of authentication in the real world performed by the session layer. When authentication is successful, the session layer creates a new session. The session is typically created after the server successfully authenticates the user's login credentials. A session represents the period during which a user stays logged into a system or application, and the session is terminated when the user logs out of the application. Now let's move to the authorization. Authorization is the process of determining what users are allowed to do after they have been authenticated or logged in. For example, after you log in to your Amazon account, you are authorized to browse and purchase items. However, you are not authorized to change the price of items. Authorization determines what actions a user is permitted or not permitted to perform. Now the next important function of the session layer is creating checkpoints. A checkpoint is also known as session restoration. Checkpoints are a way to save the current state of a session so that it can be resumed later even if session is interrupted. When a session is terminated abruptly, it preserves the session as it was at the time of disconnection or interruption. Let's understand this with examples. You may have noticed that when you download a file using download managers like IDM or FDM from the internet and your internet connection is abruptly disconnected or disrupted, and when you reconnect to the internet again, the download resumes from the exact point where it was interrupted. It does not start downloading from zero, or you can also pause the download and resume it later. This is because the session layer keeps track of what has been downloaded by establishing checkpoints. In the event of a sudden disconnection or pausing the download, these checkpoints help resume the session from the last point where the disruption occurred. Another example that you have likely experienced is when your web browser crashes or shuts down suddenly, and when you open it again, you may see a restore button, right? Clicking on this button will reopen all the tabs that you had opened prior to the browser's abrupt shutdown. This is also an example of session restoration or checkpoints. The transport layer receives data from the session layer. The functions of the transport layer include segmentation, flow control, error control, process-to-process delivery, and reliable and unreliable data delivery. The transport layer will be covered in two videos. This is the first part where we will discuss segmentation and process-to-process delivery. Let's start with the segmentation first. Segmentation Segmentation simply means dividing data or a file into smaller parts. These parts are called segments in technical terms. That's why the protocol data unit or data at the transport layer is called segment. Now, why a file needs to be segmented? Well, computers don't send complete files all at once. Let's say that A wants to send a file to B. Now, the file is not sent all at once. Instead, it is first divided into smaller segments, and then each segment is sent independently to the receiver. Let's understand how segments are created. The transport layer receives data from the session layer in the raw form of continuous binaries, ones and zeros. Now the transport layer takes the bits and converts them into bytes. The transport layer deals with data in the form of bytes. After converting bits into bytes, the bytes are then put into segments. Each segment is a collection of bytes. Each segment contains a specific number of bytes. The bytes are numbered sequentially within each segment. Each byte has a unique sequence number assigned to it. The sequence numbers help to reassemble data packets or segments in the correct order, even if segments arrive out of the order at the destination. For the sake of simplicity, let's assume segment 1 contains 5 bytes and your sequence numbering starts from 2001. Your operating system selects a random number for the first byte and then increments the number by 1 for each subsequent byte. So the sequence number for the first byte is 2001, for the second it is 2002, and so on until the last byte in the segment, which is 2005. In the second segment, the sequence numbering continues from where the last segment ended. Therefore, the first byte will have the sequence number 2006, the second 2007, and so on until the last byte in the segment, which is 2010. This is how sequence numbers are assigned for each segment. If there is a third segment, its sequence number will start from 2001 because the previous segment ended at 2010. Now these sequence numbers help to reassemble the data in the correct order to form the complete file. Each segment is sent independently to the destination and then reassembled in the correct order to form the original file. So to sum up, the segmentation in transport layer takes the data or a file, then breaks it into many segments, and then each segment is sent separately to the receiver. Segments are transmitted over the internet to their destination by another protocol called IP in the form of packets. Now next important responsibility of the transport layer is process-to-process delivery. This is also called end-to-end or port-to-port delivery. Okay, let's break this down. Process-to-process delivery helps devices deliver data to the correct processes. A computer typically runs multiple processes simultaneously, right? A process simply refers to an application program that is running. In technical terms, when you execute or start a program, it becomes a process. For example, when you start Firefox, it becomes a process named Firefox while it runs. Now think about it. You can browse multiple websites in different tabs, make video or audio calls, and send emails at the same time from a single device, right? When you have multiple applications or processes running, how does the system determine which process to send data to? When a system receives data, how does it know to which process the data needs to be delivered, which process the data belongs to? So computers need a way to identify each running process so that data can be delivered to the correct process. To achieve this, computers use something called port numbers. Port numbers identify each running process on a system and help deliver or forward data to the correct process. The operating system assigns a unique port number to each running process or network service. So after creating segments, the transport layer adds the source and destination port numbers to each segment. Source port refers to the port number of the sender's device and destination port refers to the port number of the receiver or destination's device. There are a total of 65,535 port numbers. However, the first 1023 port numbers have specific or predefined rules. These ports are reserved for well-known services such as websites, email, file transfer, etc. For example, port number 80 is always used for HTTP traffic or websites, and port number 443 is the default port for HTTPS traffic, which is a secure version of HTTP. Suppose you visit an HTTPS website. When the request or packet reaches the destination server, the request is forwarded to port number 443 because port number 443 processes HTTPS traffic. Port number 687 is reserved for emails where it processes the email data. Now let's understand the entire process-to-process delivery with real-world examples to gain more clarity. Let's say you want to access google.com. As I mentioned earlier, the transport layer adds two port numbers to each segment, the source port and the destination port numbers. The operating system selects a random port number for the source port. Let's say 1111. Source port means the port number of the sender's device. However, the destination port number will be 443 because the device is attempting to access Google. Google uses HTTPS and port number 443 processes the HTTPS requests. And the default port for HTTPS is 443. Now, when the packet reaches the destination at Google's server, there are obviously multiple processes running on the server. The server checks the destination port number in the segment, which is 443. So, it forwards the segment to the process or port number 443, where a program called a web server processes the request. Now, Google sends back the reply to A. Before sending the reply, Google swaps the port numbers. This time, Google is the sender, so the source port number will be 443 and the destination port number will be 1111. Now, when the segment reaches destination A, it checks the destination port number, which is 1111, and sends the segment or data to the intended port or process associated with that port. Now, let's say that device A accesses another website called YouTube in a new tab. Then the operating system will generate a new random port number for the new tab or website. Let's say the port number is 2222. So the source or sender port number is 2222 and destination port number is 443. When the YouTube sends a reply back to A checks the destination port number, which is 2022 this time, and then forward it to the process or tab associated with the port number, which is 2022, and the data or segment finally gets displayed in the tab. And when you open a new tab or launch another process like Zoom, the operating system assigns a unique port number to each process. Each tab and process has its own unique port number acting as a unique identifier. That's how data is directed to the correct process by computers. Now let's move on to the flow control. Flow control at the transport layer is a mechanism used to control and manage the flow of data between two communicating devices. Flow control determines the amount of data that needs to be transmitted or sent to the receiver. If the sender sends more data than the receiver can handle or process, then the data will be lost and wasted. Flow control makes sure that the sender does not send more data than the receiver can handle or process. Let's take an example. Suppose you are downloading a file from the internet. The server from which you are downloading the file can transfer data at 100 Mbps rate, but your network has a slow internet connection and can only process or accept data at 5 Mbps speed. Now, if the server starts sending data at a rate of 100 Mbps, which is significantly faster than your network's processing capacity, the data will obviously be lost and wasted. This is because your device can't process or receive data beyond its current speed of 5 Mbps. Now the transport layer controls the data flow, how much data should be transmitted to the receiver. Before sending data, transport layer asks the receiver how much data it can process. The receiver then informs the sender about its receiving capacity. The receiver advertises or tells how much data it can process. The sender then sends the data at the rate that the receiver has advertised or informed the sender. Flow control is managed through window size. You will learn more about it in the TCP section. This is a basic overview. Another important function of the transport layer is error control. The transport layer makes sure that error-free data is delivered to the receiver. If the data becomes corrupted or does not reach the destination, or someone modifies the data before it reaches the destination, then it is the responsibility of the transport layer to resend the corrupted or lost data segments. It uses the automatic repeat request algorithm to retransmit the lost or corrupted data. The transport layer adds a checksum to each segment to ensure that error-free data is delivered to its destination. The checksum essentially checks for any edits or modifications in the data. If the data is modified after leaving the sender's device, the transport layer checks for data modifications at the receiver's device to ensure that the data was not altered or modified. If it is found to be modified, it is dropped. Now let's discuss reliable and unreliable data delivery. The transport layer provides both reliable and unreliable data delivery depending on the needs of the application. We have two major protocols at the transport layer, TCP and UDP. We also have SCTP, but UDP and TCP are the most commonly used and dominant protocols. TCP and UDP are used for different types of applications. TCP protocol provides reliable data delivery, meaning that it guarantees that the data will be delivered to the receiver in the correct order and without any errors. On the other hand, UDP provides unreliable data delivery, meaning that it does not guarantee that the data will be delivered to the receiver. Now, most applications need to receive all of the data in the correct order without any missing parts. TCP ensures that this happens. The transport layer uses TCP protocol for applications where guaranteed data delivery is mandatory, such as emails, chat systems, web browsing, and file downloading, etc. For example, when you download a file from the internet, the transport layer uses TCP to ensure that the entire file is downloaded correctly without any missing parts. Similarly, the transport layer uses TCP for other applications such as emails, web browsing, etc. TCP is a connection-oriented protocol because in order to guarantee data delivery, TCP establishes a connection between the sender and receiver before exchanging the data. Now let's talk about unreliable data delivery. The transport layer uses the UDP protocol when guaranteed data delivery is not a priority. Some applications such as live streaming, VoIP audio or video calling, and online gaming don't care about the guaranteed data delivery. For example, if you are watching a live stream and your internet connection stops or you get disconnected for a few seconds, when you reconnect, the stream will not resume from where you left off. Instead, it will only show you the current live content. The packets that were lost during internet disruptions are not retransmitted in this case, because if the lost packets were retransmitted, then it would no longer be a live stream. UDP keeps sending data regardless of whether it reaches its destination or not. UDP is fast. It is a connectionless protocol, meaning that it does not establish a connection with the receiver like TCP does. The transport and all other layers of the OSI model relies on protocols to complete tasks. Each layer has its own set of protocols. Everything is done using the protocols. These are the devices and protocols at the transport layer. As you learn more, you will start connecting concepts or dots and making sense of them. This is just the beginning. The network layer receives data from the transport layer. The major responsibilities of the network layer include host-to-host delivery, logical addressing, routing, and fragmentation. Now let's discuss them one by one, starting with host-to-host delivery. Host-to-host delivery means taking data from the sender's device and delivering it to the receiver. The transport layer creates segments, right? Now, these segments need to be delivered to the destination. The transport layer can't do that. It only creates segments. Someone needs to deliver these segments to the receiver. This is exactly what the network layer or host-to-host delivery does. It takes segments from the transport layer and delivers each segment as a packet to the receiver's device or another host in a different network. The data is called packet at the network layer. This is also called source to destination delivery. After delivering the data to the receiver, the network layer passes the data to the transport layer. The transport layer then delivers the data to the exact process or application that requested it. This process is called process-to-process delivery, as we discussed in the transport layer. Process-to-process delivery only happens after the data reaches the destination device. The job of network layer is to deliver data to the destination, and then the transport layer delivers data to the exact process. This is how both layers work together. Remember, data moves from bottom to up on the receiver's device. Now let's discuss logical addressing. Logical addressing is the process of assigning source and destination IP addresses to data segments. The network layer receives data segments from the transport layer and then adds the source and destination IP addresses to each segment to form packets. The PDU or data is called packet at the network layer. The network layer adds the IP address of the sender, the device sending the packet, and the IP address of the destination device where the packet will be delivered. Each device that is connected to the internet has a unique IP address. An IP address uniquely identifies a device on the internet. The IP address essentially determines where the device is located on the internet. To deliver data, the sender needs to know the destination address. Therefore, the network layer adds the destination IP address to each packet. Then the packet gets delivered to the destination IP address or device. The network layer also adds the source IP address or the sender's IP, because when the receiver sends the data back to the sender, it also needs to know where the packet should be delivered. That's why the source and IP addresses are added to the packets. So to summarize, IP addresses are added to data so that packets can reach the correct destination. That's the logical addressing. Now let's move on to routing. Routing is an important function of the network layer. Routing is the process of selecting the best possible path to deliver data to the destination. The internet is essentially a huge collection of different individual networks or LAN networks. All the LAN networks are interconnected. These interconnected individual networks form the internet. Now remember that networks communicate with each other through routers. Routers communicate with each other to direct or forward data packets to the correct destination. Packets have to travel through various routers to reach their destination. There is never a direct or dedicated link between the sender and receiver. Data has to go through various networks or routers to reach its destination on the internet. Let's understand this with an example. Suppose device A wants to send data to B over the internet. Both are located in different networks. Now, data does not travel directly from the source to the destination. As discussed earlier, it has to pass through various routers to reach its destination. So here we have a lot of possible routes. Now the sender has to select the best possible route to deliver data. The job of the routing is to select the best possible route among all the available routes to deliver the data to the destination as quickly as possible. In our example, routing has selected these 3 routers that data needs to pass through to reach the destination. This is important. These routers that the data goes through are also known as nodes or hops. The network layer uses various routing protocols to determine the path, such as EIGRP, BGP, and RIP, Routing Information Protocol. Now let's discuss fragmentation. Fragmentation is another important responsibility of the network layer. Fragmentation simply means breaking a packet into smaller pieces or fragments. Now, why do packets need to be fragmented? The transport layer also breaks a file into smaller pieces or segments, right? Which is called segmentation. But there is a difference. Segmentation means breaking a file into smaller pieces or segments at the transport layer, and fragmentation means breaking a segment or packet into smaller pieces at the network layer. The fragmentation is required in certain cases because a single packet can carry a maximum of 1500 bytes. However, there is a new technology called jumbo frames that can carry up to 9000 bytes in a single packet. The jumbo frames are mostly used by data centers for now. They are not common at all. A single packet can carry a maximum of 1500 bytes, which is the current standard. This is also called MTU, Maximum Transmission Unit. MTU defines the total data that can be transmitted or sent in a single packet. Now, each network has its own MTU or capacity to handle data in a single packet. Let's say the sender sends a packet of 1400 bytes to the receiver, but the receiver's network has an MTU of 700 bytes. The receiver's network only accepts a maximum of 700 bytes in a single packet. The receiver will not be able to process or handle a packet with 1400 bytes because its MTU is 700 bytes. Now the sender has to figure out a way to cut down packet size to meet the receiver's MTU. So to prevent this problem, the network layer uses fragmentation. It takes the packet of 1400 bytes and divides it into two smaller packets of 700 bytes each. Now, the fragmented packets are sent to the destination and reassembled at the receiver's device to form the original packet. So this is called the fragmentation, breaking a packet into smaller pieces to meet the receiver's MTU. The most important protocol at the network layer is the Internet Protocol or IP. The IP protocol manages fragmentation, assigning IP addresses, etc. These are the protocols and devices present at the network layer. The router is the most important device at the network layer. It is the router that forwards the data packets to the destination. The data link layer receives data packets from the network layer, and the responsibilities of the data link layer include node-to-node data delivery, flow control, error control, physical addressing, framing, and media access control. So let's start with node-to-node delivery. Node-to-node data delivery means that the data link layer delivers data from one node to another. Now, what is a node? A node is a device that is part of a network and capable of forwarding and receiving data such as a phone, computers, servers, switch, router, modem, etc. Now let's understand node to node delivery in the context of the data link layer. If you recall from the network layer selects the route or path that data packets must go through to reach their destination, right? Let's say that network layer selects this route to deliver data from the source to a destination. Here we have 4 routers between the sender and receiver. The data must pass through these 4 routers to reach its destination. Now, these routers are also called nodes or hops. I will use the term nodes from this point forward because node is the terminology we use for routers in the data link layer. Now, if device A wants to send data to B, the data will not travel directly from A to B. Instead, it has to go through these nodes to reach the destination. The responsibility of the data link layer is to deliver data from one node to another or the next node that is on the way to the destination. When data leaves the sender's device, the data link layer delivers the data to the first node. Node 1 will then forward the data to node 2 and node 2 will further forward it to node 3. Eventually, the data will reach its destination. That's the node to node or hop to hop data delivery. Don't confuse node to node delivery with host to host delivery, which we have at the network layer. The network layer directly communicates with the receiver or destination device. and the data link layer takes care of the nodes or the next node that is on the way to the destination. Both layers at different levels take care of the data delivery from sender to receiver. Remember, when devices on the same network want to communicate with each other, they can directly communicate using the data link layer with the help of MAC addresses. The network layer is not required for sending data to each other within a single network. However, the network layer becomes essential when delivering data to devices located on different networks. Now let's discuss the flow control. We also have flow control at the transport layer, right? Flow control by definition serves the same purpose at the both layers. Flow control makes sure that the sender does not send more data than the receiver can handle or process. However, there is a minor difference. The transport layer directly controls the data flow between the sender and receiver devices. It ensures that the sender does not send more data than the receiver can process. Now, before data can reach the receiver's device, it must pass through nodes that are on the way to its destination, right? Therefore, we need a way to control the flow of data between these nodes as well. This is what the data link layer does. It controls the data flow between nodes. Flow control in the data link layer ensures that the sender node does not send more data than the receiving node can handle or process. It uses various algorithms to control the data flow, such as stop and wait. Again, the data link layer controls the flow of data between nodes, while the transport layer controls the flow of data between the sender and receiver. Now let's discuss error control. Just like the transport layer, the data link layer also checks the data for errors. However, there is a difference. The transport layer checks the data for errors when it reaches the destination device. But before the data reaches the actual destination, it goes through these hops or nodes, right? So similar to flow control, the data link layer checks for errors in the data at each node. I will explain in a minute why both layers check for errors. Error control in the data link layer is the process of detecting and correcting corrupted or lost data frames at each node. The data link layer uses a variety of techniques to detect and correct errors, such as parity check and cycle redundancy check. The most common types of errors that can occur at the data link layer include single bit errors, burst errors, and frame loss. The reason OSI model checks for errors at both transport and data link layer is simple. It improves the efficiency. Suppose there are no error checks at the data link layer or nodes. The data with errors reaches the destination device, and the receiver checks and detects errors. After detecting an error, the receiver requests the sender to resend the corrupted data. This is a time-consuming process because the receiver's request has to travel back through all the nodes along the path. However, detecting errors at a node before the data reaches the destination can fix them sooner. The node can request the sender to correct the error or resend the corrupted data. This saves time and improves efficiency. Now let's discuss physical addressing and framing. Physical addressing is the process of assigning MAC addresses to data packets. The data link layer assigns the MAC addresses of sender and receiver to each packet that it receives from the network layer to form frames. Data unit is called the frame at the data link layer. MAC address is also known as physical address. MAC address is a unique 12-digit hexadecimal number embedded into a computer's network card. A MAC address is permanently assigned to a network card and can't be changed. If two devices on the same network want to communicate with each other, they can communicate using their MAC addresses. Data exchange within the same network can be facilitated using MAC addresses without requiring network layer and IP addresses. As I mentioned, the data or PDU at the data link layer is called the frame. The data link layer converts packets into frames. It receives packets from the network layer and wraps them into frames. The data link layer properly formats data before it is sent to the physical layer. This process is called framing. Just like the network and transport layer, the data link layer also adds its own data or header to each packet that it receives from the network layer. The data link layer adds a header and a trailer to a data. Each frame contains a frame header, frame body, and a frame trailer. This is the structure of a frame. The header includes the MAC addresses of the sender and receiver devices as well as flow control information. The frame body contains the data or payload to be delivered to the destination. The packet that data link layer receives from the network layer is stored in the body or payload of the frame. It also adds a trailer at the end of each frame. Trailer includes error detection codes. We will get back to the frame structure in a dedicated video. There is more to frame than just these fields. Now let's move on to the media access control. Data link layer is divided into two sub-layers, logical link control and media access control. LLC handles protocols, synchronization, flow control, and error detection etc. Media access control manages data collisions. Let's understand what data collision is. Suppose devices are connected to a network through a shared cable, such as in bus topology, where devices connect and communicate with each other through a thick wire or cable. Now, in this type of network, things become problematic when multiple devices attempt to send data simultaneously. When multiple devices send data at the same time, the data can collide, which causes data loss. So in order to send data, each connected device has to access or use the shared cable when no other connected device is using it or sending data. Media access control makes sure that only one device sends data at a time to avoid data collision. Media access control makes sure that devices don't interfere with each other's data, which allows each computer to send and receive data without interference. Data is transmitted by a device only when the shared cable or link is idle and no one else is using it. The technology used for avoiding data collision is CSMA/CD. It stands for Carrier Sense Multiple Access Collision Detection. These are the protocols and devices at the data link layer. The network interface card is the most important device at the data link layer. Any device that deals with MAC addresses is a data link layer device. Another very important device at data link layer is the switch, which intelligently forwards packets based on the destination MAC address, ensuring efficient traffic flow within a network. Now the last or the first layer from the bottom is the physical layer. The data link layer prepares data to be sent over wires. It makes sure that the data is properly formatted so that it can be transmitted over the wires or physical mediums. The physical layer receives data from the data link layer and is responsible for transmitting data over physical mediums such as wires or wireless radio waves. The physical layer interacts with the hardwares that are used to send, receive, or carry data, such as cables, optical fibers, and radio waves. It is responsible for converting digital data into electrical or optical signals that can be transmitted over physical mediums. Before transmitting data to the actual physical infrastructure, the physical layer generates signals based on the medium that a device is using to connect to the network or access the internet. The physical layer receives data from the data link layer in the form of binary zeros and ones. This is digital data or digital signals. However, ones and zeros can't be sent over transmission mediums such as cables or radio waves etc. The physical layer must convert digital data into signals that can be sent over the physical medium, which depends on the type of connection being used. For example, if you are connected to the network through Wi-Fi, then the digital signals are converted into radio signals or radio waves, and if you are connected through an Ethernet cable, the data is converted into electrical signals. This conversion is done by modem. After converting the data into the appropriate signals, the physical layer transmits the data over the physical medium from one node to another, and eventually data reaches at the destination. The data is called bits at the physical layer. How data is received and processed at the destination, it will be covered in the encapsulation and decapsulation video. These are the devices and protocols present at the physical layer. You might be wondering why hubs are physical layer devices while switches are data link layer devices. A switch can read MAC addresses and forward packets to the correct destination device based on that address. On the other hand, hubs can't read MAC addresses, so they forward every packet to all devices connected to them. Remember, anything that deals with MAC addresses is a data link layer device, and hubs are physical layer devices because they can't read MAC addresses. In this section, we will dive into the fundamentals of cryptography. Cryptography is a critical component of secure data communication in modern computing. It is absolutely necessary. You don't have to master it. However, understanding the fundamentals of cryptography is essential for everyone, especially for cybersecurity and network engineers. In this first video, we will explore what cryptography is and why it is important or required. So what is cryptography? Cryptography, in simple terms, protects data. It allows devices to communicate securely over the internet. It protects data from cybercriminals, middlemen, or hackers. Let me first demonstrate data communication over the internet without cryptography. Then we will be able to understand why it is needed. Suppose device A and B want to communicate over the internet. A sends a hello message to B. Now, the data does not travel directly from the sender to receiver on the internet. Instead, it goes through various devices and networks to reach the destination. We don't know who can intercept the data as it travels to its destination. Now, what if a cybercriminal intercepts the communication? Then the hacker will be able to read all the details or data that the communicating devices exchange between them. Intercepting data is not that difficult. If you have basic hacking skills, you can intercept data easily. The problem becomes even more critical when users connect to important websites like banking portals, Gmail, or social media platforms. Interception of data communication with banks or other sensitive websites by hackers can have severe consequences devices and compromise your personal information. We have no control over who might intercept data because by design the internet is accessible to everyone. However, we can protect the data itself so that even if someone intercepts it, they can't understand the original message or information. The real problem here is the communication of data in plain text. Devices are sending and receiving data in plain text, so whoever intercepts it can easily read the original data being exchanged. Therefore, we needed a secure method for safeguarding and exchanging data. This is where cryptography steps in to address the problem. Cryptography encrypts the data before it is sent to the receiver. After encrypting, the data becomes unreadable like this. The hello message gets scrambled into this unreadable encrypted text. Now this encrypted message is then sent to the destination. Now even if cybercriminals intercept the data, they will not be able to read the original data. All they will see is the encrypted data. The data is decrypted or converted back to its original form only at the destination. This is the magic of cryptography. Only the receiver can decrypt data back to its original form. So that's how cryptography protects data and ensures it is delivered securely to its destination. This is a basic technical overview of cryptography. We will dive into more details in the upcoming videos. So let's start with encryption. Encryption is the process of transforming plain text or readable data into unreadable data to secure it from unauthorized access. Let's say the sender wants to send a hello message to the receiver. Now before sending the message to the destination, encryption scrambles or encrypts the message into unreadable random characters like this, so that only the authorized or intended receiver can read it. Data is encrypted in a way that only the intended receiver can read the original message. This encrypted data is then transmitted to its destination. Now, if hackers hack or intercept the data, they will not be able to read the original message. Attackers will still be able to access or view the data, but all they will see is the encrypted message, not the original data. Now, decryption is the opposite of encryption. Once data is encrypted, it is sent to the destination, and at the destination the encrypted data needs to be decrypted so the receiver can read the original message. Now the process of converting encrypted data back to its original form is called decryption. Remember, only authorized users can decrypt the data. Data is always decrypted at the destination. Now let's discuss the difference between encryption and cryptography. Cryptography is a broad term that includes everything related to data security. Encryption is essentially a component or part of cryptography. Cryptography, on the other hand, covers everything related to data security, including encryption and decryption, along with all the necessary steps involved in the data security process. So cryptography is a comprehensive term that includes everything related to encryption and decryption. Both are integral parts of cryptography. When it comes to encryption, there are two primary types, symmetric and asymmetric encryption. In this video, we will focus specifically on symmetric encryption and how it works. Now, symmetric encryption is also known as symmetric key encryption. It uses a single key to encrypt and decrypt data. The word symmetric means the same. Therefore, symmetric key encryption uses the same key to both encrypt and decrypt data. This key is also known as the secret key. The concept of the key in symmetric encryption is very similar to a door key. We use the same key to both lock and unlock the door, right? Only the key that locks the door can unlock it. The same principle applies to symmetric key encryption. The same key is used for both encrypting and decrypting data, and no other key can perform these functions. The data is encrypted using complex encryption algorithms. An encryption algorithm is essentially a technique or a set of steps used for scrambling or encrypting data. There are many encryption algorithms used in symmetric encryption, such as AES, DES, Blowfish, etc. to encrypt data in real-world applications. Now, I will explain symmetric key encryption using the simplest and oldest encryption algorithm. This will help us easily understand the process and how an encryption algorithm and a key work together to encrypt and decrypt data. Encryption is not a new concept. It has been used for centuries to protect information even before computers and digital data existed. The first known data encryption method was used by Roman King Julius Caesar. The technique or encryption is also known as Caesar cipher. The Caesar cipher is one of the simplest and oldest encryption methods, named after Julius Caesar, who used it to protect his military messages, such as when to attack, retreat, etc. Caesar cipher serves as a foundation for understanding the concept of symmetric key-based encryption. Now let's understand symmetric key encryption using the Caesar cipher. Let's say that device A wants to send the message hello to device B securely. As I mentioned at the beginning, the message is encrypted using a secret key in symmetric encryption. Let's say the secret key is 2. Now, the encryption algorithm or Caesar cipher works by shifting letters forward by a fixed number of positions. In this case, we are using 2 as a shift value, so it will move each letter 2 positions forward. Caesar cipher is also known as Caesar shift or shift cipher. The algorithm specifies shifting or moving letters forward by the secret key value for encrypting data. In my case, the secret key is 2, so we will move each letter forward by 2 positions. So if you move H 2 positions forward, it becomes J, E becomes G, LL becomes NN, and O becomes Q. So this is the encrypted data or text. Hello has been encrypted into this. Now remember, this is very important. This encrypted text or message is known as the ciphertext in cryptography. Ciphertext is basically the encrypted message or data. Now, after encrypting the data, A sends the ciphertext to the destination. The receiver uses the same secret key, which is 2, to decrypt the data to its original form by reversing the process. The encryption algorithm involves shifting each letter 2 positions forward in the alphabet to encrypt data, right? Now, to decrypt the message, the algorithm reverses this process by shifting each letter 2 positions backward. For example, the J becomes H and the letter G becomes E, the letters NN becomes LL, and Q becomes O. Now we have successfully restored or decrypted the ciphertext to its original form hello. This process is known as decryption. So that's how the algorithm and key work together. The algorithm specifies the shifting of letters by the shift value, while the shift value itself is the secret key. Now, if A wants to communicate with other device, it generates a unique secret key for each connection. Computers or devices in the real world don't use or rely on simple encryption methods like the Caesar cipher to encrypt data, because the Caesar cipher can be decrypted very easily. The Caesar cipher method is a valuable tool for explaining the concept of symmetric key-based encryption. The encryption algorithms utilized by computers involve highly complex mathematical equations. Encryption algorithms that computers use, such as AES and Blowfish, use sophisticated mathematical calculations to encrypt data. AES is the current industry standard and is highly secure. It is used for securing communication. Now let's address the very important question: how does the receiver know or obtain the secret key? As we discussed earlier, both the sender and receiver need the same secret key to encrypt and decrypt data, right? If the sender uses 2 as the secret key to encrypt data, then the receiver needs the same key to decrypt the data. This means we somehow need to share the secret key with the receiver so it can decrypt the data using the same key that encrypted it. However, sending the secret key directly to the receiver is not safe. Let's say if the sender sends the secret key directly along with the data to the receiver, then hackers can intercept both the secret key and the ciphertext. Consequently, they can easily decrypt the message using the secret key. That's why the key is not sent directly from sender to receiver. Instead, the key is exchanged or established securely using the Diffie-Hellman protocol. The Diffie-Hellman protocol uses complex mathematical equations that allow both the sender and receiver to independently establish the same secret key without directly sharing it. So Diffie-Hellman essentially helps both the sender and receiver establish the same secret key without directly exchanging it. Remember, the secret key is always established before both the sender and receiver start exchanging actual data. After establishing the key, both devices then begin exchanging data securely. It is a proven method for key exchange and is considered extremely difficult for a third party to intercept or predict the key. That's it for this video, guys. Let me know if you come up with questions. Before we dive into the specifics of asymmetric encryption, let's first understand why it was developed. Asymmetric encryption was developed to address the limitations of symmetric encryption. As we discussed in the previous video, symmetric encryption requires the sender and receiver to share a secret key before secure communication can begin. The key exchange is typically secure, but there is always a potential risk of compromise. Both symmetric and asymmetric encryptions have their distinct applications and uses. Asymmetric encryption solves the key sharing problem of symmetric encryption. Asymmetric key encryption is also known as public encryption because it uses two separate keys to encrypt and decrypt data, the public key and the private key. The public key is typically used to encrypt the data and the private key is used to decrypt it. The public key, as the name suggests, is either publicly available or shared with authorized recipients or receivers. The corresponding private key is kept private and is not shared with anyone. Now let's understand the essential fundamental terms of asymmetric encryption before diving into how it works. Let's say A wants to send hello to device B. Now, before exchanging the data, both devices will generate two keys each, the public key and the private key. The public and private keys of each device work together because they are always mathematically related or linked together. Remember this point, it is very important in asymmetric encryption. Suppose if device A encrypts its data with its public key, then that data can only be decrypted using its private key. No other key can decrypt it. Similarly, if A encrypts data using its private key, then the data can only be decrypted using its public key. As I mentioned earlier, both keys are mathematically linked together. So if you encrypt data with one key, then only its corresponding key can decrypt that data. The same applies to B and all other devices that use asymmetric encryption. If B encrypts data using its public key, then only its own private key can decrypt the data and vice versa. In the real world, the public key is always used to encrypt data and the private key is used to decrypt it. Therefore, the public key is shared with other devices. Now let's see how the entire communication is securely carried out using asymmetric encryption. Suppose A wants to send the hello message securely to B using asymmetric encryption. The first step in asymmetric encryption is that both the sender and receiver generate two keys each, a public key and a private key. Now, after generating keys, both A and B will exchange their public keys. A will send its public key to B and B will send its public key to A. After receiving the public key of B, A will use public key of B to encrypt its data. The hello message will be converted into ciphertext after encryption. Now, the encrypted data or ciphertext is sent to B. Now, how does B decrypt the data? B has two keys, its own private key and the public key of A, right? Remember, the data B received was encrypted using its public key, which it sent to A. Now, only the private key of B can decrypt the data because it's the only key mathematically linked to it. B already has that private key. It shared its public key and kept the private key. So obviously B decrypts the data using its private key because the data that A sent was encrypted using its public key. So the private key of B will decrypt the data back to its original form, hello. The public key can't because it is not mathematically linked to the key that encrypted the data. So basically B says to A, take my public key, then encrypt the data that you want to send to me with it and then send it to me so I can decrypt it using my private key. Similarly, if device B wants to send data to device A, it will use the public key of device A to encrypt the data. Upon receiving the data, device A will use its own private key to decrypt it. So to summarize, in asymmetric encryption, both the sender and receiver exchange their public keys before exchanging data. So the sender can encrypt the data using the public key and then corresponding private key is used for decryption. That's why asymmetric encryption is considered more secure compared to symmetric encryption because you never need to share the private key that decrypts the data. The algorithm that powers asymmetric encryption is RSA. RSA encryption is an asymmetric encryption algorithm named after its three inventors, Rivest, Shamir, and Edelman. Asymmetric encryption uses RSA to securely exchange data over the internet. In this section, we will learn about hashing. This is the first video on hashing, and in this video, we will understand what hashing is and why it is needed. Similar to symmetric and asymmetric encryptions, hashing protects data. Hashing is also a fundamental part of cryptography. However, hashing is slightly different from encryption. So let's first understand what hashing is. In cryptography, hashing is a technique that takes data or a message as input and generates a fixed size output. It takes any given input and transforms it into a random fixed value output, representing the data in a condensed form. I know it sounds confusing and overwhelming right now, but don't worry, I will explain how it works in the next video. Everything will become clear once you learn its working. So there is no need to feel lost at this point. For now, the important thing is to understand the problems that hashing solves and why it was developed. Hashing addresses two major problems: data integrity, storing and verifying passwords securely. Let's first discuss the important part, data integrity, where hashing plays a crucial role. Data integrity means that the receiver receives error-free and unaltered data. Hashing ensures that data remains unaltered or unchanged during transmission or storage. Let's say device A wants to send a file to B. Now, if a cybercriminal intercepts the file and modifies the file contents, then sends the modified file to the intended receiver, it compromises the file's integrity. The receiver will not be able to determine whether they received the original or modified file. Therefore, we need a mechanism to check the integrity of files or data. This is precisely the problem that hashing addresses. It ensures that original, valid, and unaltered data reaches the intended destination by detecting any changes or modifications that may have taken place during transmission. Another crucial application of hashing is securely verifying and storing passwords. Web and other applications rely heavily on hashing for secure data storage, particularly passwords. Hashing essentially provides an additional layer of protection. This will be discussed in a dedicated video later in the section. Beyond these crucial applications, hashing has a wide range of other use cases in cryptography, such as digital signatures, secure key derivation, random number generation, etc. In this video, we have a lot to cover. We will start by exploring the fundamentals of hashing, how it works, how it protects the integrity of files or data, and what a collision is. Hashing is a complex mathematical process that takes an input of any size and produces a fixed size output called hash value. Here is how hashing works. We provide input or data to a hashing function. Hashing functions are responsible for generating hashes. The input can be anything: a single letter, word, a paragraph, a text file, PDF file, or any other data. Regardless of the input's size, the hashing function always produces a fixed length output. For the sake of simplicity, let's assume that we have a hashing function specifically designed to generate a fixed length output of 10 random characters. This means that regardless of the input you provide to this function, it will always produce an output with a fixed length of 10 unique random characters. So if your input is a single character such as B, this hashing function will produce a 10 character random string like this as its output. Now let's increase the input size. Suppose the input is the word hello. The output will be different, such as this. However, the output length will always be a fixed 10-character long random string. Even though the input size has increased, the hash will always produce a fixed length output of 10 characters. Similarly, if you provide a file as input, the function will still produce a 10-character long output. Now, in the real world also, hash functions consistently produce fixed length outputs regardless of the length of the input. This applies to all types of data and files, including large files with sizes in gigabytes. The functions will still generate a fixed size output. That's the fundamental nature of hashing functions. There are numerous hashing functions used in various real-world applications such as MD5, SHA-1, SHA-2 and SHA-256. All of these functions produce a fixed size output. However, the exact output size varies depending on the specific hash function being used. We will discuss them in more detail in the upcoming videos practically. For now, let's dive more closely into the inner workings of hashing. To illustrate the hashing process in a clear and understandable way, I will use a very simple hashing function as an example. This hashing function works by taking the position of each letter and then adding them together to generate the hash. So here we have letters along with their numerical positions. Let's say I want to generate hash for the hello message. The letter H is at the 8th position, so I will take the value 8. E is at the 5th position. L is at the 12th position. Since there are two L's, it is 12 again. O is at the 15th position. So if we add all these numbers, we get 52. Now the result or output that a hash function produces is called a message digest. The message digest is also known as a checksum, digital fingerprint, or simply hash value. Now, the 52 is basically the hash value or fingerprint of the word hello. So this 52 essentially represents this message. As I mentioned in the previous video, hashing is used to ensure data integrity. It guarantees that data remains unmodified when transmitted from sender to receiver. Here is how it works. When data or a file is sent from one device to another, a hash value is also transmitted alongside it. Suppose device A sends the hello message to device B. It will also send the hash value calculated for hello, which is 52. Now, when hello reaches B, the receiver also calculates the hash value of hello independently using the same function that was used to calculate the hash by the sender. Now, after calculating hash, it gets 52. Now, it compares the hash value that it calculated to the value sent by the sender. If the hash value the receiver receives matches its own calculated hash value, then it means the file or message was not modified. It received the correct message. Now let's say before the message reaches the actual receiver, a hacker intercepts it, modifies hello to hell, and then sends this modified message to the receiver. Now the receiver calculates the hash. This time it will be 37. The hash value for hell is 37. When the receiver compares this new hash value with the hash sent by the sender, it will not match. This is because the message has been modified, resulting in a different hash. If the modification is detected, then the message gets dropped or discarded. Remember, even a minor change produces a different hash value, which helps to detect changes in a file or data. In the real world, you may have noticed that when you download files from reputable websites, they often provide a hash value alongside the file itself. This hash is typically displayed on the website or included in a separate file. After downloading the file, you are encouraged to calculate the hash of the downloaded file using the same hash function that the website or application used to generate the original hash. If the hash you calculate matches the hash provided with the file, it is a strong indication that you have downloaded the correct file without any corruption or tampering. So guys, that's how hashing works and ensures the data integrity. Obviously, this is the simplest possible hash function. Such simple functions are not used in real-world applications. This was just for explanation purposes. This function is very weak, predictable, and easy to crack. In the real world, hash functions such as SHA-1, SHA-56 use very complex mathematical calculations to produce a hash or message digest. Data is put through a complex process to produce a hash. Now, there are several criteria that a hash function must meet to be considered secure and reliable for real-world use. Let's take example of our simple hashing function. This function produces 52 hash value for the word hello, right? Now, there are many words that can add up to 52. For example, two Z's can also produce a hash value of 52, and the word zebra also adds up to 52 along with many other combinations. This is called collision. A collision in hashing occurs when two different pieces of data or message generate the same hash value using the same hash function. This hashing function is also producing the same hash values for different messages. This is bad. If two different pieces of data have the same hash value or generate the same hash, comparing their hashes will not tell us which one is the original. This can lead to falsely accepting corrupted data as valid, potentially causing major issues. So this function is obviously not suitable for real-world applications because it is not secure, is easily predictable, and easy to crack. Therefore, a hash function must always produce a unique hash value or output for every distinct or individual input. This is the first and most crucial criteria. Another very strict requirement for a hashing function is that it must always produce a fixed length of output. My simple hash function will not produce a two-digit output or hash value if I provide a line or paragraph as an input. The output will be 3 digits or more. But in the real world, a hash function always produces output of a fixed length, no matter how long or small the input is. It must always produce a fixed length output. So guys, to summarize, a hash function must produce a unique output for every distinct input, and every output must be of a fixed size. Command. Ping is one of the most commonly used commands in Linux networking. It is pre-installed on all three major operating systems, Windows, Mac OS, and Linux. Ping is a simple yet very important command. It is a network connectivity tool used to check network connectivity and troubleshoot issues. Let's say you are experiencing problems related to your internet connection. In such situations, you can use ping command to determine whether your internet connection is working or not. Ping can also be used to check websites. If you are having trouble accessing a website, you can use ping to verify whether the website or server is up and running. Now let's jump into the practicals. Type ping space and we need to provide an IP address or a domain name to the ping command. So let me specify, let's say google.com. The way ping command works is it essentially sends ICMP packets to the specified host or destination and then waits for a response from the specified host. Let me press enter. By default, the ping command keeps running forever. You have to stop it manually. So to stop the ping command, press Ctrl plus C together, and at the bottom we have the statistics for the connection. 14 packets transmitted. It means my system sent 14 packets to the google.com and 14 received. It means all the packets that ping sent to the Google responded to all those 14 packets. Now it proves two things. One, my internet connection is working, because in order to send packets out on the internet, you need to have a working internet connection. It also proves that Google is up and running because it responded to the packets which were sent by ping. So both systems communicated successfully over the internet. Now, as we saw, the default ping command sends unlimited packets. Now let's do some customization. I only want to send a limited number of packets. So type ping -c 5 google.com. This time ping is only going to send 5 packets or whatever number you specify after the -c parameter. So let me press enter. As you can see, it sent 5 packets and received all those 5 packets. So guys, that's how you can check your internet connectivity. If your system is able to send packets out in the internet, it means that your internet connection is working just fine. And of course, if it receives packets from the host that you provide to ping command, it also means that the host that you are connecting to is also up and running. Now, if your internet connection is not working, then you will see messages or error messages like this: temporary failure in the name resolution. Remember, this message can also appear if you provide a wrong host name or domain name that doesn't exist. This is the typical error message when your internet is not working. Now let's say if the host that you are connecting is not up and running, then in the statistics section you will see something like 0 packets received. It means that the host is not up and running. Or there could be another reason. Maybe the host that you are connecting to or pinging to has blocked the ICMP packets. The common response, if host is not up and running or is down, you will see the 0 packets received. In this section, we will get started with the binary number system. In this particular video, we will learn what a number system is and the types of number systems used by computers. If you are a complete beginner, the binary number system might seem scary or intimidating, but don't worry, everything has been simplified for you. Just pay attention. Before we get into the binary number system, let me explain what a number system is in general to set the context and groundwork for understanding the binary number system. Some of you might find this too basic. I believe it is important to cover the absolute fundamentals to ensure everyone, including complete beginners, feels comfortable and well equipped to learn. A number system is a way of representing numbers using specific symbols or digits such as 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. We use these digits to represent or write all the different numbers we can think of, right? Now, there are several number systems that are specifically used by computer systems, including decimal, binary, octal and hexadecimal. Let's start with the number system we are all familiar and comfortable with, which is the decimal number system. The decimal is a base 10 system. So what is base first? Base in this context refers to the total number of digits used to represent numbers. Base 10 therefore means the decimal number system uses 10 digits from 0 to 9 to represent numbers. The 10 digits that decimal uses are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. 0 is also counted. So from 0 to 9 there are 10 digits that decimal system uses. We can represent or write any numbers using these 10 digits, such as 6, 7, 23, 100,000 or any number that you can think of. All numbers are represented using combinations of these 10 digits. We use the decimal number system in our daily lives to count things, right? And it works pretty well for us humans. Now, computers use the decimal number system for displaying information in a human readable format. When you see any information that contains numbers, it is the decimal number system in use. Now let's move to the main part of the video, the binary number system. The binary number system is a base 2 system, meaning it uses only 2 digits to represent numbers. Those digits are 0 and 1. The decimal system uses 10 digits from 0 to 9 to represent numbers. On the other hand, the binary system only needs 2 digits, 0 and 1. With these 2 digits, we can represent or write any number through combinations of 0 and 1. In upcoming videos, we will learn how to convert any decimal number into its binary equivalent. Now, the binary number system is used by computers and all digital devices. You may have heard that computers only understand binary, right? Binary is basically the language of computers. Now, what does it actually mean when we say computers only understand binary? Data is stored, transmitted and processed only in binary by computers. Everything stored in computers, from characters, audio to video files and images, is represented using binary. This means everything ultimately gets converted into combinations of zeros and ones. For example, when you save an image on your computer, it is first translated or converted into binary before being stored in the system. Similarly, all types of data are converted into binary before being stored or processed. When a computer performs any task or calculation, the data is first converted into binary, then it is processed. In short, everything is represented by combinations of just 2 digits, 1 and 0. Computers use only binary numbers for processing and storing data. Now, the binary number system is very important in networking, specifically for topics like IP addressing, CIDR notation, network masks, subnetting, etc. We need to understand how to convert decimal to binary and binary to decimal when working with IPv4 addressing. Then we have the octal number system. Octal is a base 8 system. There are a total of 8 digits that can be used in octal. 0, 1, 2, 3, 4, 5, 6 and 7. These 8 digits are used to represent numbers. However, octal is no longer as widely used in computing as it was in early computing. The next number system is hexadecimal. In the next video, we will cover hexadecimal in detail because it deserves a dedicated video. let's begin by understanding what hexadecimal is. We don't need to learn the in-depth workings of hexadecimal. We only need to know its uses, where it is used and why it is preferred in certain situations. That is sufficient. Hexadecimal is a combination of two words, hexa and decimal. Hexa is a Latin word that means 6, and decimal, as we know, is a base 10 number system, right? So if you add up hexa, which is 6, and decimal, which is a base 10, we get 16. Therefore, hexadecimal is a base 16 number system. Hexadecimal uses 16 digits to represent numbers or data. These digits are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are decimal numbers, right? Now, the remaining 6 are letters, A, B, C, D, E, F. So, we have all the decimal numbers in hexadecimal plus 6 letters. Now, A represents 10 in the hexadecimal system, B represents 11, C represents 12, D represents 13, E represents 14. So hexadecimal uses these 16 digits to represent numbers and other data. Now let's discuss the actual question. What are the use cases of hexadecimal numbers and where do they fit in? Hexadecimal numbers have a wide range of applications. The hexadecimal number system represents binary and decimal data in a more concise and readable format. Let's understand the real-world use of hexadecimal with MAC addresses. So now what I'm gonna do is open my command prompt and show you the MAC address, what it looks like. So press Windows key, type cmd, click on command prompt, type IP config / all, press enter, and under the wireless LAN adapter Wi-Fi, locate the field physical address. Now this is the MAC address. As you can see, it is in hexadecimal digits. A MAC address is always represented using hexadecimal digits. A MAC address is a 12 hexadecimal digits long, which means it has 6 pairs of 2 hexadecimal digits, right? As you can see here. Now, if the same MAC address were represented using the decimal number system, we would need more than 12 digits, probably around 18 digits to represent a MAC address. The hexadecimal system precisely represents data in fewer digits compared to hexadecimal. Hexadecimal numbers are also commonly used in memory addressing, data compression, and even color codes. You have likely seen codes that look like this. These codes use hexadecimal system. If you are a web developer, you must have used color codes, right? Color codes are written in hexadecimal because they can compactly represent the color codes. Understanding binary to decimal conversion and vice versa is crucial for working with IP addressing, subnetting, and other related topics. It may sound challenging, but it is actually simple. There are several methods for converting decimal to binary, but I will show you the simplest one. Now I want to convert this binary number 00101011 into decimal. The binary is a base 2 number system, which means it uses only 2 digits 0 and 1 to represent numbers. Each digit's value increases by a factor of 2 or doubles as you move leftward in the number. Now let's get down to the real work without complicating it. So let me write the binary number that I want to convert into decimal, which is this. It is an 8-bit number. Now to convert, underneath the rightmost digit, write 1, start with 1, and as you move to the left, multiply the number by 2. 1 multiplied by 2 is 2. 2 multiplied by 2 is 4. 4 into 2 is 8. 8 into 2 is 16. 16 multiplied by 2 is 32. 32 into 2 is 64. 64 multiplied by 2 is 128. Keep multiplying the previous number by 2 until you reach the leftmost binary digit. Since we are dealing with only 8 binary digits, the multiplying or doubling stops there. There is no need to continue beyond the last bit. We now have the place value for each binary digit. If there were another binary digit, we would need to multiply by 2 again to get its place value, which would be 256. Since we are working with an 8-bit binary number, we don't need another value. Now we have everything needed to convert this binary number to a decimal number. To convert binary number to decimal, first identify the binary digits where there is a 1. We have a total of 4 ones. Now mark or circle all the place values where there is a 1 in the binary number. Essentially, circle all the decimal values that correspond to the ones. After marking the place values that correspond to ones, add up the marked values. This will give you the decimal equivalent of the binary number. This is as simple as that. The method is simple. If a binary digit is 1, its corresponding decimal value is included in the final sum, and if the binary digit is 0, its value is not added to the sum. Let's add these marked values or numbers that are underneath the ones. So 32 plus 8 plus 2 plus 1 is 43. So decimal equivalent of this binary is 43. So this is as simple as that. Now let's look at one more example for clarity. We will once again convert an 8-bit binary number to decimal. The reason for specifically working with 8 digits is that we commonly deal with 8-bit numbers in IPv4 addressing, subnet masks, subnetting and related topics. Most of the time we need to convert 8-bit binary to decimal and decimal to binary. Let's say we have a given 8-bit number 100101110. The method for conversion remains the same. Underneath the rightmost digit, start with 1. As you move to the left, multiply the number by 2. 1 multiplied by 2 is 2. 2 into 2 is 4. 4 multiplied by 2 is 8. 8 multiplied by 2 is 16. Then 32 multiplied by 2 is 64, and 64 into 2 is 128. Now we have the place value for each binary digit. Now circle the decimal numbers underneath the ones. 128, 16, 4 and 2. Now adding them together we get 150. Therefore the decimal equivalent of this binary number is 150. In this way, you can convert any 8-bit binary number into a decimal. And of course, if you are given a longer binary number, then add the place values by multiplying the previous value by 2. We can also do quick mental calculations. Just memorize the place value of each digit and add them where the digit is 1. With practice, it can be achieved easily. So that's all you need to know when it comes to binary to decimal conversion for IPv4 addressing. We are continuing where we left off in the previous video. In this video, we will learn how to convert any decimal number to binary. Let's say we have a decimal number 59 and we want to convert it into binary. The process is similar to the binary to a decimal conversion. This time, to convert the decimal number to binary, we first need to start by writing out the place values starting from the leftmost digit. Write 1 in the ones place and then multiply each subsequent place value by 2 as we move left. 1 multiplied by 2 is 2. 2 times 2 equals 4. 4 multiplied by 2 is 8. 8 into 2 is 16. 16 into 2 is 32. 32 times 2 equals 64 and 64 times 2 equals 128. These 8 consecutive powers of 2 provide enough place values to represent any decimal number less than 256. Now to convert 59, we need to find the binary digits or bits that we can add up to create the number 59. The process is straightforward. We identify numbers that can be used to reach the target number without exceeding it. We start with the largest number, which is 128 in our case. Since 128 is greater than 59, we can't use it to get or reach 59. If we can't use a number, we put a 0 under it. If it is used, then we write 1, so 0 here. The same goes for 64. It is greater than 59, so we can't use it. Again, put 0 under it. Now we have 32. Yes, 32 can be used to reach 59, so put 1 under that number. Next is 16. Can it also be used? The answer is yes, since 32 plus 16 is 48, which is less than 59. We can use it. So put a 1 under 16. Remember, if adding a number exceeds our target, we have to write 0, and we use 1 when a number can be used to reach the target without going over. Next is 8. Can we use 8? Yes, we can. 48 plus 8 is 56, so put 1 under 8. Then we have 4. Can we use 4? No, we can't. Adding 4 to 56 would result in 60, which exceeds our target number 59. So put a 0 in the corresponding position. Moving on to 2. Can we use it? Yes. 56 plus 2 is 58. So put 1 under 2. Then we have 1. Can we use it? Yes. 58 plus 1 is 59. Therefore, we place a 1 in the 1 position. So this is the binary representation of 59. 0, 0, 1, 1, 1, 0, 1, 1. So guys, this way you can convert any number from decimal to binary. Now let's convert one more decimal to binary. Let's say 171. The process is the same. We need to identify numbers that can be used to reach the target number without exceeding it. Again, we start with the largest number, which is 128. Since 128 is less than 171, we can use it to reach 171. Therefore, the write a 1 in the corresponding position. Next is 64. Adding it to 128 would exceed our target. So we skip it and write a 0 in its position or beneath it. Moving on to 32. Adding it to 128 gives us 160, which is still less than 171. Therefore, we use 32 and write a 1 in its position. Next number is 16. Adding it to 160 results in 176, exceeding our target number 171. So we skip it and write a 0 in its position. Next is 8. Yes, 8 can be used to reach 171. 160 plus 8 is 168. So we write 1 under it. Next is 2. Yes, 2 can also be used to reach 171. 168 plus 2 is 170. So we use it and we write 1 under it. Finally, 1 is all we need to reach 171. Therefore, we write 1 in its position. 170 plus 1 is 171. So 10101011 is the binary equivalent of decimal 171. Now this is an 8-digit number. So highest number an 8-bit binary number can represent is 255. If you add all the digits together, you get all possible combinations from 0 to 255. Therefore, these 8 bits can represent numbers from 0 to 255. If you need to represent a number larger than 255, you will need more than 8 bits. All we need to do is increase the number of bits. For example, adding just one more bit or 9th bit allows us to represent numbers from 0 to 511. You can simply add bits as needed to handle larger numbers. I specifically used 8 bits because 8-bit binary conversion is heavily used in subnet masks and subnetting. Each part in an IP address or subnet mask uses 8 bits called an octet. Therefore, for these applications, understanding 8-bit conversion is sufficient and you don't need to dive into advanced algebra. It is more than enough. In this video, we will learn about two operators, the OR operator and the AND operator. Both of these operators are also known as logical operators. Specifically, the AND operator plays an important role in IPv4 addressing, especially for tasks like identifying network IDs, subnetting, and related topics. Understanding AND operator is essential for mastering IPv4 addressing, but don't worry, it is actually quite simple to grasp. So let's start with AND operator. The AND operator is a Boolean logical operator used in algebra and computer science. It only accepts Boolean values as inputs, meaning you can't provide decimal numbers as inputs. Now there are only two Boolean values, true and false. The AND operator accepts only these two Boolean values as inputs, and the result of an AND operation is always either true or false. It is important to remember that the Boolean value true is commonly represented by 1 and false is represented by 0 in computer science. This means you can use 1 instead of true and 0 instead of false in most cases. Now let's understand how the AND operator works. We need to provide two Boolean values or inputs to the AND operator. Then it gives an output that is either true or false. Here I have 3 columns, input 1 and 2. The AND operator requires 2 inputs or Boolean values. Then the third column is going to display the output or result of the AND operation. Now I have enclosed 1 and 0 in brackets because true and 1 are equivalent in Boolean logic, and 0 and false are also synonymous or same, so don't get confused here. The first expression is true and false or 1 and 0. It evaluates to false. The result is false. Then we have false and true. The result is also false. The false and true also evaluates to false. Now we have the last combination, true and true, or 1 and 1. Now if we apply the AND operator to these two true values, the output will be true. So the only time the result of the AND operation is true when both values or inputs are true. So remember this important point. Only true and true result in true in AND operator. All other combinations result in false. So that's all about AND operator. With two Boolean values, you can only have 4 possible combinations of inputs. True and true, true and false, false and true, and false and false. Now let's talk about the logical OR operator. While not as important for IPv4 addressing as the AND operator, understanding it is still crucial. In some ways, it functions similarly to AND operator. Once again, I have 3 columns, input A, B, and the result. This time we will be using OR operator. Unlike AND, which produces a true result only if both inputs are true, the OR operator produces a false result only when both inputs are false. The first expression that we have, true or false, or 0 or 0. The result is true because at least one of the operands is true. Now false or true is also true, and true or true is also evaluated as true. However, the OR operator produces a false output only when both inputs are false. This means that if one operand or input is true, the result is always true. This is the important distinction between the OR and AND operators. All other combinations of inputs will result in a true output except for false and false. So to summarize, AND operator produces true in its output when both inputs or operands are true, and the OR operator produces false as its output only when both inputs are false. That's all you need to know about these two operators. Nmap is an extremely important tool in cybersecurity. Whether you are a network engineer, cybersecurity analyst, or an ethical hacker, Nmap is useful for everyone in general. It is a tool that should be part of your cybersecurity skill set. Now, what is Nmap? Nmap is an advanced information gathering tool that hackers and pentesters use to obtain information about the systems they intend to hack or test. Now what happens is that before actually hacking a system, attackers need to collect information about their target system. Hackers search for openings or possible access points for infiltration. Nmap provides this information quite easily and masterfully. Nmap is a port scanning tool. It scans for open ports, vulnerabilities, and various services running on a system. This is the first practical video on Nmap. In this video, we will learn the fundamentals of Nmap scanning and analyze all three states of a port. Now let's jump into the practicals. So open your terminal and type Nmap. The first thing that I always like to do when learning a new tool is check the options that it offers. So type Nmap --help. The help parameter displays all the options that can be used with Nmap. So press enter. As you can see, these are the options or available options that can be used with Nmap. Let me tell you guys, Nmap is a very advanced tool. Therefore, it offers all these options. So feel free to go through this documentation. Now type Nmap space. Now before scanning the target network, you should always check whether it is up and running or not, because if it is not running, then it is pointless to scan. So type -S uppercase P. S stands for scan, P stands for ping. In the background, Nmap conducts the ping scan to check whether the specified host is up and running or not. Now specify the name of the host. You can either specify an IP address or a domain name. I'm gonna specify the domain name scanme.nmap.org. Remember guys, you can't randomly scan any website on internet with Nmap. It is illegal. Fortunately, Nmap provides this specific server or subdomain that we can use for learning Nmap or practicing Nmap. Or if you have your own server or domain, then you can specify that as well. Now the way this command is gonna work, Nmap will conduct the ping scan in the background to check whether the provided host is running or not. Press enter. As you can see, one host up, it means the specified host is up and running. Now we can proceed further with the scanning. Type Nmap, type the name of your target network, scanme.nmap.org. Now this is the default Nmap scan without any options. By default, Nmap scans the most popular 1000 ports. If you don't provide any options like this, then Nmap will scan the most popular 1000 ports. So press enter. It is gonna take some time to complete the scan because Nmap has to go through all the 1000 popular port numbers and determine their state, whether they are open or filtered. As you can see guys, the scan is complete. Now let's analyze the result. The first nice thing that the Nmap does is it prints the IP address. As you can see in the brackets, we have this IPv4 address. This is the IPv4 address of this specified host. Now, instead of using this domain name, we can directly use this IPv4 address. So what I'm gonna do is copy this IPv4 address, and here is the IPv6 address for this domain name. Now let's analyze the actual result, which is this. So here we have 987 port numbers closed, and remaining 13 are either open or filtered. We have 3 columns here. Port column displays the port number, state column displays the state of a port. There are 2 possible states of a port. Either it can be open or filtered. We'll get back to it in a minute. Then we have service column. It displays the service running on a port. For example, the port number 22, it is open, and the service running on port number 22 is SSH. The default port for SSH is 22. Now, what does the open port mean? It means that this port is accepting connections or ready to accept connections. The SSH essentially allows us to access servers or computers remotely from anywhere. So if the SSH port is open, it means you can access a server or computer remotely from anywhere. You just need to provide the correct login credentials. Now, what does the open port mean from a hacker's perspective? Well, if the legitimate users can access or log in the SSH, so can hackers. Hackers can basically hack the SSH service by brute forcing its login credentials. Or if the SSH version is vulnerable, then they can exploit that particular vulnerability. So an open port can be vulnerable if it is not properly protected. Then we have port number 25, which is filtered. Now, what does the filtered port number mean? It means it is probably protected by a firewall. Only the authorized person can access the port number 25, or you can say only the authorized users can connect to port number 25. We have a plenty of open ports such as FTP. FTP is similar to SSH. The only difference is that SSH is secure. Communication on SSH is encrypted, whereas on FTP the communication is carried out in plain text. So that's it for this video, guys. Thank you very much for watching, and if you have any questions, then let me know. Wireshark is a complicated tool, right? So in this video, I'm gonna simplify Wireshark for absolute beginners. So guys, if you are someone who is new to Wireshark or struggling with it, then trust me, by the end of this video, you will be able to use Wireshark efficiently. Wireshark is a special tool used for monitoring computer networks. Wireshark helps you to see what is happening when your computer sends and receives data. It monitors or captures all the network traffic. Wireshark is of course free and open source tool. Wireshark is a must-know tool for security analysis. It is often used to detect and analyze network security threats such as hacking attempts, unauthorized access to sensitive data, and it can easily identify attacks or suspicious traffic on your network. It is a go-to tool for cybersecurity analysts. Wireshark can be used to analyze network traffic in real time to identify and resolve network-related problems such as slow performance, dropped packets, and other connectivity-related issues as well. Developers can use Wireshark to understand how protocols work and identify issues related to their implementation. These are just, the main uses of Wireshark. It is a very vast tool. It can be used for, many other things. Now to download and install Wireshark, go to the wireshark.org, click on download. Here we have files for Linux, Mac and Windows. So download the appropriate file according to your operating system. Here, as you can see guys, we do not have files for 32-bit systems, right? This is because Wireshark 4.0 or higher versions do not support 32-bit systems, right? So if you have an older computer or 32-bit system, then you have to download this file 3.6.11. So click on this down arrow. From here you can download 32-bit file for your operating system. And I'm not gonna go through the installation steps because installation process is very simple on all operating systems. On Windows, make sure that you do not check or uncheck anything during the installation, right? Keep clicking on next, then your installation will be successful. If you come up with any problems during the installation or any part of the video, then let me know in the comment section and I will happily answer everything. Alright, so once your installation is complete, then open your Wireshark. And this is the welcome window of Wireshark. It displays all the installed network interface cards, and this list is going to be different for everyone. Most likely you are not gonna see all these local area connections because they are not real or physical cards. They are created by my virtual machines. Now there are two inbuilt network cards on each system, Ethernet and wireless card. Ethernet is simply represented by Ethernet on Windows and wireless card is represented by Wi-Fi. And on Linux, the wireless card is represented by WLAN 0 and Ethernet is represented by ETH0 on most Linux distributions. Now to start capturing packets, you have to select one of these physical network cards. Now which one exactly you have to select? Well, it depends on your connectivity, how you are connected to your network or how you are accessing the internet. I'm connected to my network through Wi-Fi or wireless card, so I'm gonna select Wi-Fi. As you can see, it is showing some spikes, right? These spikes are indicating that there are some activities going on this particular interface. We also have spikes on adapter for loopback traffic interface as well. Well, this is the local host. It does not capture your network's traffic. It only monitors your system traffic. This is not that important. Again guys, I'm gonna select Wi-Fi to start capturing packets. So double click on the appropriate interface. As you can see, Wireshark is capturing packets, right? At the top you can see capturing from Wi-Fi, right? Now first thing that I'm gonna do is explain what all these different sections or components mean, what information they represent. So go to the view menu. Allows us to control the components that you want to appear in your display area. As you can see, Wireshark has already pre-selected some of the components for us. First three selected components are main toolbar, filter toolbar and status bar. This is the main toolbar. It contains the functions that you are gonna use on a regular basis. I will get back to all these functions later in the video. Then we have filter bar. This is the filter toolbar. Here you can type your filters. Filters are basically used to hide unnecessary traffic. I will get back to filters later as well. For now, just remember that if you want to type and apply the filters, then this is the place where you can type the filters. Then we have a status bar at the bottom. This is the status bar. As you can see, it basically gives you a brief summary of captured or lost packets. Then we have packet list. This section is called packet list. Packet list displays or contains all the captured packets. Every single packet that Wireshark captures is going to be displayed or listed here. Then we have packet details. As you can see, guys, the packet list section only gives you a brief overview of each captured packet. Now, if you want to analyze packets in detail, then you can use packet details section. For example, let me stop the session first. I'm gonna click on packet number 139. Now, down here, packet details section is displaying a detailed information about the selected packet. As you can see, frame number 139. Now here you can analyze the selected packet in detail. Now let me click on different packets. As you can see, the information keeps changing as I click on different packets. Then we have packet bytes. On your right side, this section or panel is called packet bytes. It displays information in its raw or original form, right? As you can see, the default format is hexadecimal, and you can also change it to a binary. So click on the blank space, click on as bits. Now as you can see, information is in raw binary. I'm gonna revert back to the hexadecimal format because it is a little more presentable than binary. And if your packet contains plain textual information, then that information will also be displayed here as it is in its raw form. Now go to the view. Let's say you do not want packet bytes section, then click on this packet bytes or whatever you want to hide. Now as you can see, it has been completely hidden. So to get it back, go to the view, again click on packet bytes. Now it is back here. Now let me walk you through what all these columns mean, right? So first column that we have is NO. NO is short for number. It basically displays the packet number. Each packet is going to have a unique number. As you can see, the first packet that Wireshark captures is automatically assigned number 1, second packet 2, and so on. Then second column is time. Time column displays the exact time when a packet was captured. Right now the default format for displaying time is not that presentable, right? So let's change it first. So go to the view. Now click on time display format. From first half, select time of the day. Again go to the view, time display format. From lower half, select seconds. Now as you can see, we have a much better or presentable format for displaying the timing of captured packets. Then we have source. Now source column displays the IP address of sender who has sent the packet. Destination column displays the IP address of receiver where the packet has been delivered. So let me select, let's say, packet number 30. Sender of the packet number 30 is this IP address 192.68, and it has delivered this packet to this device 35.3. Then protocol column displays the packet type, whether it is TCP, ICMP or UDP packet. Length column displays size of each packet in bytes. Info column, it gives you a brief overview of each captured packet. So that's what all these columns mean. Now let's go through all the toolbar functions. Red button stops the current running session, and first button from left starts a new session. So click on it. As you can see, before starting a new session, Wireshark is asking me whether you want to save already captured packets. So I'm gonna click on save, then give it a file name, let's say packets. Now you don't have to write any extension after the file name. Remember, Wireshark automatically saves your packets with .pcap or pcap-ng extension. Pcap-ng is the default extension for saving Wireshark files. click on save. Now a new session has been started. Then third button restarts a new session. So if you want to restart a new session when you already have a session running, then click on this button. And here also, if you want to save already captured packets, then click on save before continuing. This time I'm gonna go with continue without saving. Then fourth button is capture options. Capture options button cannot be accessed when you have a session running. So let me stop the session first. Now if I click on the capture option button, as you can see, now it is working. Now capture options window displays all the network interface cards, just like your welcome window. The only difference is that it gives you a much better control over interfaces. As you can see, we have additional options such as promiscuous mode and monitor mode. Okay, I will get back to capture options later. Then we have open a capture file button. So this button allows you to open a already saved file. So click on it. Now I'm gonna double click on the file that I saved a few seconds ago. So double click on the file. Now continue without saving. Now as you can see at the top, packets.pcapng, Wireshark is reading packets from this particular file. Then next button that we have is save this capture file. So this button basically gives you option to save your packets quickly. So click on the button, write the file name, then click on save. It will save the packets. Now another way to save packets is go to the file, click on save as. Then next button is close. So close button takes you back to your welcome window, as you can see. So let me start the session again. Now next button that we have is find. So click on the button. It basically allows us to search for packets based on different types of values. As you can see, we have a drop down menu here. So click on the down arrow and let me start with, let's say, string. Now in this box, type a string or text, let's say payload. Now let me click on find. As you can see guys, it is highlighting the packet that contains the word payload right here, as you can see. So when you select the string option, whatever you type here, Wireshark is gonna search for that particular text or string in each packet. Wherever it finds the word payload, then it will highlight those packets. As you can see, for now it is highlighting packet number 55. Now if I click on find, it is highlighting the next packet that contains the word payload, like this. Then we have hex value option. Let me select it. Now here you can search by hexadecimal values as well. So let's say 4A. Now click on find. As you can see on the packet bytes panel, 4A is highlighted, and in the packet list section, Wireshark is highlighting the exact packet that contains this value. Then we have a display filter. We have not covered the display filters yet, right? Once you will learn display filters, then you will automatically learn to use this feature. For now, you don't have to worry about it. Then next two buttons that we have are right and left arrow. So right arrow button basically takes you one packet up from your current position. My current position is, let me click on 8. So if I click on left arrow button, it will take you one packet up, and right button is gonna take me one packet down from my current position. Then we have go to specified packet. Click on the button. Here in the box, type the packet number, let's say 5, and click on go to packet. Then as you can see, it has taken me to the packet number 5. It is being highlighted. So whatever number you type in here in this box, Wireshark will take you to that particular packet. Then we have up and down arrow keys. The up arrow key is gonna take you to the first captured packet in the list. Click on it. As you can see, it is highlighting the first packet in the list, and down arrow key takes you to the last captured packet, right? Next button that we have is this automatically scroll to the last packet during live capture. So when you enable this button, it will automatically take you to the last packet that Wireshark captures during the live session. As you can see, it has this light blue background color, right? It means it is enabled, right? If I click on it, now it is disabled. It is advised that always keep it enabled. Now the next button basically enables the packet coloring. As you can see, we have packets with different colors, right? TCP packets have a different color and ARP packets have a different color. So what basically Wireshark does, it assigns a unique color to most commonly used protocols or filters, so we can easily identify the packets, right? So when I'm gonna see this light pink color, I can automatically recognize, yeah, this is an ARP packet. Now if you want to find out which color is associated with which filter or protocol, then go to the view, click on coloring tools. Now here you can basically see which color is associated with which filter or protocol. UDP protocol is going to have this light gray background color, so feel free to go through the list. You can even customize these colors. Let's say for ARP you want a different color, so click on the ARP, then down here click on background, then select a color of your choice, then click on OK, and after that click on OK, then color will be changed. In the same way you can change foreground or text color as well. Select the color, click on OK, then click on OK. Changes will be applied right away. Then next buttons that we have are plus and minus. Plus button basically is used to increase the font size, as you can see, and minus button is for decreasing the font size, and button next to minus button sets the font size to default. If I click on it, as you can see, the font size has been set to the default. Now the last button resize or sets the packet columns size to default. As you can see, my destination column is overlapping the source column, right? Now if I click on this last button, as you can see, the size has been set to the default. Now I can see contents of each column easily. Filters are used to hide or filter out unnecessary traffic. For example, here as you can see, I have thousands of packets, right? Now let's say I only want to see HTTP packets in my packet list section. All other traffic is irrelevant or useless to me. In that case, if I manually try to locate every single HTTP packet among thousands of packets, then it is going to take a lot of time, right? So to solve this problem, we have something called filters. Filters allow us to exactly see what you want to analyze and see in your packet list section. For example, I only want to see HTTP packets. Then all I have to do is type a valid HTTP filter. Then Wireshark is only gonna show all the HTTP packets and other traffic will be hidden. So this is as simple as that. We have two types of filters in Wireshark: display and capture filters. Display filters are used or applied on already captured traffic. As you can see, I already have captured packets. Here I can apply the display filters, and I will get back to capture filters later. Now let's do some practical examples of display filters. Display filters can be written and applied here in the display filter bar. So I'm gonna start with filtering HTTP traffic. So traffic filter for filtering HTTP traffic is just HTTP. So type HTTP. As you can notice, when you type a correct or valid filter, Wireshark automatically changes background color to green. Green background means a valid filter. Now if I type something that Wireshark does not recognize, then background color changes to pink. So green means valid, pink means invalid filter. Now how to apply the filter? We have two options. First, press enter. Now as you can see, filter has been applied. Under the protocol column, Wireshark is only displaying the HTTP traffic, because this is exactly what I have told Wireshark. Only show me HTTP traffic. Now another way to apply filters is click on this right arrow on your right side. Click on it, then filter will be applied. You can clear filters by clicking on this cross button. Now as you can see, we are back to the normal. Now let's filter, let's say, DNS packets. So filter for that is DNS. Hit enter. Now as you can see, Wireshark is only displaying the DNS packets. Now I want to see, let's say, TCP packets only. So filter is TCP. As you can see, it is only showing the TCP traffic. In the same way, let's say I want to see UDP packets. So filter for that is UDP. Now let me see whether I have any ARP packets. So type the ARP, hit enter, and yeah, this is the ARP filter for filtering ARP packets. In the same way, you can filter all the possible, network traffic. All you have to do is remember the protocol name, then type that in here in the filter bar. Now let's filter encrypted or HTTPS traffic. Your first guess might be HTTPS, right? As you can see, this is not a valid filter, right? So to filter secure or HTTPS traffic, then you have to type TLS. So press enter. As you can see, now Wireshark is showing all the encrypted traffic. TLS filter makes sense because HTTPS protocol is actually combination of HTTP and TLS. TLS takes the HTTP traffic, then encrypts it, and that makes the HTTPS protocol. Sorry, I forgot to add S. Now, till now, we have used or filtered one type of traffic only, right? Now, let's say I want to see ARP and DNS packets simultaneously. It can be done through something called operators or operator. So type DNS, then write OR and ARP. OR operator is used to combine multiple filters. So here I am basically telling Wireshark, if you find DNS packets or ARP packets, then show me all those packets. So if I hit enter, then Wireshark, as you can see, it is displaying all the DNS and ARP packets. In this way, you can combine as many filters as you like. So let me add another filter, TLS or ICMP. Okay, so feel free to add as many filters as you like. And OR operator can be written with two pipes as well, like this. UDP. This is also a valid filter, or ARP. See guys, the OR operator pretty much works as it works with programming languages. So here it can be used to combine multiple filters. Now let's use NOT operator. So type NOT and TCP. Now what does it mean? NOT operator basically negates the value that you supply to it. Here I'm telling NOT operator that, okay, don't show me TCP packets, show me everything but not the TCP packets. So if I hit enter, you are not gonna see any single TCP packets in the list, as you can see. And NOT operator can be written with exclamation symbol as well. So exclamation TCP, it is also a valid filter. Now let's filter traffic by port numbers. So type let's say TCP. I want to filter traffic on port number let's say 80 port is for HTTP, right? So if I hit enter, it is not a valid filter. Sorry, I forgot to add equal to signs. So port number 80 means it is going to list all the HTTP traffic. Here also you can use OR operator, or TCP dot port EQ means equal to 443. So EQ or equal to sign, both are same. So if you hit enter, now this time I'm telling Wireshark, if you find HTTPS or HTTP traffic, then list all those packets. So 443 port number is obviously for secure or HTTPS traffic. Now let's cover another very important filter called IP addr. IP addr filter is basically used for filtering traffic by IP addresses. Let's say you want to check all the packets that a particular IP address has sent or received. So write IP.addr equal to, then paste the IP address. Now this filter is gonna only display the packets that this particular IP address has sent or received. So if I hit enter, now as you can see under the source and destination column, right, you can use OR operator to combine multiple IP addresses. So let's say you want to check packets that multiple IP addresses have sent or received, then use OR operator IP.addr, let's say here 79. Now this filter is gonna display all the packets that these two IP addresses have sent or received. In this way you can combine as many filters as you IP addresses as you like. Now here also we can use NOT operator. So if I type NOT at the beginning, then what I'm telling Wireshark this time is, do not show me packets that this particular IP address has sent or received. So if I hit enter, you are not gonna see this IP address in the packet list, as you can see, because we have clearly told Wireshark, don't show me packets that have been sent or received by this IP address. And another important filter that I'm gonna teach you is contains. So type TCP, let's say contains, now within the double quotes write YouTube. Now what this filter is gonna do, it will check every single packet in the list and see whether the packets contain the word YouTube. If any packet contains YouTube, then that packet will be listed here. If I hit enter, and as you can see, there are no such packets that contain YouTube. Now let's try the DNS. Now as you can see, we do have DNS packets that contain YouTube. So as you can see, youtube.com. So this IP address visited this website YouTube, or it basically made DNS queries to youtube.com, right? Now let's move to the capture filters. Now capture filters allow you to have control over your traffic, what you want to capture. Capture filter, as the name suggests, you can basically tell Wireshark before starting a new session what you want to capture, right? By default, Wireshark captures all types of traffic floating on your network. Now let's say you only want to capture HTTP traffic, right? You don't want to capture any other traffic, just FTP or HTTP. Then you can tell it to Wireshark before starting a new session. Then Wireshark will only capture whatever traffic you tell it to capture. So you have to go back to your welcome window. Now first thing that you have to do is select the interface where you want to capture the traffic. Then here, as you can see, we have the box where you can type the capture filter. Capture filters are different in terms of syntax from display filter. So if I type, let's say HTTP, then as you can see, it is not a valid filter, right? So to write a filter to capture HTTP traffic, then we have to write port, then port number 80. So port for HTTP is 80. So this filter is gonna capture the HTTP or traffic on port 80. Now to start capturing packets, double click on the interface. Now as you can see guys, at the top, capturing from Wi-Fi on port number 80. So it is only gonna capture traffic on 80. So let me visit, let's say this is an HTTP website. As you can see, not secure. It is capturing HTTP traffic. Now let me visit a website which uses HTTPS, let's say YouTube. As you can see, it is not capturing anything, right? So to confirm it further, let me apply the TLS filter. As you can see, TLS found nothing because this filter, capture filter, is only gonna capture the HTTP traffic. Now back to the welcome window again. Another place where you can type the capture filters is go to the capture options. Now here select the interface first, then write the filter. Here as you can see at the bottom we have a box. So port number 80. Now let's say I want to capture FTP traffic, then you have to write the port number for FTP, which is 21. Here also you can use OR operator. So type port, now let's say 22. Now this time Wireshark is gonna capture both HTTP and SSH and FTP traffic. You can combine as many filters as you like here. And if you click on start, then it will start capturing traffic. Now if you want to capture, let's say only TCP traffic, then you can directly write TCP and UDP. Filters are common for both display and capture filters, right? Let's say UDP. Now let's say you only want to capture traffic that a particular IP address sends or receives. Then write the host filter, then paste the IP address. Now this filter is only gonna capture the traffic that this specified IP address sends or receives. So guys, that is it for filters. If you want to learn more about filters, then feel free to check my Udemy course, where I have covered a plenty of advanced filters. Now you need an external wireless card for Wi-Fi penetration testing. These are the recommended cards suitable for Wi-Fi pen testing that you can consider purchasing. They are all compatible and supported by Kali Linux. We are going to use Kali Linux for Wi-Fi penetration testing. Kali Linux has all the tools pre-installed that we need for Wi-Fi penetration testing and security. In this video, we will learn how to connect your wireless network card to Kali Linux and address the common errors that may arise initially. Now let's dive into the practicals. Before you plug in or connect your wireless card, we need to upgrade the system. So type sudo apt. First we need to update the repositories. Now provide your password. Let the update command finish. Now once the update command completes, then we need to execute upgrade command. So type sudo upgrade, press enter. Now type y, press enter. Let the upgrade command finish. It is very important. Now once the upgrade command finishes, now we are good to go. Now plug in or connect your wireless network adapter to your USB port. To use your wireless card in your Kali Linux virtual machine, go to the devices, click on USB, and your wireless network card's name should appear in this list. I have an Alpha network card that uses an Athereus chipset. As you can see, it is listed here. So click on your network card or appropriate network card. I'm going to click on Athereus. Now once selected, Kali Linux is going to take around 15 to 20 seconds to set up everything when you use your wireless network card for the first time in Kali Linux. Now wait for 15 to 20 seconds. Now to verify whether your card is detected by Kali Linux or not, type IP space A, press enter. As you can see guys, WLAN 0, my wireless card has been detected. W stands for wireless, LAN stands for local area network, and the number 0 represents the card number. Each wireless card has a unique number assigned to it. The first wireless card that you connect is assigned number 0. If you connect another card, that card will be assigned number 1. In case if your card is not appearing or Kali Linux has not detected it, then disconnect your card, then reconnect again and repeat the same steps. Go to the devices, USB, click on Athereus or whatever chipset your card is using. Now let me verify again. As you can see, WLAN 0, it has been detected. Once detected, now you can use your wireless card to connect to a Wi-Fi network. Click on the networks icon, click on available networks. Now select the Wi-Fi network that you want to connect to. As you can see, now sometimes you might encounter errors like this: can't attach USB device, failed to attach the USB device. In case if you do encounter such an error, then solution is simple. Disconnect your wireless card, then reconnect again. Now go to the devices, USB. As you can see, my network card is already selected. If it is already selected, then you don't need to do anything. Just wait for a few seconds and type IP-IPA to verify it, as you can see. And if it is not selected, then select your chipset. Then it should automatically solve the problem. In case you have a different network card and Kali Linux is not detecting it, post your questions in the Q&A section. I will definitely answer your queries there. If you have a network card that I recommended, Kali Linux will detect them automatically. You don't need to install drivers for them if you use Alpha series cards. Now once the wireless card is detected, now we are good to go. Now let's talk about the tools that we are gonna use for wireless penetration testing. The tool that we are gonna use is Aircrack-ng. Now Aircrack-ng is not a single tool, rather it is a complete suite. It is collection of many tools. Aircrack-ng is the best tool out there for testing wireless security. Each tool within Aircrack-ng is designed for specific tasks. For example, Aircrack suite has a tool called Aerodump-ng. Aerodump-ng is used for capturing packets, and then we have Airmon-ng, which is used for controlling the monitor mode. The Aircrack-ng itself is used for cracking passwords. There are many more tools in the Aircrack suite that we will explore as we progress through the course. Now we need to verify whether Aircrack-ng is detecting the wireless card or not. So type sudo airmon-ng, press enter, provide your password. As you can see, airmon-ng has also detected the wireless card. It means this card is compatible with airmon-ng. Now we are good to go. Remember guys, you will need to repeat the same steps each time you want to use your wireless adapter in your Kali Linux virtual machine, right? After plugging in the card, you need to go to the devices, USB, then select your wireless card. A wireless network card can operate in two modes, managed and monitor mode. In managed mode, also known as normal mode, the wireless network adapter is used for standard tasks such as connecting to Wi-Fi networks, accessing the internet, and utilizing other network resources. Monitor mode, on the other hand, is entirely different. It allows us to intercept or capture all network traffic being transmitted over a specific Wi-Fi network or all surrounding wireless networks within its range. Wireless cards operate in managed mode by default, allowing you to connect to Wi-Fi networks. However, to capture or monitor network traffic, we need to switch or change the network card to monitor mode. In monitor mode, a wireless network adapter can capture wireless network traffic within its range. Now let's discuss the real question: why do we need to capture wireless network traffic? Well, to hack a Wi-Fi network, certain information is required. This information can be obtained by capturing packets, and monitor mode allows you to capture those required packets. Specifically, we need the four-way handshake, which can be intercepted using monitor mode. However, it is important to note that this mode is often used for legitimate purposes by network administrators, security professionals, and researchers. They use it to monitor and analyze wireless network traffic for troubleshooting, security testing, and research purposes. In the next video, we will enable the monitor mode. In this video, we will finally learn how to enable and disable monitor mode as well as how to restart the network manager. Now let's jump into the practicals. First, connect or plug in your wireless network card. I have already plugged in mine. Let me verify that. Type IP space A, press enter. As you can see, here it is WLAN 0. I'm gonna put a WLAN 0 into the monitor mode. So type sudo airmon-ng. Airmon-ng is part of the Aircrack suite. It is used for controlling the monitor mode, including enabling and disabling it. Now, before enabling the monitor mode, we need to check for processes that might cause problems later. There are certain processes that might put your card back to the managed mode from monitor mode. So let's check those processes. Pass check parameter. It will list those processes. Press enter. As you can see, found two processes that could cause problems. Now we need to terminate these processes. It is easy. After check, type kill. Kill parameter is going to kill or terminate those processes. Press enter. As you can see, this process has been terminated. Now we are good to go. Type sudo airmon-ng space, type start space. Now specify the name of your wireless card that you want to put into the monitor mode. For me, it is WLAN 0. Now airmon-ng is going to start the monitor mode on this specified wireless card WLAN 0. Press enter. As you can see, monitor mode enabled for WLAN 0 on WLAN 0 mon. It means that the specified wireless card WLAN 0 has been put into the monitor mode under the new name WLAN 0 mon. And if you want to use or access the monitor mode, then we have to use this name WLAN 0 mon or whatever name it is after this particular part. Now let's actually verify whether the card is in monitor mode or not. Type IP space A at the bottom. As you can see, WLAN 0 mon. The card is indeed in the monitor mode. We can also use iwconfig command to verify the monitor mode. Press enter. As you can see, mode monitor. Now once your card is in monitor mode, you can't use it for general purpose like connecting to the Wi-Fi networks. In monitor mode, we can capture traffic and monitor all the Wi-Fi networks within your network card's range. We will do that in the next video. Now let's learn how to put your card back to the managed mode. At some point you will need to put your card back to the managed mode, right? Once you are done with Wi-Fi pen testing. So type sudo airmon-ng ng stop. Now type name of your monitor mode, which is WLAN0MON for me. Now airmon ng is going to stop the monitor mode WLAN0MON. Press enter. As you can see guys, monitor mode disabled for WLAN0MON. Now let me list network interfaces IP space A. As you can see guys, the card is back to the managed mode. Let me actually type iwconfig. Press enter. As you can see, mode managed. Now after putting your card back to the managed mode, you should always restart your network manager. So type sudo systemctl space restart, type network manager. Make sure that N is in uppercase and M also must be in uppercase. Now what this command is gonna do, it will reset your network configurations, fix common problems, and your card will become ready to be used in managed mode. Press enter. Now command has been executed successfully. Now click on your network icon. As you can see guys, now my wireless card is up and running. That's it for this video guys. Thank you very much for watching. In this video we will learn how to detect or discover Wi-Fi networks within your network adapters range, explore the fundamentals of AeroDump-ng scan, and save the network traffic to a file. This is definitely going to be an exciting and informative video. So let's dive into the practicals. The first thing that you are gonna do is put your wireless network adapter into the monitor mode. I have already enabled monitor mode. Let me verify that. Type IP space A, press enter. As you can see, WLAN0MON, my card is already in the monitor mode. We need the monitor mode for capturing wireless network traffic and discovering Wi-Fi networks. Once your card is in monitor mode, we are good to go. Now type sudo AeroDump-ng. AeroDump-ng is also part of the Aircrack suite. AeroDump-ng is a powerful tool used for capturing wireless network traffic. It also discovers and displays information about the nearby Wi-Fi networks. Now after AeroDump-ng, specify name of your monitor mode, which is WLAN0MON for me. Now this particular AeroDump command is going to discover and display information about all the available Wi-Fi networks within the range of your wireless card. Let me press enter. As you can see guys, the AeroDump is scanning for the nearby Wi-Fi networks. It scans and lists all the nearby Wi-Fi networks within the range of your wireless card. Now we have a lot of information here, right? I will break down everything. We have two sections here. In the first half, it displays all the Wi-Fi networks that it has detected along with their information. In the bottom half, it displays the devices that are connected to these Wi-Fi networks. Now first thing that we have to understand is what all these columns mean, what information they represent. Now the first field is BSSID. BSSID refers to the MAC address. Each wireless access point or wireless router has a MAC address. For example, the MAC address for the network Cyborg is this. Then we have PVR. PVR indicates the signal strength. It basically tells us how close we are to a Wi-Fi network. If the PVR value is around 70 or above 70, then it means the signal strength is weak. If it is below 60, then the signal strength is considered average, and if this value is below 40, then it means the signal strength is strong. You are close to a Wi-Fi network, or you have a very powerful wireless card. Then we have beacons column, it displays the total beacon packets that a Wi-Fi network has transmitted. A Wi-Fi network uses beacon packets to announce its presence. On average, a Wi-Fi network sends around 10 beacon packets per second. In simple terms, through beacon packets, a Wi-Fi network basically tells the nearby wireless devices, I am available, you can connect to me if you have the proper authority. Then we have data column. It displays the number of packets captured by the network card on each listed network here. Remember guys, AeroDump-ng is capturing or listening to the network traffic of each network that it has detected or listed here. Later in the video, I will demonstrate how to save the captured packets. Data field helps us to understand the amount of data traffic on the network. And next is /s. It stands for seconds. It shows the average number of data packets a network has transmitted each second, calculated over the last 10 seconds. And then we have CH. CH stands for channel number. It displays the channel number on which the wireless access point or wireless network is operating. Then we have MB. MB displays the maximum speed supported by a Wi-Fi network. And next is ENC. ENC is short for encryption. It indicates the type of encryption protocol the network uses for encrypting packets. 95% of networks still use WPA2, although WPA3 is available, which is updated version of WPA2. It is considered more secure. However, WPA2 remains the most widely used encryption protocol, with over 95% of networks still using it. WPA2 makes sure that data sent or received over a wireless network is encrypted. And next is cipher. Cipher refers to the specific algorithm used for encrypting and decrypting data within the encryption process. CCMP is specifically used with WPA2. It offers significantly more security compared to older protocols like WEP and TKIP used in WPA. And next is auth. AUTH. Auth refers to the authentication method used to protect against unauthorized access to the network. It specifies how devices are authenticated before being allowed to connect to the network. PSK stands for pre-shared key, indicating that the Wi-Fi network utilizes a shared password. All users are required to use the common network password to connect to the network. To access the PSK Wi-Fi network, you will need to enter the correct Wi-Fi password. And the last column is ESSID. It basically displays the name of Wi-Fi networks. Here we have two Wi-Fi networks, Cyborg and Sunny. And in the bottom half, AeroDump displays devices that are connected to these Wi-Fi networks. First column, BSSID, it displays MAC address of the wireless access point or wireless router, and station column displays MAC address of the device which is connected to a network. For example, this MAC address or wireless device is connected to this Wi-Fi network. And if a device is not connected to any Wi-Fi network, then you will see something like not associated. Not associated means the wireless device has not connected to any Wi-Fi network. It is still searching for Wi-Fi networks to connect. Now, like I discussed earlier, we can save the packets that AeroDump is listening or capturing. Now here, the AeroDump is basically listening to the traffic of all these detected devices. We can save the traffic that it is capturing to a file. So press Ctrl+C to exit out of AeroDump. Okay, so type AeroDump ng wlan0mon, then type write Write parameter allows us to specify the file name where you want to save the captured packets. Now you can specify a specific directory where you want to save. If you don't specify any specific directory, then it will save the files in your current working directory. Now provide a file name, let's say captured packets. Now AeroDump is going to monitor the network traffic of all the Wi-Fi networks within its range and then save the traffic into this specified file captured packets. The files will be saved in your current working directory. Let me press enter. Now let me exit out of AeroDump by pressing Ctrl+C. Now type ls. As you can see, AeroDump has created these different files. AeroDump basically saves captured packets in different files. We have files with .cap extension, .csv, .netxml, etc. However, only relevant file for us is this .cap. We can open the .cap files in Wireshark. Let's actually do that. Type Wireshark space and then specify the file name that you want to open. Now what Wireshark is gonna do, it will open this specified file. Let me press enter. As you can see guys, inside this file we have the packets that the AeroDump captured. So guys, that's how you can save the captured packets to a file. So that's it for this video guys. Thank you very much for watching. In this video, we will learn how to scan Wi-Fi networks operating on the 5 GHz frequency band. This is a theoretical video. Practical aspects will be demonstrated in the next video. There are certain things about 5 GHz networks that we need to understand before diving into the practical aspects. By default, AeroDump-ng only scans and lists networks in the 2.4 GHz band, as we saw in the previous video. Now, what if a network is using only the 5 GHz band? Most networks use dual bands, but some specifically use only 5 GHz frequency band. To scan the 5 GHz networks, we have to use the band option in AeroDump-ng. Remember, this is important to scan or discover 5 GHz networks. Your network card must also support the 5 GHz band. That's the prerequisite. Now we need to use the band parameter with AeroDump to scan for 5 GHz networks. The band option allows you to specify different bands or a combination of bands that you want to scan. AeroDump supports two bands, 2.4 GHz and 5 GHz. We can also combine both, which enables us to scan for both 2.4 and 5 GHz networks. Now to scan and list 5 GHz networks, we need to use band A parameter with AeroDump. The letter A represents the 5 GHz band. We will demonstrate this practically in the next video. There are other options for the band parameter as well. B represents 2.4 GHz band using the old 802.11b standard, and G represents the 2.4 GHz band using the 802.11g standard, which is more common. G is also the default mode. If you don't specify any bands, by default AeroDump runs with the G option, and if you want to scan for both bands, you can use band AG option. Remember, specifying multiple bands can increase workload on your system and potentially slow down scanning. We will continue where we left off in the previous video. In this video, I will demonstrate how to scan for 5 GHz networks, practically also how to scan for both 2.4 and 5 GHz networks simultaneously. Now let's dive into the practicals. So type sudo AeroDump-ng space 2 hyphens, type band. The band parameter allows us to specify the frequency band that you want to scan for. I want to scan the 5 gigahertz frequency band or Wi-Fi networks. So type A. As we discussed in the previous video, A represents the 5 gigahertz frequency band. Now specify name of the monitor mode, which is WLAN 0 mon. Now this particular aerodump command is only going to discover and display the 5 gigahertz Wi-Fi networks or Wi-Fi networks using the 5 gigahertz frequency band. Remember guys, your wireless network adapter must support the 5 gigahertz band. Then only the aerodump will be able to scan and list the 5 gigahertz networks. Press enter. As you can see, aerodump has detected the 5 gigahertz network. It is still scanning. If it finds other 5 gigahertz Wi-Fi networks, then those will be listed as well. Now, how do you exactly know whether aerodump is scanning the 5 gigahertz networks or frequency band? Well, check out this particular section, CH. It is showing the range of channels that it is scanning. The range of 5 gigahertz channels is from 36 to 165. On the other hand, range of 2.4 gigahertz channels is from 1 to 14. As you can tell, it is scanning between 36 to 165. So guys, that's how you can scan and detect only 5 gigahertz networks. Now, I live in a very remote area. That's why I only have very few 5 gigahertz Wi-Fi networks. If you live in a densely populated area, then you might see a lot of 5 gigahertz networks. Now, let's scan the 2.4 gigahertz networks. I'm gonna exit out of aerodump by pressing Ctrl plus C. Now, by default, the aerodump scans for the 2.4 gigahertz networks. If you don't specify the band parameter, then by default it is gonna scan for 2.4 gigahertz networks. However, you can explicitly specify if you want to scan the 2.4 gigahertz band. So type band and specify G. G represents the 2.4 gigahertz band. Press enter. As you can see, this time it is only scanning the networks that use 2.4 gigahertz frequency band. As you can see, the channel section. Now let's scan both 2.4 and 5 gigahertz bands. To scan both, we need to provide A and G values to the band parameter. As you can see, I have specified A, which represents 5 gigahertz, and G, which represents the 2.4 gigahertz frequency band. Now this particular command is going to scan for both 2.4 and 5 gigahertz Wi-Fi networks. Remember guys, when you scan the multiple bands, it also increases the load on your system resources like RAM and processor. Press enter. Now check out the channels section. It is scanning the both bands from 1 to 14 and 36 to 165. That's how guys you can scan a particular band or multiple bands. That's it for this video guys. Thank you very much for watching. In this video, we are going to discuss the four-way handshake. In a wireless network, data is transmitted through the air using radio waves, right? Since the data travels through the air, it is always vulnerable to interception. If the network is not properly protected, hackers can easily intercept and steal your information by capturing the unencrypted or unprotected data. This can lead to compromised devices and stolen personal information across the network. Therefore, we need a mechanism to protect the data. As we have seen in the previous video, data can easily be intercepted. This is where the four-way handshake comes in. It refers to the initial exchange of 4 packets between a client device like your laptop or phone and a wireless access point you are trying to connect to. As we discussed in the cryptography section, keys or encryption keys are used to encrypt data, right? So to encrypt wireless data, we need encryption keys. The four-way handshake is the process of generating encryption keys. Encryption keys generated by a successful four-way handshake are also known as session keys. The keys generated during the four-way handshake are used to encrypt data between the client device and wireless access point. The four-way handshake establishes a secure connection between client device and a wireless network so they can communicate securely over an encrypted channel. After a successful four-way handshake, the client device and the wireless access point can communicate securely. This allows the client to access the internet securely. Data gets encrypted, and even if attackers intercept this encrypted data, they will only see scrambled or encrypted information, not the original data itself. Now, to hack a Wi-Fi network, we need to capture four-way handshake. Capturing four-way handshake is essential. Four-way handshake contains all the necessary details to initiate the password cracking process. By capturing, we mean intercepting a successful four-way handshake. The four-way handshake is essentially the exchange of 4 packets between a client device and a wireless router or wireless access point. We need to intercept 4 packets of four-way handshake to initiate the password cracking. The encryption keys used to encrypt traffic are derived from a combination of Wi-Fi password, SSD, MAC address of the access point, MAC address of the client, and nonce values among other elements. All this information is used to generate the encryption keys or session keys. These elements undergo a cryptographic function to generate session keys, which encrypt data during the Wi-Fi session. It is important to note that these elements are not directly combined to generate session or encryption keys. Instead, they go through 4 distinct steps within four-way handshake process. I'm not going to cover the entire four-way handshake in detail because it requires a separate crash course to fully understand it. To crack Wi-Fi password and learn the process, you don't need to understand the exact steps. They are not essential at all. Understanding the concept and its function is sufficient. This video is going to be very important. In this video, we will capture a four-way handshake. Capturing a valid four-way handshake is essential for cracking the password. Without a valid four-way handshake, we can't initiate the password cracking process. First, we need to capture the four-way handshake and save it to a file. Once captured, then this file can be used to launch the password cracking attack. First thing that we need to do is collect some essential information about the target network. We need certain information to hack or test a Wi-Fi network, such as its MAC address and channel number. So type sudo aerotump ng. Now specify name of your monitor mode, which is WLAN 0 MON for me. Now aerotump command is going to discover and display all the available Wi-Fi networks within the range of my wireless network adapter. Press enter. Now keep scanning until your target network appears in this list. As you can see, my target network has already been detected, which is this Sunny. I'm gonna test or hack my own Wi-Fi network. Once your target network gets detected, then you can exit the arrow dump. Now I'm gonna note down the MAC address and channel number of my target network in a file. So let me open a new terminal tab and I'm gonna open nano to note down the details. MAC address and channel number. Let me copy the MAC address. This is the MAC address of my target network, which is Sunny. Let me paste it here. And the channel number is 9. Now we need to monitor the network traffic of our target network. So type sudo space arrow dump ng space 2 hyphens bssid. bssid refers to the MAC address. Now here we need to specify the MAC address of your target network. So what I'm gonna do is copy the MAC address of my target network and paste it here. Now type -c. -c stands for channel. Now provide the channel number where your Wi-Fi network is broadcasting on. Mine is on 9 space. Now specify the write parameter. Write parameter allows us to save the captured packets into a file. Now specify name of the file. I'm gonna specify handshake. The arrow dump is going to save the packets that it captures in this specified file handshake. The file will be saved in your current working directory. Now what basically is going to happen? The arrow dump is going to monitor or capture the network traffic of this particular Wi-Fi network. Then the packets that it captures will be saved to this file called handshake. And of course at the end you have to specify the monitor mode name, which is WLAN0 MON for me. Now press enter. As you can see guys, check out the channel. It is fixed at 9, so it is only capturing all the traffic going through this specified Wi-Fi network, then saving that to the specified file, which is handshake. Now the primary target of this video is to capture handshake, right? So how to capture the 4-way handshake? Either a new device has to connect to the target network, or an existing device has to disconnect then reconnect to the network. So as soon as a new device connects or reconnects to the network, then the 4-way handshake will be captured. Let me demonstrate this. What I'm gonna do is, I am already connected to my network, right? Let me disconnect from the network. Now as soon as I reconnect, the 4-way handshake will be captured. Let me reconnect. Click on connect. As you can see guys, WPA handshake, the 4-way handshake for this Wi-Fi network has been captured. Now we don't need to monitor the network traffic anymore. Once you capture the 4-way handshake, you can exit. Press Ctrl+C to exit out of the arrow dump. Now let me ls. As you can see guys, we have handshake files with different formats like .csv, netxml and .cap. Now the file that we need is this handshake.cap. We need this file to initiate the password cracking process. Before that, we have to actually verify whether the 4-way handshake is valid or not. It can be done using Wireshark. Let me copy the handshake01.cap file. I'm gonna open it in Wireshark. So type Wireshark, paste the file name or type the file name, press enter. Now in the filter bar, type EAPOL, press enter. Now, EAPOL stands for Extensible Authentication Protocol over LAN. It is a network communication protocol used for authenticating network devices. Now, here as you can see, we have 4 packets being exchanged between a wireless device and the Wi-Fi network. We have exact 4 packets. It means the 4-way handshake was successful because a successful 4-way handshake exchanges 4 packets between a wireless device and the Wi-Fi network or wireless access point. Now guys, this 4-way handshake is extremely important. 4-way handshake is required to initiate the password cracking process. Okay, so keep this handshake.cap file safe. We are gonna need it later when we will crack the Wi-Fi password. Now guys, as you can tell, this method of capturing 4-way handshake is not very efficient, right? We have to wait someone to connect to the network or someone to disconnect from the network, then reconnect. It can be time consuming. We will address this problem in the next video. In this video, we will discuss the de-authentication attack, which is essential for capturing 4-way handshake and launching advanced attacks like evil twin attacks. Therefore, it is important to understand how it works. In the previous video, we captured a 4-way handshake, right? To capture 4-way handshake, either a new device needs to connect to the network or an existing device needs to disconnect and then reconnect to the network, right? Here we have an obvious problem, right? In most cases, people are already connected to the network and new client devices may take a lot of time to connect. There you have to wait patiently. Now, to address this problem, we have something called a de-authentication attack. A de-authentication attack works by disconnecting devices that are already connected to the network. In simpler terms, the de-authentication attack kicks off or disconnects devices from the network by sending de-authentication frames to all devices on the network. Once you disconnect devices, most devices reconnect automatically, right? So as soon as client reconnects, whether manually or automatically, the AeroDump-ng captures 4-way handshake. De-authentication frames, as we discussed in the fundamentals section, are used to disconnect devices from the network. How a de-authentication attack basically works: the attackers pretend to be the router or access point by spoofing the router's MAC address and SSID or its name. They then send de-authentication frames to the devices connected to the network on behalf of the router. The attacker uses router's MAC address and sends de-authentication frames to the connected devices. When client devices receive de-authentication frames, they assume the frames are sent by the router or network. They immediately disconnect as soon as they receive the de-authentication frames. And when the user or client device reconnects, the 4-way handshake gets captured. There is no default mechanism to verify whether the frames are coming from a legitimate router or attackers. Only latest 802.11x standard has automatic protection against de-authentication frames by default. That's how de-authentication attack works and is used by hackers. We will continue where we left off in the previous video. In this video, we will learn how to capture the 4-way handshake using the de-authentication attack and also fix the common errors you may encounter during the de-authentication attack. A de-authentication attack serves 2 purposes. 1. Capturing the 4-way handshake, and 2. Disrupting the network services. Now let's dive into the practicals. Make sure that your wireless card is in monitor mode. I have already enabled monitor mode. Let me verify that. Type IP space A, press enter. As you can see, WLAN 0 mon. My card is already in monitor mode. Once your card is in monitor mode, we should be good to go. First thing that I'm gonna do is collect the MAC address and channel number of my target network. We are gonna need both for launching a de-authentication attack as well as monitoring the traffic of my target network, which will help us to capture the four-way handshake. So type sudo aerodump ng space. Now specify name of your monitor mode, which is WLAN 0 mon for me. Press enter. Now keep scanning until your target network appears in this list, and mine has already been detected. As you can see, my target network is Sunny. Press Ctrl+C to exit out of aerodump. I'm gonna note down the MAC address and channel number of my target network. So let me copy the MAC address, and I'm gonna open a new terminal tab. Type nano, and I'm gonna note down the details in this file. Press Ctrl+Shift+V to paste, and the channel number is 5. Now I'm gonna monitor the traffic of my target network. So type sudo aerodump ng space, type PSSID. Now copy and paste the MAC address of your target network. After PSSID, paste the MAC address. Now type C. C is for channel number. Now type the channel number of your target network, which is 5 for me, space. Now type the write parameter. As we already discussed in the previous practical video, it allows us to save the packets that aerodump captures to a file. So specify a file name where you want to save the packets. Four-way handshake. By default, this file will be saved in my current working directory. And the last thing that aerodump needs is the name of your monitor mode, which is WLAN 0 mon for me. So this particular aerodump command is going to monitor the traffic of this specified Wi-Fi network, and the packets that it captures will be saved to this specified file, four-way handshake. Now press enter. As you can see, it is capturing the packets and saving them into the specified file. Now we need to launch the de-authentication attack. So keep this aerodump command running. I'm gonna open a new terminal tab. Now to execute the de-authentication attack effectively, we need to configure the network card to the channel number where the target network is operating. Sometimes you will encounter errors like WLAN 0 mon is on channel N and AP uses another channel. To fix this problem, we need to set the wireless card to the channel number of your target network. So type sudo iwconfig space. Now specify name of your monitor mode, then channel. Now type the channel number where your target network is operating. For me it is 5. This command is going to configure the wireless card to listen on channel number 5 or whatever channel number you specify. It will stick to this specific channel number and won't hop to others. Now press enter, provide your password, and the command has been executed successfully. Now we are ready to launch the de-authentication attack. So type sudo airplay-ng. Now airplay-ng is also part of the Aircrack suite. It is used for generating de-authentication packets or frames. Now space, 2 hyphens, type de-auth. The de-auth parameter allows us to generate de-authentication packets. Now you have to tell de-auth parameter how many de-authentication packets you want to generate. Let's say 100. So de-auth will generate 100 de-authentication packets or whatever number you specify here. Now type A is for access point. Now we need to specify the MAC address of the access point or target network. And let me copy the MAC address of my target network and paste it here. Now type WLAN 0, type the name of your monitor mode. So that's all the Airplay-ng command needs. Now let me break down this entire command. The Airplay-ng is going to generate 100 de-authentication packets, then send those packets to the devices that are connected to this Wi-Fi network or access point. And when the devices receive the de-authentication packets, they will automatically disconnect, and when they reconnect, then the arrow dump is going to capture the four-way handshake, because we are monitoring the traffic of that network, right? Make sure that the arrow dump command is running. Now let me press enter. As you can see, guys, it is sending the de-authentication packets to this Wi-Fi network. Now as you can see, guys, my device has been disconnected. Now what happens if I reconnect to my network? Let me switch to arrow dump. Let me reconnect to my network. Click on connect. Now it is not able to reconnect because the de-authentication attack is still going on. As you can see, as long as this de-authentication attack is ongoing, devices will not be able to connect or reconnect to the network. Let me attempt to reconnect again. Now de-authentication attack will stop after sending the 100 packets. As you can see, it has sent the 100 packets. Now let me attempt to reconnect. Now it should work. Click on connect. As you can see, guys, it has successfully captured the four-way handshake. So guys, that's how the de-authentication attack works. It sends the de-authentication packets to the devices connected to your target network and forces them to disconnect, and when they reconnect, the arrow dump captures the four-way handshake. Now that we have captured four-way handshake, we don't need to arrow dump keep running. So I'm gonna exit it by pressing Ctrl+C. Again, back to the de-authentication attack. The number that you specify after de-auth parameter, it will generate and send those many packets. If I specify, let's say 10,000, then it will generate 10,000 de-authentication packets. Now there is another way to execute the same de-authentication attack. What you can do is specify 0, then 0. Now what Airplay-ng is going to do, the -0 is short for de-auth parameter, and when you provide the value 0, then Airplay-ng is going to send unlimited or infinite de-authentication packets. Let me press enter. Now it is going to keep sending the de-authentication packets unless you stop it manually, right? So to stop this de-authentication attack, you have to exit manually. So press Ctrl+C to exit out of the Airplay-ng. As I mentioned, the -0 is short for de-auth parameter. You can also specify a specific number to it. Let's say 5, 6. It will generate 6 de-authentication packets this time. And it should stop after generating 6 de-authentication packets, as you can see. So guys, that's how you can execute a de-authentication attack. Now let me type ls. As you can see, guys, the arrow dump has generated all these files. The only file that we are gonna need is this file with .cap extension. We will need this for cracking the Wi-Fi password or initiating the password cracking process. This is very, very important. So what I'm gonna do is copy this file to my desktop. Let me copy it, type cp, and now specify the name of the destination directory, desktop. D is in uppercase, press enter. Let me change my directory to desktop. ls, as you can see, here is the file. We are gonna need this file for initiating the password cracking process. So make sure that you keep the four-way handshake file that you captured. In this video, we will discuss several topics, including what a word list is, a dictionary and brute force attacks, and how Wi-Fi password cracking works. Understanding these attacks is essential for both protecting your network from such threats and effectively following the practical demonstrations in the next video. In a dictionary attack, a hacker attempts to crack the password by using a word list. Now, a word list is essentially a text file that contains thousands or even millions of potential passwords. There is a very popular word list called rock.txt. Rock.txt word list contains millions of real-world passwords. The passwords stored in the rock.txt come from multiple sources, such as most commonly used passwords, weak passwords chosen by users, and passwords that were leaked online after a security breach. These passwords are still in use today. Most importantly, rock.txt is not a list of random guesses, but the actual passwords used in the real world. Similarly, all other word lists also use common passwords or those leaked after a breach. Let's briefly discuss how word lists are used to crack Wi-Fi passwords. The tool used for cracking Wi-Fi passwords is Aircrack-ng. Aircrack uses a word list to crack the wireless network key or password. First, we need to capture a valid four-way handshake. Once the handshake is captured, Aircrack-ng uses a word list to perform a dictionary attack. When a tool uses a word list to crack a password, it is called a dictionary attack. The way Aircrack-ng works is it reads passwords from a word list, then hashes each password using the same algorithm as the WPA2 protocol. These hashed passwords are compared to the captured four-way handshake. If a match is found, the password is cracked. Remember, in a dictionary attack, the password can only be cracked if it is present in the word list. If the correct password is not there, the attack will fail. This is a very basic overview of how it all actually works, but it is enough for you to understand how the cracking works. Explaining everything in detail would require a crash course in cryptography, which is beyond the scope of this course. Now let's discuss a brute force attack. A brute force attack involves trying every possible combination of characters or numbers for a password. For example, if a password is 8 characters or digits long, a brute force attack would test all possible 8 character or digit combinations until the correct password is found. Eventually, there will be one correct password among all possible combinations. Aircrack-ng can perform both brute force and dictionary attacks. Dictionary and brute force attacks are different. A dictionary attack uses a pre-made list of common or leaked passwords to guess the correct password. On the other hand, a brute force attack tries every possible combination of characters until the correct password is found. In this video, we are finally going to learn how to crack the Wi-Fi password or initiate the password cracking process. Before we do that, Remember that you need a valid 4-way handshake file to begin or start the password cracking process. I already have captured a valid 4-way handshake. If you already have a valid 4-way handshake file, then we are good to go. If you don't, you need to capture the 4-way handshake first. It is an essential component required for password cracking. Now let's dive into the practicals. I have saved my 4-way handshake file in my desktop. So I'm gonna change my directory to desktop. I recommend you do the same. Switch your directory to where you have the 4-way handshake file saved. Ls, as you can see, here is my 4-way handshake file. Now we are good to go. Type sudo Aircrack-ng. Aircrack-ng, as the name suggests, it is used for cracking passwords or Wi-Fi passwords to be specific. Now Aircrack needs minimum 2 options, a valid 4-way handshake and a word list. So first parameter that it needs is the 4-way handshake. So specify name of the 4-way handshake file. I'm gonna copy it and paste it here. And if you have 4-way handshake file stored in another directory, then specify path to that directory. Since I have 4-way handshake file in my current working directory, I only need to specify the file name. Now second parameter that it needs is the word list that you want to use for cracking the password. Kali Linux has many built-in word lists, and one of them is Roku.txt. Roku.txt is probably the most popular word list in world. So we have to specify the path to Roku.txt. Before we do that, there are a few things that we need to do. Open a new terminal tab. We need to change directory to word lists. So type cd user share. The word lists are stored in this directory called Wordlists. This is the complete path. Press enter. Ls. Here, as you can see, guys, we have roku.txt.gz file. For now, the roku.txt is zipped. In order to use a roku.txt file, first we need to unzip it. Then we will be able to use it with Aircrack-ng or any other Kali Linux tool. To unzip, type sudo gunzip space. Now specify name of the roku.txt.gz file. Now gunzip is going to unzip this roku.txt.gz file. Press enter. It will take a few seconds to unzip. Ls, as you can see, guys, roku.txt file has been unzipped. Now roku.txt has probably more than 1 million passwords. What I'm gonna do is check how many passwords are stored in this roku.txt file. So let me pipe the output of cat command to wc command. So type pipe character. Now wc-l, press enter. As you can see, guys, the roku.txt has over 1 million passwords. No, not 1 million, rather over 14 million passwords stored inside this roku.txt file. I can't view the passwords of roku.txt file because if I open this file, then the terminal will crash. The terminal will not be able to handle these many lines. But what I'm gonna do is check the, let's say, first 10 passwords. It is easy. Type cat roku.txt, pipe it to head command -n, let's say 100. The head command is going to display the first 100 lines or passwords in this file. Press enter. As you can see, guys, these are the passwords in the roku.txt file. There are millions of such common passwords. Now we need to specify path to this roku.txt file in Aircrack-ng. So back to the Aircrack-ng. Now after providing the name of 4-way handshake file, specify W. W stands for word list. Now you have to specify path to the word list. So type /user share /word lists, then roq.txt. Let me resize my terminal a bit. Now Aircrack-ng is going to initiate the password cracking process, and it will use this specified word list. Make sure that you have provided a valid 4-way handshake file and correct path to roq.txt word list. Now press enter. As you can see guys, the Aircrack has started the cracking process. It is currently testing around 550 or 600 passwords per second. But this number can be different and significantly higher for you if you have a high-end computer. As you can see guys, key found. This is what a cracked password looks like. This is the password of my Wi-Fi network. Now I can use this password or key to access my Wi-Fi network or access my cracked Wi-Fi network. Remember guys, the success of a dictionary attack depends on whether the password is in word list or not. If the password is in the word list, then it will be cracked. If not in the word list, then it won't be cracked. Now, passwords that contain only numbers are very easy to crack. In fact, a purely numerical password can be cracked within minutes without any problems. Like this, the numerical passwords are easiest and most vulnerable to cracking. However, if a password is stronger and includes numbers, letters, special characters, uppercase and lowercase characters, such passwords are very hard to crack, often impossible to crack. Even passwords based on common characters can still be vulnerable, but it takes significantly longer time to crack. I know this is very simple. I just wanted to show you how to use a word list to crack passwords. We will use more effective and sophisticated password hacking techniques in the upcoming video. Thank you very much guys for sticking around. In the previous two sections, we have seen how attackers can exploit or hack Wi-Fi networks using various methods, right? Now in this section, I will demonstrate how to detect and protect your network from all possible Wi-Fi attacks. This is the first video of the section. In this particular video, we will focus on detecting de-authentication attacks. The de-authentication attacks are central to both dictionary and evil twin attacks, right? The evil twin attack specifically depends on a successful de-authentication attack to function properly. Without a successful de-authentication attack, the evil twin attack is not impactful at all. Therefore, if we can detect the de-authentication attack, it makes safeguarding the network easier. In this video, we will learn how to detect de-authentication attacks using Wireshark. Now let's jump into the practicals. I'm gonna execute the de-authentication attack on my own network and then capture packets or de-authentication packets in Wireshark. Before we do that, we need some network details to launch the de-authentication attack, such as the MAC address of the target network and the channel number where it is broadcasting on. Now let me scan all Wi-Fi networks around me so I can note down the required details to launch the de-authentication attack. Aerodump ng. Now specify the name of your monitor mode. As you can see guys, my target network has appeared in this list. This is the network Sunny. I want to execute the authentication attack on my network. Now once your target network appears here, press Ctrl+C to exit. Now I'm gonna open a new terminal window and note down the details. MAC address. This is the MAC address of my target network. Now let me note down the channel number where it is broadcasting on. Channel number is 11. Now we need the MAC address if you use the Airplay-ng to execute the authentication attack, and if you use MDK4 then you only need channel number. I'm gonna use the MDK4, so type sudo MDK4 space, specify the name of your monitor mode. Now D is for de-authentication attack, it launches the de-authentication attack. Now -C is for channel number, you have to specify the channel number where your target network is broadcasting on. For me it is 11. Now guys, before I execute this attack, I'm gonna open my Wireshark so we can capture the de-authentication packets. Later we will analyze those packets to identify the attack. And now in this window of interfaces, you will see the monitor mode. Here as you can see WLAN 0 mon. So double click on your monitor mode. And as you can see, Wireshark has started capturing the network traffic. Remember, the Wireshark is capturing all the network traffic. So count for captured packets will easily go in thousands within a few seconds. Now let me execute the de-authentication attack. Let me press enter. As you can see, it is sending a plenty of de-authentication packets per second, over 1000 per second on average. Wireshark is capturing everything. So guys, when you put your card into the monitor mode, you will not be able to identify the de-authentication attack because Wireshark literally captures all your network traffic. Now what I'm gonna do is stop the capturing packets, click on the red button, and I'm gonna stop the de-authentication attack as well. So we literally have over 100,000 packets, as you can see. Now detecting the de-authentication packets among these thousands of packets is very difficult. Here we can use something called a filter. We need to use the filter for displaying only the de-authentication packets. So filter for that is type wlan 0.fc.type underscore then subtype equal to 12. Now in management frames, the subtype 12 represents the de-authentication frames and 11 represents the authentication frames, right? We discussed this in the fundamentals section. Now press enter. This filter will display only the de-authentication frames or packets. As you can see guys, under the info column, these are all de-authentication frames. We literally have thousands of de-authentication frames. So it is certainly a de-authentication attack, right? Remember, a router or wireless access point never sends this many de-authentication frames. In case of some maintenance or troubleshooting, it typically sends maybe 50 or something de-authentication frames. But if the count for de-authentication frame is anything above 50, then it certainly is a de-authentication attack. Now click on any de-authentication packet, and at the bottom let me expand the 8011 de-authentication flags. Now here we have a field called type subtype de-authentication. In bracket we have a hexadecimal number 0x000C. If you convert this hexadecimal number into decimal, you will get 12. Now here we have the transmitter address, which is this MAC address. Now if I go back to my details that I have noted down, as you can see guys, this is the same MAC address. It means the de-authentication frames are coming from this MAC address. This MAC address or device is sending the de-authentication packets. Now this is the MAC address of the target router or target network, but here the router did not send these de-authentication frames, right? It is the attacker who basically masked or spoofed this MAC address, then sent the de-authentication frames on behalf of the network or target network. So guys, that's how you can basically detect the de-authentication frames in Wireshark. This is as easy as that. Now this method of detecting de-authentication attack is not very efficient, because when you put your card into the monitor mode and capture packets using Wireshark, the Wireshark essentially captures thousands of packets, right? The count for captured packets will easily go in millions, and at some point Wireshark will eventually crash if you keep capturing packets for a longer period of time. So in the next video, I will show you an efficient way to detect de-authentication attack.